Welcome back to a new course. In this Data Science Bootcamp, we are going to talk about Python programming language, Pandas, Matplotlib, Numpy, Seaborn, Plotly, and Scikit-learn. So we are going to cover data analysis, data visualization, and machine learning. You don't need to know anything when you are starting to this course. We are going to start from the installation of the Python programming language. If you want to ask anything about this bootcamp or data science, you can write on the comments. I'm going to be replying all of them. So let's start coding. Here I am at the python.org. You can download the Python from here. From just visiting the download section, you can just select the package you want, like you can just press download Python and then you're ready to go. Don't forget to get the download button for your operating system from here. For example, if you are using Windows, you need to select the one with Windows. And this is our second place, our code editor. If you're just learning Python, I recommend you to use this code editor, but you can try others too, but I'm going to be using the Visual Studio Code in the course. So if you download this and use this in the course, it's going to be really good for covering everything in the course. From here, code.visualstudio.com, you can just press download and download this code editor. And after that, you are going to be ready to write your Python programs. And we are going to jump on the code editor right now. So here we are at our screen that when we install the code editor, we downloaded. So from here, you can just visit here, extensions. And then from here, you can install Jupyter, Jupyter Keymap, Jupyter Celtex. They are going to be installed automatically. If you just install the Jupyter, we are going to use a Jupyter notebook on this Python course. Also, you can download the Python and Pylance from here. And after that, you are going to be ready to go. We can just close this extensions page. After that, what we are going to do is we are going to open this page in here. Like I'm just going to click on it on the Explorer. And after that, here is our file base. Like from here, by right clicking or using the upper buttons, I can create files from here. Like I'm going to say right click and then I'm going to choose new file. And I'm going to say first file.py. So here is a Python file. You can create a Python script from here, like you can just write code, you can say blah blah blah, and after that you can just run everything in the file. But in the course we are not going to use that. We have a special file format which is called Jupyter Notebook, which enables us to run cells instead of the full program. Like what I meant by cells, I'm just going to show you. We are going to create another file like notebook.ipynb. And after creating this, you can see an automatic cell came up. And we can just close the other two. Like I'm going to say don't save. I will close the welcome one. And I'm just going to delete this since we are not going to use that. And let's talk about the Jupyter Notebook. In Jupyter Notebooks, you can just add code cells like this and write programs separately. And you can just run them cell by cell. So you can do a lot of things by not running the entire program, which is going to be quite useful in data science. And Python programming. This is going to be a course for Python development, and also it's going to be a base for a data science roadmap. So whether you are trying to learn Python or you are trying to learn data science, this is a great point to start. After learning the Python, you can just learn other things like you can just learn web development, data science, and extend your knowledge in that areas. You can do game development, you can do cybersecurity, etc. You have a lot of options. Great. Now I'm going to delete these code cells, and from the right side I will select a kernel from here. I will say Python environments, and I'm going to select the Python, the most up-to-date version, like this. And we are going to write our first code right now. It's going to be our first program. We will say print, and we are going to say welcome to the course. And I'm just going to run that. If you are using Windows, you can just press Shift and Enter for running the cell and getting a new one. If you are using Mac, you can just press Command and Enter and you can do the same operation. And in here, we just said print and we use the print function for printing something to here. We displayed the welcome to the course in the screen. Another thing we are going to cover is going to be the comments. You can just use the hash character and add like this is a comment. and you can just run this. A comment doesn't affect your program, and it just helps other developers or the ones that you read your code to understand the code better. Like after this print statement, I can just add a comment like, here I added a comment, and after that when I run this, you're going to see it's not going to display this line here because it can be seen only in the development side. Okay, I'm going to show you a feature of the Jupyter notebooks. I'm just going to come in here and I will select the markdown, and after that I'm going to say this is my first markdown, and I'm just going to run this one. And here you can see that I displayed a text in the place that I want, and I can use the markdowns like this for adding comments on the Jupyter notebooks. By the way, following the course by coding, like writing the codes with me, is going to be really helpful on your learning process, and I highly recommend it. If you just see on the screen and don't write them on your code editor or a notebook and anything, if you don't write them, you are going to forget them. But if you write them and do practices by yourself, you are going to learn better. Great, now we will talk about variables and data types. Let's start with the basics. In Python, a variable is like a container that holds data. You can think of it as a label attached to a value. Variables allow us to store and manipulate data in our programs. With variables, also I will show you the type function, just like the print function, which is going to help us on seeing the data type of a variable. Let's say name, and after that for defining a variable I will use a equal sign, and after that I'm going to say my name like honor in quotes. We are going to cover the quotes after this, and I'm going to say type name, and we are going to see that we will get a string in here. So for creating a variable, I will use a name, and after that I'm going to say equal sign, and after that it can be like integer, like I will say age, and after that I'm going to enter my age after that. And when I do that, when I call the age here, I'm going to get the data type of integer right now. The important thing in variable defining is entering a name, and after that using an equal sign. So let's do more examples on this. I'm going to say height, and I'm going to say 185, and I'm just going to run this, and I will call the type of this, and it's going to be a float in here. Let's do one more, like is student, and it's going to be no. So when I define this, it's not going to give error because we don't have something like no, but we can just say false instead of no. We are just going to cover the booleans after this. I'm going to say is student type in here, and it's going to be boolean. Instead of yes or no, we have true and false in Python. In these examples, we have declared four variables: name, age, height, and is student. Each variable has a specific data type: string, integer, float, and boolean. Now we are going to talk about them. We will start with string. The string data type is used to represent text. Strings in Python are enclosed in single or double quotes. So let's do an example with strings. I will say like name again. I'm just going to use single quote, and after that I will say honor, and we are going to see that it's going to be string again. And after defining this, I can use this string in a function like I will say name like this, and it's going to print honor. So what it does is it stores this string in name variable, and after that when I call the name in anywhere in my program, it will return honor for that. Also, you can define strings with double quotes, like let's say message, and after that I will say if you like the course, please like the video and subscribe. And I'm just going to say print message. I will just use it in a function, and it's going to print the message. In this example, we have created a string variable named message, and we just printed it. Strings are versatile and can represent anything from simple words to entire paragraphs. Let's talk about integers. Integers are used to represent whole numbers without any decimal points. They can be positive, negative, or zero. So let's say number is going to be 25. And here it is. When I call the type number, we will get the 25. And when we print the number, here it is. So when I call the type of the number, it's going to return integer. When I print the number, it's going to return 25 because I just defined a variable as number with the value 25. Also, you can just do minus 25, and after that you will get a negative number printed in here. You can just change the variables like this. Like I just wrote minus 25 in number and it updated to minus 25. And after that, if I say number equals to 0, and if I print the number again, we will see that it's going to print 0 instead of minus 25 because we just updated it. Integers are commonly used to represent quantities, counts, or any situation where only whole numbers are relevant. Great, let's talk about floats. The float data type is used to represent numbers with decimal points. Floats are suitable for situations where precision matters. Like let's say height again, and let's say 6'3", 6'4", doesn't matter. And after that I will say type height, and we will get the float in here. And I'm just going to print the height like this. And after that I'm going to see that 6.4 is displayed on the screen. Again, you can use like minus like this for getting negative floats, and you can just use 0.0 for getting something like 0. Here it is. I'm just updating that and running the print statement again. So let's just change this to 6.4 again, and I'm just going to show you a thing. Like we said print height and it's 6.4, but what we can do with print functions is we can use multiple variables or multiple things together in print functions. Like I will say print and I will say height. After that I'm going to add a comma to here, and after that I will say height. So it's going to print height and 6.4 together. So what else you can do is you can just say height string, and you can just say height. You can define a string like this, and after that you can just say print height string, and after that you can use comma, then you can say height, and you are going to see that it's going to run perfectly. Okay, let's keep with the floats. Floats are crucial when dealing with measurements, calculations involving fractions, or any scenario requiring decimal precision. Great, let's talk about booleans. Booleans are used to represent truth values, either true or false. You can think them like yes or no, but in Python we have true and false, not yes or no. They are fundamental for making decisions in your code. Like let's say, is Python great? And I'm just going to say true. After that I will just type the is Python great? And here we get the boolean. So let's print this with the feature we just learned, like is Python great? And I will say is Python great after that, and we will see that is Python great true in here. Also you can delete this and print this by itself. It will print true like this. Booleans are essential for creating conditional statements and controlling the flow of your program. Great, we just learned variables and data types. We have some rules and common use types on variable naming, so let's talk about them. One of the golden rules of variable naming is to use names that are meaningful and descriptive. This makes your code self-explanatory, reducing the need for comments. So let's do an example like name, and let's set this like Clark, and let's say age is 35, and let's say is adult, and it's going to be boolean true. So these variable names clearly convey the purpose of each variable, making the code more understandable. Okay, let's come to the Python's rules on variable naming. We can't start with a number or symbol when we are defining variables. Like I can say 3 variable and it can be like 40. It's going to raise an error. One of the golden rules of variable naming is to use names that are meaningful and descriptive. This makes your code self-explanatory, reducing the need for comments. So let's do an example like name, and let's set this like Clark, and let's say age is 35, and let's say is adult, and it's going to be boolean true. So these variable names clearly convey the purpose of each variable, making the code more understandable. Okay, let's come to the Python's rules on variable naming. We can't start with a number or symbol when we are defining variables. Like I can say 3 variable and it can be like 40. It's going to raise an error. But if I just delete this, it's going to work smoothly. So we can't add numbers. It's same for the punctuation, like minus variable is going to return error. Also underscore variable is going to raise an error. We can't use any symbols in variable naming, like I can say event name and I can just say like basketball match. It's going to raise an error. But with one exception, that you can use underscore in variable naming. Like you can say event and name with underscore and you can just say basketball match. And if you do like this, you are not going to get an error. You are going to create your variable successfully. This is only for the underscore. Also, we have another rule, like be cautious not to use reserved keywords as variable names. Like print was a reserved keyword. It's a function's name in Python. Doing this can lead to unexpected behavior and errors in your code. Like if I try to print and if I just define a variable like print and I say basketball match. And if I just run this, it's going to work smoothly. But when I call the print function, I can have some problems like here. I can't use the print function like this. I will say Python is great in print function. But what happened is we can't use the print function because we defined a variable like this. So try not to do that. But how are you going to change this? From here, you can just say restart. But before that, you are just going to delete these cells. Like I will delete this one. And when I press the restart in here, and I will say restart. And after that, I'm going to say run all. And you will see that it's going to be stuck on the errors. Like we have errors in here and run the others. It's going to run our runtime, every cell, and it's going to stop at the first error at this place. So I'm just going to pass them and I will come to here. We can see that our print function's name is changed, like the color of it changed, and now I can use the print function safely. If you did something like we just did, you can just press restart and you can say restart for restarting the kernel. And after the restart, you can just do things again without the problems. Like you can just use the print function again. So again, we have a function named print in Python. So not using it as variable name will be a good practice. Let's talk about common naming practices. When naming variables, there's 2 common methods and they are called snake case and camel case. This convention ensures consistency across your code base. Snake case gets used like lowercase letters and underscore between the words like this. And the camel case is like uppercase letters for the first letter of the words like camel case. And we can just say for example. From here, we can see that we use underscore and lowercase letters on snake case and we capitalize every first letter for word in camel case. Great. Let's talk about arithmetic operators. Arithmetic operators allows us to perform mathematical operations in Python. These include addition, subtraction, multiplication, division, and more. Let's define 2 variables like number 1 as 10 and number 2 as 5. And let's start with addition. Let's say addition is going to be equal to the number 1 plus number 2. So if we print the addition's value, we will see that it's going to be 15. Also, in a print function, you can just do 10 plus 5, and after that you will see that it's going to print 15. Let's do subtraction. We will say subtraction is going to be 10 minus 5, which we can also do with variables like number 1 minus number 2. And if you print its value, it's going to be 5. Great. Also, I want to show you that In normal Python scripts like the .py extension files, you can just print something with writing print function. But in a Jupyter notebook, if you just write the variable's name like this, you will get its value like you write the print. You don't need to use print every time. Great, so let's get the multiplication right now. We will say multiplication, and it's going to be equal to number 1 multiplied by number 2. And let's see its value. From now on, I'm not going to use print in the most of the topics, and I will just write the variable name. Let's also do division. We will say result division, and it's going to be like number 1 divided by number 2. And let's get the result division. Also, you can do an operation like 10 divided by 5, like strictly like this, and you will get the same result. Since we are in Jupyter Notebook, we don't need to write the prints in the most of the scenarios. Great, so let's talk about exponentiation. We will say exponentiation, and it's going to be number 1 power number 2. And let's see what's its value like. As you can see, 10 with power 5 is going to be 10,000. Great. So in these examples, we have covered various arithmetic operations using two variables, number 1 and number 2. So let's talk about the order of the operations. It's crucial to understand the order of operations, often remembered by the acronym PEMDAS. PEMDAS, and it's like parentheses, exponents, multiplication, and division from left to right, and addition and subtraction. I want to write this for clear demonstration, like parentheses, exponents, multiplication, and division left to right, and also addition, subtraction from left to right. Also, it needs to be like division. All of these are left to right. Let's do an example like PEMDAS. I just read it like PEMDAS, but I'm not sure how it's read, and I will say number 1 plus 3, and let's multiply this with number 2, and let's divide this like with 2 and give the power of 2, and let's see our result. In this example, we have used parentheses to enforce a specific order of operations. The result is calculated following the PEMDAS rule, ensuring that multiplication and division take precedence over addition and subtraction. Python also provides augmented assignment operators, which offer a concise way to perform arithmetic operations and update the value of a variable. Let's see how they work. So let's go like, let's set 0 to total, and then let's use total plus and equal sign together, and let's say 5. This one is going to make our total 5. It's pretty same, like I'm going to add here as comments. I will say total equals to total plus 5. These both are same, like this one and this one is completely same. Let's do like total minus equal sign 2, and let's see the value of total in here. It's going to be 3, and it's same as total minus 2. These are same. So let's do a multiplication like this, total multiplied equal sign 3. Also it's equal to total multiplied by 3, and let's see the value of this like 9. Great. In these examples, we have used the plus equal sign, minus equal sign, and multiplication symbol equal sign operators for augmented assignments. These operators offer a shorthand way to update the value of a variable based on its current value. Okay, let's talk about comparison operators. These operators allow us to compare values and make decisions based on the results. Let's explore the different comparison operators available in Python. Let's firstly talk about the equality operators. It's going to be double equal sign and exclamation mark with equal sign. The equality operators allow us to check if two values are equal or not. So let's say like x is going to be equal to the 5, and let's say y is going to be equal to 10. So let's check like if x is equal to y. So let's say like result 1, and it's going to be equal to the x equals to y. Also we can add parentheses to this. It will both work. I will just show you both. When I run this, when I get the value of this, we are going to see it's false. It returns a boolean. We can also check its type like type result 1, and we are going to see it's a boolean. So let's just delete this type thing, and I'm going to show you if I remove the parentheses, it's going to be the same. So I will just update this one and update this one. This checks if x is equal to y. So great. So at another step, we will see that result 2 is going to be x exclamation mark equals sign, and we will say y. Also we can't add space to there, and I'm just going to run this, and I will say result 2 in here. So it's true. This is like if x is not equal to y. Also you can add parentheses if you want. It's not necessary, but you can do that, and it will work in the same way. In this example, we use the equal to operator to check if the value of x is equal to the value of y. We also use the inequality operator to check if x is not equal to y. Okay, let's talk about relational operators like greater, less than, less or equal to, greater or equal to. Relational operators helps us compare the magnitude of values, whether one value is less than, greater than, less than or equal to, or greater than or equal to another. So let's say like a, and let's say 15 for this, b, let's say 20 for this, and let's check if a is less than b, like let's say result 1 again, and I'm going to say a less than b. So let's print the result 1. True, 15 is less than 20. Great, let's check if a is greater than b. So for that we will say result 2, and I will say a, and then I will say b. And let's print the result 2. It's going to be false, like this. And now we are going to check if a is less than or equal to b. So for that I will say result 3, and I'm going to say like a is less than or equal to b. So I will just get the result 3 in here. It's going to be true. Also you can directly do like less than or equal to b instead of assigning to a variable, but I'm just assigning them to a variable for this to be more informative. So let's check if a is greater than or equal to b. So for that we will say result 4, and it's going to be like a greater than or equal to b, and it's going to be false. Great. In these examples, we use the relational operators to compare the values of a and b in various ways, checking if one is less than, greater than, less than or equal to, or greater than or equal to the other. We can chain multiple comparison operators together to create more complex conditions, like let's say number, and let's set it like 25. And then we can say result again, and it can be like 10 less than or equal to, number less than or equal to 30. So we have two conditions in here, and let's get the result. In this example we use a chaining of comparison operators to check if the value of number is between 10 and 30. This is a concise way to express multiple conditions. So let's see object comparison. The is and is not operators are used to check if two objects reference the same memory location. Let's say variable 1, and let's set 10 to this, and let's say variable 2, and let's set 10 to this too. So we can say like result 1 can be variable 1 is variable 2. And let's get the result of this, like result 1. It is true, since they have the same value, and we can just use is not same like this, result 2, and it's going to be variable 1 is not variable 2. And let's get the result 2 in here, like we have false. In this example, we create two variables, variable 1 and 2. The is operator checks if both variables reference the same object, while is not checks if they don't. Great, now we are going to turn back into strings and we will talk about the string methods. Let's redefine strings. Like strings in Python are sequences of characters, and Python provides a rich set of tools for working with them. So let's create a string variable like greeting, and it's going to be like hello. And after that, what we can do is also let's say like hello Python. And what we can do now is let's see some basic operations. Like we can get the length of this like length function we have in Python. It's a built-in function, and we can say length greeting, and it's 14. This 14 here is the character count, like 5 in hello, 6 space also included 7, 8, 9, 10, 11, 12, 13 and 14. We have 14 in here. We can access to individual elements. Like if you want to access to the first character, we need to say greeting and we need to say 0, because in Python indexes start from 0. Like if you want to reach the first one in all of the scenarios, you need to write 0. So the first index is going to be 0 and the second one is going to be 1. Like is h in here is index 0 and this e in here is the index 1. So if we want to reach to the last character, we need to say greetings, variable name, then we need to open brackets and we need to say 13 since we started with 0. So we are going to have this mark in here. Also, how we can do that is we can just say greeting and say -1 inside of this bracket. And if we do that, we will reach the same result. It will just go from here, this h to left, and take the first one if we say -1. If we say -2, it's going to give us the n. Like this. Great. So it's like the same for the others. If you want to access to element of a, I'm not sure if I talked about it yet, but for a list, tuple, etc., you are just using the variable name and you will add brackets, then you will give the index number. If I didn't talk about the list, tuple, etc., that kind of things, it's just coming in the, I'm thinking like 5 or 6 minutes of this course, and you will see that. You can also slice the strings. Like let's call our string again, like the greeting. Let's say we want to get a substring like 7th character to 13th. And here it is, Python. Let's say if you want to get the exclamation mark too, we can say 14 in here. Great. We can add strings together. Like we can just say greeting and we can say plus arithmetic operator and we can say welcome. And it's going to work smoothly. Like it's going to be like hello Python welcome. You can do that in a print function like greeting plus, let's give it an empty string for a space and we can say welcome. And here it is, our result. But one important thing in here, you can't add numbers to here. If you are adding strings, all the types needs to be string. Like it's going to raise an error. But if I give this 25 like in a string format, not integer, it's going to work smoothly. Like this one in here is not an integer, it's a string. You can also just check the type of this from here for making sure it's string, if it's written inside the code. In these examples, we have covered various basic string operations. We have calculated the length of the string, accessed individual characters using indexing, sliced the string to create a substring, and concatenated strings together. Python provides a variety of built-in string methods that make string manipulation more efficient and convenient. Let's explore some of them. So let's create a string again. Like sentence is going to be like Python is an amazing programming language. And what we can do is we can change the case like sentence.upper method in here. We can see that all the letters are uppercase, and we can do like sentence.lower for getting them all in lowercase. We can find substrings like sentence.find method in here. Amazing. And we can see its index. It's going to be the starting point of its index like 6, 7, 8, 9, 10, 11, 12, 13. And from 13, here is amazing. Great. Also see that after the dot, I can use the methods like from the variable name, and using dot, I can use the upper method in here. You can do that too. You can try different methods like sentence, dot, and after putting dot, you are going to see the list of methods in here, and you can just try different things from here. Let's see replacing. So we can say replace, and after replace, we need to give like, let's say we want to change the amazing with powerful. And when we run this, you are going to see that Python is a powerful programming language. Also, this sentence is not modifying the original variable. Like if I call the sentence again, we are going to see that it's going to be a Python is an amazing programming language. So what we need to do in here is, if we want this to be our original sentence, we just need to do an assignment like we need to say sentence, and we need to reassign the variable like sentence.replace amazing with powerful. And if we do that, you are going to see if we call the original sentence variable, it's going to be changed to powerful. So what we did in here is we just reassigned the sentence with this equal sign. Also, we can count the occurrences like we can say sentence, and we can add dot, and we can use the count method, and we can just give the I in here like this, and it says 2. Let's check them. One in programming and one in is. In this examples, we have used various string methods like upper, lower, find, replace, and count to manipulate the string sentence. These methods offer powerful tools for working with text data. Let's talk about string formatting. String formatting is a powerful feature in Python that allows us to create dynamic and readable strings. Let's explore different ways to format strings. Let's say name, and it can be like Jack, and let's say age, and it can be 30. So we can use f strings. What are they? We can say formatted string, and for creating a f string, we just need to add f before the quote. So I'm just going to create a normal string like this, and I will say hello, my name is, and after that, if I use curly braces, I can insert variables like I can say name, and I will say I am curly braces age years old, and I'm just going to set this and call formatted string. It's going to return hello, my name is Jack and I'm 30 years old. What if we don't put this f or curly braces? It's not going to work like that, and we can't get this in the scenario. So if you want to use f string with curly braces, it's a really nice method for string formatting. Also, we have another one, the format method, like we can say formatted string2, and it's going to be hello, my name is empty curly braces, and I am empty curly braces again, and years old. But after this string and we will say dot format, and we will pass the name and age with the order we want to create. So if I call the format string again, it's going to say hello, my name is Jack and I'm 30 years old. But this order is really important. If you just say age and name, it's going to mix them up and it's going to give something different. So we don't want this. So we need to take care of this order in here. Name, age. Now it's cool. Great. In these examples, we have demonstrated two common ways of formatting strings, f-strings and format method. These techniques allows us to insert variables into strings for dynamic content. Great, let's talk about conditional statements. Conditional statements are a fundamental building block of programming. They allow our programs to make decisions based on certain conditions. Let's start with basic if statement. So our keyword is if in here. Let's set age to 25 and we will say if age is greater than or equal to 18, print you are an adult. And when I'm just making this work, it's going to print that you are an adult. but it's working because this condition is satisfied. This is true, like I'm just going to run this in here and it will return true. But what if it not? So I can just change the age in here to 15 and it's not going to work in this scenario. It didn't print anything. So, okay. In this example, we have used an if statement to check if the variable age is greater than or equal to 18. If the condition is true, the indented block of code is executed, printing you are an adult. What if that condition is not satisfied? We have the keyword else for that scenario. So let's say like age is going to be 15 this time, and we will say if age is greater than or equal to 18, print you are an adult. And we will say else right now. We don't need to give any condition to here. We can say print you are not an adult. So what this does is it checks this condition, it passes it since it is not satisfied in here. After that it comes to here. We don't need to specify any condition in here, and when I run this you will see that we are going to have this else block worked. Sometimes we need to check multiple conditions. This is where the if, which is the combination of else and if statement, comes in play. So let's say like temperature is 28, and we can say that if temperature greater than 30, then print it is a hot day. And we will say now else if elif 20 less than or equal to temperature and less than or equal to again 30, print the weather is pleasant. And we will say else, and it's going to be like print it is a cold day. And here we can see that it's catched by this else if block right now. It checks for the first if, then it passes, it gets caught in the second if. So it doesn't print it's a cold day. If we just delete this, you will see that it's going to print the else block we have, but if we just insert this, it's not going to, because it's going to be catched from this. In this example, we have used elif to check multiple conditions. Depending on the temperature, the program will print different messages. Conditional statements can also be nested, allowing us to create more complex decision-making structures. Like we can say is raining, and it can be like true, and we can say is cold, and it can be like false. So let's say if is raining, print bring an umbrella. And we can say if is cold, then we can say print wear a jacket too. So it's only going to work if this if condition is satisfied. It means that it is true. Like if we assign true to this, like in here, it's going to work. And what we can do is we can say else, and we can say print enjoy the day. So it only printed bring an umbrella because this one worked, this one didn't work because this condition is false, and it didn't get caught from else because it get taken by this if. Like this else is connected to this if statement. In this example, we have nested if statements. If it's raining, the program advises to bring an umbrella. If it's cold as well, it suggests wearing a jacket. If it's not raining, it encourages enjoying the day. For simple conditions, Python offers a concise ternary operator. Let's explore how it works. It's going to be a one-liner, like we can say age 21, and after that we can say you are allowed if age is greater than or equal to 18, else you are not allowed. And it's going to give you are allowed. And we change this to 10, it will say you are not allowed this time. And if we change this to 50, for example, it's going to say you are allowed. So in this example, we have used the ternary operator to assign a value to the variable message based on the condition. It provides a concise way to express conditional statements. Let's talk about for and while loops. We will start with while loop. No, let's start with for loop. I'm going to start with for loop, not while. The for loop is used when we want to iterate over a sequence, a specific number of times. Let's start with a basic example. I'm going to create a list like fruits, and it's going to be apple, banana, and I will say cherry. So after that, I'm going to create my for loop like for fruit, in fruits, print fruit. So how this works is, for every element in fruits list, like for apple, banana, and cherry, it's going to iterate 3 times. It's going to print the element. Like you can just change this fruit as index, whatever you want, but you want to use you need to use the same thing inside the for loop, and it's going to work in the same way. In this example, we have used a for loop to iterate over the fruits list. The loop variable fruit takes on each value in the list, and we print each fruit. The range function is often used with for loops to generate a sequence of numbers. So let's explore how that works. We will say for number in range 1 to 4, print, let's use an f string in here, let's say number, and we can say number. This one in here, the element indexer, and I'm just going to make it work, and we can see that number 1, number 2, and number 3. In this example, we have used the range function to generate a sequence of numbers from 1 to 3. The for loop iterates over this range, and we print each number. Okay, now we can talk about the while loop. The while loop is used when we want to repeatedly execute a block of code as long as certain condition is true. Let's explore a basic example. Let's say that count equals to 0, and I'm going to say while count less than 3. I will say print f string again count, and I will give the count in here. So what I'm going to do in here is I will say count plus equal sign 1. So when I run this, you are going to say 0, 1, and 2. So it works as long as count is less than 3 and count is 0 at the starting point, like in here, and we print that value, but after that we add 1 to count. So it's increasing in every loop, and we get the 2, and we can't get 3 because now there is no equal sign. If we do that, it will also print the 3, and we need to reassign this also, but let's delete this and make them rerun. It works only 3 times because we are increasing it by 1 every time. In this example, we have used a while loop to repeatedly print the value of count as long as it's less than 3. We increment count within the loop. Sometimes we want to control the flow of our loops using break and continue statements. Let's see how they work. By the way, we are using lists like numbers 1, 2, 3, 4, 5. We are going to cover the lists and other data types in our forward video processes, but I'm just using them for giving examples. This means that we have brackets for creating a list, and we have 5 elements in it, like 1, 2, 3, and 4, and 5. They are all our elements, and I'm just using them because it's going to be clearer to cover these concepts with lists, and we will cover what are they in the further processes of our course. Knowing only the list is created by the brackets, and we have 5 elements on it. It can be also strings and multiple random things like apple, 2, 3, cherry, 5. This is also a way to create a list, and we will cover that. Okay, let's give the same example, like create the list like numbers, and we can say 1, 2, 3, 4, and 5. We have 5 elements in it, and if we want to reach to them, we can say numbers and bracket. Let's say we want to reach to the first one, we can just say 0 and we can get the 1 because our first index is 1. Great. So we will cover the lists later on, and we have the numbers list, like you can check the type, of numbers and you will get list. Okay, let's talk about the break and continue. Let's say for number in numbers, if number equals to 3, break, and then print f string number and number. So what it does is it exits for loop when number is 3, and it goes over 1 firstly, then goes in second firstly, and when it comes to the third element, the second index, it quits the loop because number equals to 3. This if statement works on the scenario. Like we inserted an if statement in a for loop in here. So if you want to give an example to the continue, we can say for number in numbers. Again, we are going to loop through this list. We can say if number divided by 2 equals to 1, continue. There's a typo. And otherwise we will say print f number It just kept this 2 in here because 2 divided by 2 is 1. It gets caught by this condition, and we just skip that with continue keyword. So break for exiting the loop, continue for skipping that, and keep going on. Let's do an example with conditions and loops. Like let's loop through a string. So let's say word is going to be equal to the Python. And if you write a for loop on this, it will iterate through P, Y, T, H, O, and N. So we can say like for character in word, we can say character dot lower, and we can print this. Here we get the Python in correct order, and we can also say upper after character, and we will get all uppercase letters in this scenario. So if we use for loops on strings, it iterates over every character. Let's talk about indentation. We can think it like spaces before codes, like this print statement have 4 spaces and I give the space with tab. You can both use tab or space. You can press tab for giving 4 spaces. Python relies on indentation. Let's dive into the details of this unique feature. Indentation is not just aesthetic in Python, it's a fundamental point of syntax. It's used to define blocks of code such as those within loops, conditional statements, and functions. And we already saw examples like inside the for loops, we give indentation for spaces in here, like in the both loops and conditions. Like I'm going to if statements, you can see that we are indenting here, we are nesting this if statement, and we use indentation. It's a really crucial thing in Python, and let's do examples with this. Let's say if true, print this line is indented, and also print so is this one, and we can say outside of this condition this line is not indented. So I'm just going to make this run, and if I say false, we will see that this 2 is not going to work because our condition is false right now. So it will only print this one since it's not indented. But if I say true to this, you'll see that all of them is going to work. Mixing spaces and tabs or having inconsistent indentation levels can lead to a syntax error. So we don't need to do something like if true, and we can say like print this line is indented with spaces, and we can say like print this line uses a tab which is not consistent. They need to be at the same level. Like if I press tab in here, it's going to work, but I used space, 8 spaces in here. After this if enter, I used 4 extra. We generally don't do that. So we need to check the indentation levels. Let's do an example for loops, like for index in range 3. Let's also firstly print this for remembering it. Print index and we get 0, 1, 2. And let's say print this line is inside the loop. And let's say print this is 2. And we can say print this line is outside the loop. Also, let's make this run, and we see that it repeats 3 times this because it's inside the loop. It's going to loop through this 3 times and it prints the outside thing at the end. Let's talk about lists, tuples, sets and dictionaries. I showed you lists like with brackets and 1, 2, 3, 4 example, but we are going to talk about it more right now. We will be using them a lot when we are coding in Python. Understanding these data structures is crucial for effective and versatile. Let's start with lists. A list is a versatile and mutable data structure in Python. It allows you to store and manipulate collection of items. Let's create a list like fruits, and it can have values like apple, I'm going to store strings in it, banana, and cherry. So we have 3 elements. For defining every different element, you can say this comma in here and then create a new element. Like you can insert the variables too inside the lists. Like let's say apple is going to be apple, and you can just use the variable. It won't raise an error in this scenario. It can store variables, integers, floats, strings, any type of data. And here is our fruits list. So let's access to its elements, like let's say first fruit, and let's save it like fruits, and we'll get the first one, the apple. So in Python, indexes start from 0, so we will say 0, and let's print this first fruit, and it's apple as we can see. Also, let's get the last one, like last fruit, and we need to use fruits 2 or -1, and we can just access to this with last fruit. Remember that if you want to go back to the last element and go from right to left, we can use minus. Let's do slicing in the list, like fruits can be like 1 to 3. Remember this bracket and the operations from the strings, they are same. We can check the type of our list, like type fruits, it's going to be list, and let's get the list again. So let's see some more methods, like we can say fruits.append, and we can say grape, and it's going to add the grape to the list like this. And if you want to remove an element, we can say fruits.pop, and let's say we want to remove the element with the index number 2, so it's cherry. And let's call the fruits again. You will see we have 3. We just added grape in here with append and dropped cherry in here with pop method. And in these examples, we have created a list of fruits and demonstrated various operations such as accessing elements, slicing the list, modifying elements, adding new elements, and removing elements. Okay, great. Let's talk about tuples. A tuple is similar to list, but unlike lists, tuples are immutable, which means that we can edit the lists and we can't edit the tuples. Once a tuple created, their elements cannot be changed. Like in lists, we just added grape in here and we dropped cherry in here, but we can't do that in tuples. So let's create a tuple. So what's the difference on creation is, let's say dimensions, and we need to use normal parentheses after this instead of brackets. So if I just say 10, 20 and 15, and I can change its elements right now, but we can still reach to them. Like we can say dimensions, and let's say we want to reach to the first element, I can say 0 and I can get 10, and we can get the last element like this. There's no problem on accessing the elements, and we can just check the type of dimensions like this, and it's tuple. Tuples are useful for situations where you want to ensure that the data remains constant throughout the program. Okay, great. Let's talk about the dictionaries. A dictionary is a collection of key-value pairs, providing a flexible way to store and retrieve data. Okay, let's talk about them. We can create dictionaries with curly braces like, let's say, students, and we can say curly braces, then we can say name, and we need to use this after that, and we can say, let's say, Alice for the name. And after the comma, we can say age, and we can say 22. Then we can define like major, and actually it's a student, not students. For the major, we can say computer science, and we can say is student, and it can be true. So when I call student again, we will see that we will get a dictionary like name and its value Alice, age and 22, major computer science, and is student true. So let's check the type of this. It's going to be a dictionary. It enables us to store keys and values together, and we use dictionaries a lot when we are programming in Python. So how we can access its values, like we can say student, and we can, after that we can say with brackets name, so we will get Alice, and we can do like student age, and it will return 22. If you want to modify a value, like you can say student age, and let's make it 30. So when we call the student again, you will see that our age is going to be 30. And let's say we want to add another thing to here. We can say like student, and we can enter the new data point we want to create, and we can say like A. And when we call the student again, we will see the grade 2. And if you want to remove that, we can just say removed major, and we can say student.pop major. And let's call the removed major. We can see that computer science is removed. And we can call student. We won't see the major right now. Great. In this example, we have created a dictionary representing a student. We have demonstrated how to access values, modify values, add new key value pairs, and remove key value pairs. So let's talk about sets. A set is an unordered and mutable collection of unique elements. It's useful for tasks that involve testing membership and eliminating duplicate entries. For defining sets, we will say like colors set, and we will open curly braces again, but this time we won't give key value type of data. We are just going to create data like tuples and lists. I will directly say the value, and then I will use comma like green. Also, you can give integers like this too. I will say red, and I will say yellow. We can call like type color set, and it's a set. As you can see, we can get the length of this. Also, we can get the length of the lists and tuples. For checking a membership, like we can say is green here, and we can see like green in color set. So we have green in here, so it's going to return true. And let's get the value of the is green here. It needs to be true. Great. Now we are going to talk about a really good feature of Python, which is named as list comprehensions. List comprehensions provide a compact way to create lists, making your code more expressive and readable. List comprehensions allow us to create lists using a single line of code. They are concise and often more readable than traditional for loops. So let's start with a basic example. We can say squares, and we can create an empty list. Then we will say for number in range 5 squares append number in the power of 2. We need to use dot after this, and I will just make it run. Also, let me show you the output of this for loop. Normally I will say print number, and you will see that we will have 0, 1, 2, 3, 4, 5. If I do this, we will see that 1, 4, 9, like this. Great. So we are just adding them into our list, like in here, with append method. Like in every iteration with the append method, we add a value like we add 0, the power of 2, 1, 2, 3, 4, 5, and we add them into the squares list. We created an empty list, and by using the append method, we add the number in each iteration to this list. So in this example, we have used a traditional for loop to create a list of squares. Now let's do the same using a list comprehension. So I will say that squares list comprehension, and it's going to be like number and this for number in range 5. It's syntax. So if I run this and call this, it's going to give the same result, just like the for loop, but in a single line, and it looks really readable, right? When you get used to this, it's a really nice feature and is commonly used on Python programming. Okay, let's talk about nested data structures. Nested structures such as lists of lists or dictionaries of dictionaries allow us to represent complex relationships and hierarchies in our programs. One common form of nested data structures is a list of lists. This structure is particularly useful for representing matrices or grids. So let's say matrix, and we can say like we are going to open a list with brackets, and then for the first element we are going to open a new list, and we will say 1, 2, and 3. So in this side we have an element for the main list, and our element have 3 elements inside. So we have 2 lists in here, and I'm going to create a new one like 4, 5, 6, and I'm going to create a new one. Let me open up a space for that, for a clear vision. 7, 8, 9. So we have 4 lists in here, 1 main list and 3 in the elements. So I will just make it run, and I will just call the matrix. You will see that we have 3 different lists inside the main list. If I get the length of this, it's going to give me 3, since it has 3 elements. Like this. Great. Now we can access to its elements like matrix. Also, let's just delete this. If we want to reach to the first element, the second element, I'm sorry, this one, and I will just run this here, and if I want to reach to this 5, I'm going to say 1 again. I'm just going to add another bracket, and here we have 5. We firstly reached this, after that we reached this. In this example, we have created a list of lists representing a matrix. We can access individual elements using double indexing, where the first index refers to the outer list and the second index to the inner list. Working with nested lists also provides modifying and adding elements. So let's say we want to change this 1 in here, and we want to make this 99. So we can say matrix to first index and the first index of it. So we will say 0 again. Remember, indexes starts from 0 in Python. And let's firstly reach to that. Here it is. And let's set this to 99. And when I call the matrix again, you will see that that value is going to be changed. And we can add a new row, like let's say new row, and we will say 10, 11, 12. And we can say matrix dot append, just like in lists. We can say new row, and we can call the matrix again, and you will see that 10, 11, 12 is going to be added up. In this example, we have modified an existing element in the matrix and added a new row to the list of lists. This showcased the versatility of nested structures. Another powerful form of nested data structures is a dictionary of dictionaries. This allows us to create a hierarchical structure with key value pairs. So we can say like students, and then we can use curly braces for creating a dictionary. And let's say like Alice, and we're going to open a dictionary again, and we can say like age equals to 22, and major is mathematics. and we can just add a new one like Bob, and we can say age equals to 25 and major equals to economics. And let's call this students dictionary. And if you want to access to the Alice's age, what we can do is we can say students Alice, and after that we can say age, like this. In this example, we have created a dictionary of dictionaries representing student information. We can access individual elements using multiple key indexing. Modifying and adding elements in a dictionary of dictionaries follows a similar pattern. Let's see it in action, like let's say student Alice and age, and we can say it like 25, and after that when we reach to this element we will see that it's 25. And let's also update this one, and let's add a new student like new student, and it's going to be age, let's say 20, major physics, and we will say student, let's say Charlie, is going to be equal to the value new student. So when I run this and call the students again, we will see Charlie too. In this example, we have modified an existing element in the dictionary, just like in here, and then we added a new student to the structure. Python allows us to combine various nested structures to represent even more complex relationships. So we can just do like copy this entire thing, and after that we can say people, and we can open a list, then we can paste this dictionary in here. Also, let's fix this. Great. So when I run this, we will see that we will have people, a list, and we can check type of this. It's a list, but we can take the first element of the people and check the type of this, and we can get the first element of this dictionary like 0 and 0. Now you will see that we will get an error because this one was a dictionary and we need to write it like Alice, and after that we will get age and major in here. In this example, we have created a list of dictionaries representing people. We can access individual elements using both list indexing and dictionary key indexing, like this one in here. Great, let's talk about functions. Functions allow us to encapsulate and reuse code, making our programs more modular and readable. Defining a function involves specifying a block of code that performs a specific task. So let's start with a basic example. We have the keyword define, def, and after that we will give the function name, and we are going to open parentheses. And let's say like when we call this function, we want it to print hello Python lovers. Okay, something like that, or we can just write hello. So after defining this, we can call this function in our program like this, just like the type of print function. We can use that. In this example, we have defined a simple function named greet that prints a greeting message. The function is defined using the define keyword followed by the function name and parentheses. We then call the function using its name and parentheses. Functions can accept parameters, allowing them to receive input values. So let's explore how this works. Let's say define greet person, and let's add name in here, and then we will say print f hello, and we will say name. So let's talk about this. Here we give a name in function, and then we use this given name in here. It's not a variable, we just give it when we call function, and we use it in here. Like, let me show you, greet person, and I'm going to write my name, and the name is going to be my name, and we can also change this to Bob, and you will see that the name is going to change. It's not a variable, it's the input of the function. In this example, we have defined a function named greetPerson, that takes a parameter name and prints a personalized greeting. When calling the function, we provide an argument for the parameter, such as greet person Bob. Functions can have default parameter values, which are used when an argument is not provided. This provides flexibility on function calls. Like we can say define greet with default, and we can say name is going to be equal to the Charlie, and we can say print hello name again. And here, if I don't give a name to function, it's going to give like, also we need to use it with parentheses. If we do that, we won't get this print message. We will see that hello Charlie, but we can give it name inside like Bob, and it will print the Bob this time. But if we don't give anything to function, it will just print this default thing, Charlie, like this. In this example, we have defined a function named greet with a default parameter value for name. If no argument is provided when calling the function, it uses the default value. Functions can return values too, allowing them to produce a result that can be used elsewhere in the program. So let's define a function like square and give number inside, and let's return. We have the return keyword for returning values, number, squared version of the number. So when we call this, it's going to give an error because we need to give an input, and when we say 5, it will return 25. Great. So we can just store this like result square 5, and then we can use this in our programs like result. We will get the 25 again. So in this example, we have defined a function named square that takes a parameter number and returns the square of that number. We call the function and use the returned value in the program. Functions can have multiple parameters and return multiple values. Like we can say define calculate rectangle area, and let's say we want to give length and width. And after that, what we can do is, also I wasn't going to make it run, so I can just say clear cell outputs from here, and I will say area is going to be length multiplied by width. Also let's add something like parameter is going to be 2 times length plus width. Actually, I made a typo in here. I'm just going to change that, and we will return area and parameter. So also now we are going to see a different variable creation, like we can say area and parameter, and we can say calculate rectangle area 4 and 6. So when we run this, we will get values for both area, the first one, and we will get a value for both parameter, the second one. You can create variables like this, but if you mix the order of them, it's going to change. So the order is really important on this too. Like if I change their position, you will see that their values are going to change like this. We don't want that. Okay, let's see a function with variable number of arguments. So we can say define calculate sum, and regardless of the number entry, like user can enter 20 numbers, we will say arguments in here. We will say total, and we have a function like sum for getting the sum. We will say arguments, and we will say return total. So here we can say calculate sum after creating this and give 1, 2, 3, 4, 5, 6, 7, 8, and a lot more, and it will return the sum of this. You can just delete some of them and it will work the same, like this. In this example, we are defining a function named calculate sum that accepts a variable number of arguments using the argument syntax. This allows the function to handle any number of input values. I'm just repeating everything after each operation for this course to be more informative. Let's talk about lambda functions. Lambda functions are a concise way to create anonymous functions in Python. They are often used for short, one-time operations. We can define them in one line. Like we can say square, and we can say lambda x, and 2, like this. And after that, we can just use like result is going to be square 4. just like the regular function. Here it is. It works exactly same as the function we defined. Let's talk about modules. In Python, a module is a file containing Python definitions and statements. These files can define functions, classes, and variables that can be reused in other Python scripts. We have a keyword import for that, and we are going to, let's say, import the random module. And after that, we can use its attributes, functions like I will say random, and I will use random integer, and I will give it a range of 1 to 10. Also, you can see at the upper side, it returned random integer in range, including both endpoints, and it shows the inputs of this. And I will say enter, and it just returns a random number. It will change every time when you run the cell, and it's a nice module that you can use a lot in your programs. After the import of the module, you can use its attributes like this. In this example, we have imported the random module using the import keyword. The random module provides functions for generating random numbers. We use the random integer function from the random module to generate a random integer between 1 and 20. You can also import specific functions or classes from a module, reducing the amount of memory your program uses. Like you can say from random module import choice and shuffle methods. And after that, after this import, you can use this too, but you can't use others if you import it like this. Like let's say my list is going to be 1, 2, 3, 4, and 5. And if you want to make a random choice from this, we can just say random.choice or directly choice. Since we import it directly, we can say my list, and it will give it a random choice from this. If you do like random.choice, random.random integer, you will be using this. If you directly write choice, you will be using this because you are importing this one directly. And you can use shuffle like this, and it's going to be like it will change its order. You can just print this for seeing. It will just update the original list. Like when you do shuffle, it won't work with print because it will return none. If you use shuffle my list, it's going to be shuffled, and you can just call this again, make this run again, call this again. It's just going to change the order of your list like this. Okay, so in this example, we have imported specific functions from the random module. We use a choice function to pick a random element from a list and a shuffle function to randomly rearrange the elements in the list. Sometimes module names can be lengthy. You can use aliases to create shorter names for modules, making your code more concise. So what I'm talking about is, I will say import random, we have a keyword as, and we can say R&D. And after that, I can just use random as like R&D. I can say R&D, and then I can use its features like random integer 1, 5. So here it is. If I import it like this with as keyword, I can use R&D after that. In this example, we have aliased the random module as R&D. This allows us to use the shorter name R&D when referencing functions from the random module. Python comes with a variety of built-in modules that provide essential functionalities. Let's explore one of them, the math module. Like we can say import math, and after that we can say math, and we can use its functions. Like you can just scroll in here and see. So I will say square root, and I will say 25. Also we can do like math.factorial 5, and we will get 120. Great. In this example, we have imported the built-in math module and used functions like square root to calculate the square root and factorial to compute the factorial of a number. Great. Let's talk about classes and objects in Python. It's going to be our last topic for this course. In Python, a class is a blueprint for creating objects. An object is an instance of a class, and it can have attributes and methods. Attributes are the characteristics, and methods are the functions. We will also talk about object-oriented programming. Object-oriented programming is a style of programming characterized by the identification of classes, of objects, closely linked with the methods with which they are associated. So you will understand better, it's just a definition, and we can start to learn about them right now. I will create a class. We have a class keyword for creating classes. I will create a class as dog, and its syntax is like define. Then we need to use init in here. It's a common thing for literally every class. We will say self, name, and age. We need to use this self too, and after that we can just use like self.name is going to be name, and self.age is going to be age. And this is a characteristic of this, and we can just define a function like define bark, and we can say self, and we can just use print f self.name says woof. Here it is. So we have a characteristic in here and method in here. So great. Let's talk about this. In this example, we have defined a class named dog. The class has an init method, which is a special method called a constructor. The constructor is used to initialize the attributes of the class. We have attributes name and age. Additionally, there is a method named bark that prints a bark message. Once a class is defined, we can create objects from it. Objects are instances of the class, and they can have unique values for their attributes. So we can do like dog1, and we can use dog class, let's say body, and let's say tree. The name is going to be body, like in here we need to give it in the same order. We don't care about the self in here. Name is going to be body, and age is going to be 3. And also let's say dog2, and we can say dog max, and we will give 5 in here. Actually I need to add parentheses, not brackets. Great, it looks better. Now we can call these characteristics like dog1 dot name is body, dog1 age is 3, dog2 name is max, and dog2 age is 5. Now we can use this bark method with 2 of these, like we can say dog1 dot bark, and after that we will see the method bound method dog.bark, and if we add parentheses after this, we will see that body says woof. This function, like let's delete them and see it clearer, and if we say dog2.bark, we will see that max says woof. So this is how we create classes and use them. We can talk about inheritance and other features of the class, but I'm not going to include them in this tutorial for this to be simple and not more complex. If you want to just see them, you can just visit my YouTube channel, and I have a full video of classes. It was like a 7 minutes, and I show everything about classes on there, so I'm not going to include in this tutorial because it's going to be literally complex. I'm going to open my terminal, and I'm going to say pip3 install pandas. Sometimes it works with pip, not pip3, so you can try that if it's not working. And when pandas is installed, we can close our terminal and we can start to our course. This statement allows us to access all the functionalities provided by the pandas library throughout our code. After the installation is complete, you can verify it by importing the pandas library in a Python script or a Jupyter notebook. We are going to use a Jupyter notebook for this course because seeing things cell by cell is more educative and informative, I think. I generally prefer using Jupyter notebooks when I'm coding. Okay, we are going to import our library. We are going to say import pandas, and we will say pd. This line of code imports the pandas library with the alias pd, which is a common convention among the pandas community. You can also check the version of pandas that you have installed by running this command. You will say pd, and you are just going to say version with 2 underscores, and you can see the pandas version. This command will display the currently installed pandas version on your system. Now let's explore the process of creating a pandas series. At the first steps, when we are creating series and data frames, I'm going to create them manually by writing, but after, when the times go over with the course, I'm going to just make copy pastes for the data creation for making this course short and more efficient. So, what is series? A series is a one-dimensional array-like object that can hold various data types, including integers, floats, and strings. So let's say my series, and we are going to say PD, we will use series. You need to use capital letter for the S, and we are going to give values like 10, 20, 30, 40, 50, and we are going to set index here, and let's set index like A, B, C, D, and E. And now we can get our series displayed. This will create a series with the provided data and display it on the screen. So let's check its type like type my series, and you are going to see that it's going to be series object. You can also specify custom indices to label your data points, enhancing the accessibility of the series. Pandas series support both label-based and position-based indexing. You can access specific elements for a range of elements using their labels or positions. For example, let's access our elements by label. So for that we will say my series, and with using brackets we are going to say, let's say we are going to take the value of the index A. And as we can see, the index A has the 10 value. So let's slice elements by label. We are going to see this in more detailed version in a second in the course. So let's say B and let's say D. This time we are going to take elements from B to D, including both. These operations allow us to extract specific data points or subsets from the series efficiently. Pandas series facilitate element-wise operations, allowing you to apply arithmetic operations to the entire series at once. So, for example, let's firstly call our my series, and then let's say we are going to add 1 to every element. So we will say my series plus 1. Like, it's this easy. We can add a constant value to the series this easy. Also, let's do a multiplication like my series multiplied by 2. And also we can do division like my series, and we will say divide by 2. Here it is. We can do a lot more with series. So let's display the data type of the series elements. So we will say my series, and this time we are going to use data type. And here it is. We have integers in our original series. Like, let's just display it like this, and you can see that we have integer values. Also we can check it like, let's reach to the first element we got, and let's check the type of it for seeing if it's integer. And we can see that it's an integer. Great. We can determine the size of the series. We need to use my series, and we will say size this time. And it's 5 because we have 5 elements in our series. Here it is. We have 5. We can get the shape of the series. Like, we can say my series dot shape. Here it is. Understanding the data type, size, and shape of your series provides valuable insights into the nature and structure of your data. Pandas series offer a wide range of methods for efficient data manipulation and analysis. Let's explore some of these methods. For displaying the first few elements of the series, we can use .head method. You are going to see this a lot when you are using Pandas, and when we use that, it displays 5 entries, but you can see the difference like with this because we only have 5, and in the parentheses, if you say like 3, you are going to display 3 elements. Similar to that, if you say .tail after series, you are going to get the last items, but let's say 2 this time inside the parentheses, and you will get the last 2 elements. Also, you can get the descriptive statistics for the series if you have numeric values. Like, we can say my series.describe, and let's just run this. You are going to see that we have the count, mean, standard deviation, minimum value, quartiles, and the maximum value here. So what else you can do is you can just say my series, let's call it, and you can say sort values, and this is now sorted in ascending order. For sorting in descending order, you can just say ascending, and you will need to set it as false, and when you do that, you are going to see that it's going to display the series in a descending order. These methods enable you to quickly gain an overview of your data, facilitating a deeper understanding of its characteristics and distribution. Now we will focus on creating data frames, a key data structure in the Pandas library from various data structures. This is going to be the thing that you will see most as the data type when you are working with Pandas or in any data-related operation. Understanding how to efficiently construct data frames is crucial for handling and analyzing complex datasets. Let's start by creating a data frame from a Python dictionary. So let's create a dictionary like data, and we will say name. By the way, I'm going to say this again. I'm doing it manually because we are just starting to the course. After that, I'm just going to make copy pastes for these operations. Emily, let's say Kate, and let's say Sam. Then we can do age, and we can say 25, 30, 28, and 35. And let's say city in here, and we can do New York, and let's say San Francisco and Chicago, and what else we can say? Let's say Seattle. And here is our dictionary. We can see our dictionary have name, age, and city. These are going to be our columns, and John, Emily, Kate, Sam, 25, 30 are going to be our values. So for creating a data frame from a dictionary, we are going to say data frame equals to pandas.dataframe, just like series, but you need to use capital letters on both D and F, and then we are going to say data. It's this easy, and when we call data frame like this, we are going to see that our data frame is going to be created. This code snippet demonstrates how to create a data frame from a dictionary where keys represent column names and values represent the data in each column. So let's talk about it. We have indexes in here like 0, 1, 2, 3. We have columns name, age, city, and we can see our values in here. You can also construct a data frame from a list of lists. Consider the following example, like we can say data list, and we are going to open a bracket for creating a list. Then we are going to create another list inside, like let's say John, and let's just do the same with the upper one, John, and 25, and New York. And let's do Emily. Also, we need to create a new list for this, so I'm just going to close this one. Then I'm going to say new list, Emily, 30, and San Francisco. And then what else we can do is we are going to create a new list like this. We will say Kate and 28. Normally I wasn't going to write all of them, but just for showing you that both methods are same, I'm going to do that. And at the last part we will say Sam, 35, and we need to add Seattle to that. Seattle. Okay, great. Now we have our list in here. Let's just call data list and see what it looks like. It looks similar to these values, right? We just need to give columns to this. So let's say we will use like data frame list, and I'm going to say pandas.dataframe, and I'm going to say data list is going to be the values that my dataset is going to be created on. Then I'm going to say columns, and I'm going to give them their name. Like we can say name, we can say age, and we can say city. And when we run this data frame list, you're going to see that it's similar with this. Actually, they are not similar, they are same. When we call data frame, they are both same. Using this method, you can customize the column names and explicitly define the data structure. Pandas also enables the creation of data frames from Numpy arrays. So let's do that. Let's import Numpy as np, and Numpy is really popular if you are doing a data related thing in Python. Let's create an array like numpy.array, and we are going to say two brackets 1, 2, 3, and 4, 5, 6, and let's say 7, 8, 9. I think it's enough. And when we call our array like this, you're going to see that we have this array. And what else we are going to do now is we are going to say data frame array, and we will say pandas.dataFrame again, just like in the lists. We are going to say data array, and we are going to say columns. We will say A, B, and C. And let's call our data frame array. So here it is. We have our data frame right now. Also, you can check type of the data frame, like you can say type, and you are going to see it's a data frame. Here it is. So we said columns in both list and NumPy array, but we didn't say it in the dictionary side. That's because in the dictionary side we are giving these labels, like these are going to be columns, but in the other ones we don't have them. Like in this list we have nothing like name, and in this array we don't have anything like A, B, and C. So with this method you can easily convert NumPy arrays into data frames. Now we will explore the process of loading data from various file formats such as CSV and Excel into Pandas data frames. Understanding how to efficiently import external data is essential for real-world data analysis tasks. Let's begin by demonstrating how to load data from a CSV file. So since we changed our data frame a little bit, like we didn't change what we used other ones, I'm just going to make a copy paste again for creating the data, and seeing this again and again will help you on remembering the codes. So I'm just going to create a data frame like this. We have a dictionary name made city, same dataset, and I'm just going to run this, and here is our data frame again. So I'm just going to open Explorer from here, and you are going to see that we have no files in here, and I'm just going to write my data frame to a CSV file, and then we are going to see that our file is going to be in here. I'm going to say dataframe.toCSV, and I'm going to say example.csv, and we need to set index equals to false if we don't want these indexes to be written on our CSV file. I don't want that. I generally don't use that. And when I run this code, you are going to see that my example CSV is going to be displayed in here. So let's check how it looks like. I'm just going to click on it, and you can see that we have name 8, city John 25, New York, Emily 30, San Francisco, etc. I actually made a change. I'm just going to reverse it. And so great, we've written our data frame to a CSV file safely. But what if you want to read it back or read it from another data file? You are going to use this command a lot. We are going to say data, and let's just use PD. We are going to use read CSV, and we are going to say example.csv. And when we use that, and when I call the data, you are going to see that we are going to have the same data frame. Actually, we have this space in here. So if we change it from the original CSV file we are reading and save it like that, you are going to see that it's going to be fixed in here. So my file is not saved, I think. I'm just going to make command and S for saving that, and now it's going to be fixed, I think. Yes, great. This example demonstrates how to create a data frame, save it as a CSV file, and then read the data back into a new data frame. Next, let's explore loading data from an Excel file. It's also a thing you are going to do a lot when you are working with data. So again, we need to write it to an Excel file. So I'm just going to say data frame. We are going to see our data frame again. I'm going to use to Excel this time, and we are going to say example, and we need to write XLSX or any other Excel formats. I don't remember any of them. And I'm going to say index false again, and we are going to say example.xlsx is going to be in here. And then when I click on that, I think I don't have any Excel viewer in my VS Code. So I'm just going to try open anyway, and it's going to show a different thing. Okay, but I'm just going to show you this file in a second. So here's my Excel file that I just created. So in the original data frame we have this space, as you can remember, and now we can see our data frame is in an Excel file format. So I'm just going to jump back into the VS Code right now. So what I'm going to do right now is I'm going to say data Excel, and this time I'm going to use read Excel command, and I'm just going to say example data.xlsx. And when I call this data.xl, you're going to see we have this original data frame again. Also, since this looks bad, I'm just going to do like rename, and we are going to say columns, and let's say age, and actually the original name of it is like this, and let's say age instead of this without spaces. And I'm just going to run this one, and it's going to look better. I'm going to show you these methods in the later stages of the course. It was just fixing for the visual thing. So we can close this. Okay, this code snippet showcases the process of saving a data frame to an Excel file and subsequently reading the data from the Excel file back into a new data frame. Pandas also supports various other file formats, including JSON, SQL, HTML, and Parquet files. You can utilize appropriate methods such as pd.readJSON, readSQL, and readHTML to load data from these formats into a data frames. Now we will delve into the basic operations that can be performed on Pandas data frames. These methods are the ones that you are going to use a lot when you are doing a data analysis. Application. Understanding how to view data, select specific rows and columns, and apply filtering techniques are essential skills for effective data manipulation and analysis. So let's just create our data frame again with the same code. I'm just going to recreate it in different sections for remembering the data frame and showing you this data creation code. And let's start by exploring how to view data within a data frame. So for displaying the entire data frame, you already saw that we can just write data frame in the Jupyter notebook and you will see the same. So we just use the head method with a series, and we can just use data frame.head like the series one, and it's going to display the first 5 rows of the data frame, and I'm just going to write 2 in here. So you're just going to see the John and Emily. So we also have tail like in the series, and let's just change this 2 with 1 for getting the Sam in here. Great. These commands will allow you to view the entire data frame as well as the first and last few rows, providing an overview of the dataset. Pandas provides various methods for selecting specific rows and columns within a data frame. So let's make example with this. For selecting specific columns, we can just say data frame, we can use 2 brackets, and we can just say name and city. And you are going to see that we are not going to get age when we run this code. Here it is. So you can also select one column like this, and we are going to get the name values in here. But there's something important, that if you use this with 2 brackets, it's going to return a data frame. Let's just quickly check this. When you use that, it's going to return a data frame. And if you just remove the one of the brackets from both sides, like if you delete this and delete this, and when you do that, you are going to get a series. So if you do type on this, you are going to get the values inside of that column as series, just like in here. Also, let's just filter with 2 brackets again. For getting a data frame, I'm just going to show you another method. I need to put a bracket on there, and when we run this, we are going to get a data frame in here. If you want to get these values, you can just use .values after that, and you will get the values like John, Emily, Kate, and Sam. Actually, I think I need to remove the parentheses after that, and here it is. We got an array of that values. Okay, with that being said, let's call our data frame, and let's just say we want to select specific rows based on conditions. Like, let's pick the entries, rows when I say entries, with the age greater than 28. So what we are going to do is, we will say data frame, we are going to open brackets, then we are going to put our condition in here. I'm just going to say data frame age, we are selecting the column values like this, and I'm just going to say greater than 28. And when I run this, we are going to get the ones which is greater than 28. Actually, Kate is 28 years old, so if we just put a Q sign in here, we are going to get the Kate also. These operations enable you to extract specific subsets of data based on your defined criteria, facilitating targeted data analysis. Let's do some operations with these. Also, we will see more filtering operations you can use. I will explain them briefly in the next parts of this video. So let's filter our data based on a specific condition again, like let's say data frame, and we are going to say data frame, let's use name this time, equals to John. And here we got the entry with this information. Also, you can just say Emily like this, and you will get the Emily this time. Okay, so what else we can do is we can filter our data using multiple conditions. Like what we can do is we will say data frame and we will use brackets again. And for each condition, we need to put parentheses, and we are going to say data frame city equals to New York, and we are going to use the AND operator after parentheses. And I'm just going to open a new one, and let's see which entry lives in New York, and let's just say data frame age is less than 30 for getting the John. And here it is. Also, if you just change this to 20, you are going to see you will get nothing because one condition here is satisfied, but the second condition is not satisfied, and we are using the AND operator. So we need to get both conditions true for getting that entry. Okay, let's filter rows using the isIn method. So I will say, let's say selected, actually let's call data frame again for remembering it. I will say selected cities, and I'm just going to say New York and Seattle. And I'm just going to filter the data like this. I will say data frame city, and I will use isIn method. Then I will say selected cities, and you are going to see we get the selected cities. We can change this like Chicago, and when we run this, you are going to see the filtered entries are going to change. We can also filter rows using string methods, like let's say data frame and let's say data frame name, and we will use that string. Then we will use starts with method, and let's just say J for getting the John. Here it is. We filtered rows where name starts with J. Also, we can change this like K for getting the Kate. Great. We can also select specific rows based on index values. Like let's just call our data frame again. You can see these are our index values. Like John has the index 0 and Sam has the index 3. For that, we will use data frame.ilog. I also have a specific part in this course for this log and ilog. You can just watch right now and you are going to understand how it works. After that, we are going to say 0 and 2. We get the indexes 0 and 1, but not 2. This is not included. It's like 0 to 2. Also, let's use log. Since I talked about it, we can just say data frame log, and we can just use data frame, and I will say age, and I will do greater than 28. Let's say you don't want to get the entire columns with this. You can just select like name and city from here. Like you will not get the age after this. Here it is. These examples illustrate different ways to filter data within a Pandas data frame based on specific conditions and criteria. Incorporate these techniques into your data analysis workflow to efficiently extract meaningful insights from your datasets. We are going to talk about them more in the video. Now we will focus on handling missing data within Pandas data frames. Dealing with missing values is a crucial step in data processing and analysis, and Pandas provides several techniques to address this issue effectively. Before we delve into handling missing data, let's first identify the missing values within our data frame. So we are going to take the help of Numpy for creating missing values. We already imported it, but let's just import it again. Import Numpy as np, and how we can create missing values in Numpy is we can just use numpy.nan, and it creates an which we can also refer as missing value. So I'm just going to make a copy paste again, and in here we have missing values in every column, as you can see. And for checking missing values, you can just say data frame and is null like this, and you are going to see you are going to get booleans for each value in here, and if it's a missing value like in this one, you will get true, otherwise you will get false. This will help us identify the locations of missing values in the data frame. If you want to see the counts, you can use .sum after it. Like you can just say data frame is null, and after that you can use .sum and you will get the counts. Like we have 1 in A, 1 in B, and 1 in C, as you can see. One approach to handling missing data is to drop the rows or columns containing missing values. Also, if you are going to do any type of change in dataset that you want to change after now, you either need to use in place or reset it. I will show it to you in a second. So let's just keep with dropping the NA. If you want to drop the values that you don't want to use, you can just say drop NA, and it's going to drop the entire rows which contains NA values. Like we have NA in the index 3, index 2, and index 1. You're going to see this 3 is dropped and we only get the 0 and 4. But when you call the original data frame, you are going to see that these chains are not set in the original data frame. Like we have the indexes 1, 2, and 3. If you want to save it, we can basically use in place equals to true after the drop NA. So what we can do is we are going to say data frame.drop NA, and we will use in place equals to true inside the parentheses. And when we do that, we are going to see our original data frame is going to be updated. Also, we have another way for this. Let's just recreate our data frame, and we can just use data frame drop NA like this. You know, this is not going to change our original data frame, but if you reassign it to the data frame like this, df equals data frame.drop NA, you are going to see that you will have a data frame without non-valued rows like this. Great, let's recreate the dataset with NA values and see other dropping methods. Here we have the data frame with NA values. Let's drop the columns with any missing values. In our case, all of our columns is going to be dropped because we have null values in 3 of them. So we will say data frame.drop NA, and this time we are going to say access equals to 1 in the parentheses, and you are going to see that we have no columns left. So if you change this to 0, you are going to get rows deleted 1, 2, 3. Access 0 is rows and access 1 is columns. You can remember that for the future usage. Also, you can drop rows with a threshold of non-missing values. Like if you say data frame.drop NA and you will set threshold as 2, you are going to see that none of are going to be dropped because there is no 2 NA values in a row. Like if you just change this numpy.nen with this one too, and you are going to see that right now. I'm just going to call the data frame again, and I'm just going to show you the A and B is NA for the 2, and when I run this, it's going to drop the row 2. So if you just do like 1 in here too, let's just say 3 for displaying it again. You can see 1, 2, 3 is dropped right now, and you can just say 1 like this and you will get none dropped. Great. These methods allow us to selectively drop rows or columns containing missing values based on specified conditions. Another approach is to fill in the missing values with appropriate data. So let's do some examples with it. Let's call our data frame again, and you will see that we have NA values right now. And let's just say data frame.fill NA, and let's just use 0 for filling the NA valued rows with 0. You can see our NA values are 0 right now, but it's not originally modified on the data frame. So if you want to do, you can use in place equals to true, but I'm not going to do that because I'm going to show you more methods of filling, and here it is. So let's just move into the next one. We are going to fill the missing values with the mean of the column. It's commonly used for filling the missing values. Also, median is commonly used. I'm going to show you that too. We will say data frame.fill NA, and we will use data frame.mean, and you will see that our NaN values are going to be filled with the means of the columns. Also, for the median, you can just use data frame fill NA, and you will see data frame. median. And when you use that, you are going to fill the NA valued rows with the median of that column. Like the median value of the B column is 9, like in this case, the NA values are going to be filled with the median right now. Also, you can use different aggregation functions like maximum or minimum with fill NA method. Also, we have a filling method like forward filling. I'm just going to show you that. You will say data frame fill NA, and we will say method is going to be equal to the forward fill right now. What this does is, I'm going to show you with the original data frame right now. It just fills the next value with the upper value, like this is 6 in here, then NA comes, it fills this NA with 6. And for the other, it just checks, for this, it checks this one, B1, and then it fills B2 with 6. Also, we have something like backward fill, and when you do that, it's just the reverse of it. It just checks this value, and the below value is 9, so it fills this one with 9, and then it checks for the B1, it checks for B2 for the B1, and it just fills it with 9. These techniques provide flexibility in filling missing values with meaningful data, ensuring the integrity of the dataset. Now we will focus on data manipulation using the powerful log and ilog methods in Pandas. Understanding how to effectively use these methods is crucial for performing advanced data operations and analysis within data frames. Let's start by exploring the log method for label-based indexing. So I'm going to create an example data frame again, and we are going to work with this right now. Let's access a specific row. For that, we will say dataframe.log, and let's say A. And here it is. So we got the 1, 6, and 11 from here. Okay, let's access to multiple rows. So for that, I will just say A and B, like this. Actually, I need to use this instead of comma, and this time it's going to work. Now we have 1, 6, 11, and 2, 7, 12. This is for slicing rows. So if you say C in here, you are going to get the values between them, like this. And for selecting multiple rows, like the old example, we need to use comma, but we need to use 2 brackets. Like we can just use 2 brackets for accessing multiple rows, like this. Also, you can just pick like E with A. You don't need to get the between values. Like in this example, we get this one and this one. Okay, let's see the accessing to specific rows and columns together. So for that, we got the A and E here. So, and let's just say we want to get B and C as the columns, not A. So for that, we can say B and C, like this, for getting that information. Here it is, we didn't get the A. Also, you can just change this as A, and you will get the A instead of B. These operations enable us to select specific rows and columns based on their labels within the data frame. Now let's explore the ilog method for position-based indexing. So I will just say data frame for the ilog part, and I'm going to say, like, let's just say we want to access to the first row. So we will say data frame.ilog, and we will just say 0 in here. Here it is. Don't forget that indexes start from 0 in Python. Like if you want to get the first of this, you need to use 0, and if you want to get the second, you need to use 1 instead of it. Okay, let's see the accessing to multiple rows. Let's just say 0 and 2, and we need to use double brackets like this. And when we run this, we are going to get the 0 and 2, A and C. Here it is. Let's see how we can slice the rows. I'm just splitting one of the brackets, and I will say 0 to 3. It gets 0, 1, 2 indexes, but not the 3. Remember it like 0 to 3, but not 3. And for the accessing specific rows and columns, we can just use, let's just say, we will use double brackets 0 and 2, and you are going to remember that we get A and C, and this time, like the log 1, I will use comma, then I'm going to say 1 and 2 for getting the B and C. And if I just change this to 0, we are going to get the A again instead of B. These operations allow us to select specific rows and columns based on their positions within the data frame. Now we will delve into advanced techniques for conditional filtering and querying within the Pandas data frames. Mastering these methods is crucial for extracting specific subsets of data and performing complex analysis on datasets. Let's start by exploring conditional filtering using Boolean indexing. Before that, I need to make a copy-paste from my clipboard like this for creating a data frame. You're going to remember this data frame. Here it is. Let's filter the rows based on a specific condition, like you are going to remember this one. We will say data frame and we are going to open brackets, then we will say data frame age, and let's say like less than 32. And here we dropped this row Sam because his age is 35. And let's apply multiple conditions like we did earlier. I will say data frame city, and also I need to use data frame brackets before this, and we are going to say city is going to be equal to the Chicago. Also we need parentheses. Since we are doing multi-condition filtering, we need to use open and operator, then we need to open parentheses. Then we are going to say data frame age less than 30, and we will get the Kate in here. Remember that if we just change one of this like Chicago with New York, you are going to see that we are not going to get any results because actually both conditions are true for the John. Let's just say age less than 24. We are not going to get any returns right now because one condition is satisfied for John, but the other one is not satisfied. So it returns nothing since we are using AND operator. These operations enable us to extract specific subsets of data based on complex conditions within the data frame. Pandas provides the query method for advanced querying, and if you are familiar with SQL, you are going to love this method. Let's just use query like dataframe.query, and we will say age greater than 28. When we run this, we are going to get the ones with the age greater than 28. Also, we can use the query method using multiple conditions like the old one. Let's just say data frame query, and we will say age greater than 28, and let's say and city equals to San Francisco. Actually, we need to use quotes like this for this to run because it's a specific value. We need to put it before the city name, and when we run this, we are going to see we got the Emily. But if you want to say like I want to get the entries which satisfies either this or this condition, you can just use or instead of the and you will get the everyone which satisfies one condition from here. Like Sam is at the age of 35, so it came, but it's not living in San Francisco. You can also query with arithmetic operations like let's say dataframe.query, and we can just use like age multiplied by 2 greater than 50, and we are going to see the rows which has the age 2 multiplied version is greater than 50. Now we will explore the techniques for sorting and ranking data within Pandas data frames. Understanding how to effectively sort and rank data is essential for organizing and analyzing datasets in a meaningful way. Let's begin by examining how to sort data within a data frame. Let's just call data frame again. Actually, I need to call data frame, not st. Here it is. Let's sort our data frame by specific column. Let's say sort values, and we will say age in here. And we can just use ascending with this. Ascending false for sorting it in descending order based on age. This is a way of it. And let's say we want to sort the data frame by multiple columns. So we will say data frame sort values, and we will just give a list like the columns. So this one sorts the data frame first by city and then by age. And if you give category columns like this, it will sort the data frame in alphabetical order. These operations enable us to arrange the data frame based on specific column values, facilitating data organization and analysis. Next, let's explore the process of ranking data within a data frame. So let's rank the data frame based on a specific column. For that, we will say data frame age and we will use dot rank. And when we do that, you are going to see that our data frame has the ranks. And we can just handle ties via ranking, like we can just say data frame age dot rank, and we will say method is going to be equal to minimum this time. You can see it's changed. This handles ties by assigning the minimum rank to tied values. Ranking data allows us to assign numerical ranks to the values in a specific column, providing insights into the relative positions of data points. Now we will focus on the techniques for combining and merging data frames in Pandas. Understanding how to effectively merge and concatenate data is essential for integrating and analyzing complex datasets. Let's begin by examining how to concatenate data frames. So I'm just going to create two data frames like this. And I'm just going to run this one, data frame 1 and data frame 2. Here we have two data frames. Let's concatenate data frames along rows. So for that we will say pd, we are going to use the concatenate method, and we will say data frame 1 and data frame 2. For concatenating data frames along columns, we are going to say pd.concat, and we will say data frame 1 and data frame 2. This time we are going to set the axis as 1. These operations enable us to combine data frames either along rows or columns, facilitating the integration of data from multiple sources. Next, let's explore the process of merging data frames. So for that, I'm just going to create a new data. Like here, we are going to have the data frame 3, and you are going to see a similarity between data frame 1 and data frame 3 is that A columns values are the same within these. So we are going to merge data frames based on the A column. We will say pandas.merge, and we will say data frame 1 and data frame 3, and this time we are going to say on A. So what happened in here is we just merged this data frame 1 and data frame 3 on A column, and this time we have B and C here. Merging data frames allows us to combine data based on common columns, enabling comprehensive analysis across related datasets. Now we will focus on essential data cleaning techniques within Pandas. Data cleaning is a crucial step in the data preprocessing phase, ensuring data integrity and accuracy for further analysis. Let's begin by exploring how to remove duplicate values within a data frame. I will create a data frame like this, and I'm just going to call this data frame, and you are going to see that we numeric values in the values like this index 1 and 2 are duplicates, and in terms of columns, like these values are duplicated in A column, these values are duplicated, and in the B column these values are duplicated. For removing the duplicate rows, we can use DataFrame.dropDuplicates method, and you are going to see that we won't have duplicates after it. Let's say you want to check the duplicates in your data. So for that you can say DataFrame.duplicated, and it's going to return booleans like true and false, and if you use that sum after that, you are going to get the actual number of duplicated rows. So if you want to remove duplicate rows based on specific columns, like if you want to remove duplicates on the A column, these two and these two are going to be removed. You can do it like DataFrame.dropDuplicates, then you need to say subset, and you need to say A inside here, and you are going to see that these columns values are dropped, like this one and this one are dropped because they are duplicates. These operations enable us to identify and remove duplicate rows based on specific criteria, ensuring data accuracy. Next, let's explore techniques for handling outliers within a data frame. So let's quickly call our data frame again, and I'm going to work on the B column. Let's check the values for the B column, like we have minimum of 4, maximum of 7. We got the 75% 6 and 25% 5 in here. So we will take this quantile and take this quantile. Then we are going to filter our data based on that bounds. Like our bounds are going to be maximum value plus 1.5 multiplied quantile range and quantile minimum minus 1.5 quantile range. By the way, quantile range is maximum versus minimum. Like it's going to be 3. Okay, we can just do that. Let's say quantile low and it's going to be data frame B, and we will use dot quantile and we will say dot 25. And for the quantile high, we are going to say data frame B and we will use quantile 0.75. Also, let's recreate our B quickly. Like I'm just going to delete this and I will say B and A are going to take values like 12, 10, actually it won't change anything, like, and let's say 1 in here. And let's also say 25. Just for seeing the filtered version, because if we keep like that, the numbers are so close and there is a situation that none data will drop. So I'm just going to rerun this. We got a problem. I need to add one more number in here. Now it's going to be fixed. And here is our new data frame. And now we can work on it. Also, we need to rerun this because the values are changed. Like if I say data frame describe this time, all the values are going to be changed and our interquartile range is going to be 25 versus minus 1. It's going to be 24. Okay, let's say quantile range is going to be equal to the quantile high minus quantile row. So, by the way, I just recognized that I was telling quantile thing wrongly. Let's just call describe. The quantile range is this minus this. 75 quantile minus 25 quantile. Not maximum minus minimum. It was something different. I'm sorry. And now we can do lower bound and it's going to be equal to the quantile low minus 1.5 multiplied quantile range. And lower upper is going to be, actually let's call it like upper bound, and it's going to be quantile high plus 1.5 quantile range. And we are going to filter this. We will do, as you already know, multiple filtering operation, like let's say df filtered, and we are going to say data frame, and we will say parentheses for the first condition, data frame B greater than lower bound, and operator df B less than upper bound. Also, let's display data frame before getting the filtered version. Like also display this df filtered, and you are going to see the difference, like 25 is dropped. Handling outliers using quantiles allows us to identify and filter out data points that fall outside a certain range, ensuring the data's reliability for analysis. Now we will focus on the techniques for handling categorical data within Pandas. Understanding how to effectively manage categorical variables is essential for various data analysis and modeling tasks. Let's begin by exploring how to encode categorical data. So I'm just going to create a new data frame and let's call it. We can see that we only have categorical values in here. So let's start with encoding categorical data using getDummies method. We can use like pandas.getDummies, and we are going to say data frame category like this, and you are going to see that we have 3 columns, and you are going to see that each unique value in here in columns, and if it's A in the original data frame, it's true in here. If it is not, it's false. Actually, for knowing the third class, you only need 2 of this. Like you can just say A and B, and this will give you information about the C, because if it's false, if it's true, C is going to be false in here, and if it's both false, the C is going to be true in the third index. Like you can use it like this. Also, I'm going to show you another encoding method. This one is not going to be from Pandas, it's going to be from Scikit-learn, but it's something useful, so I just want to show it quickly. we can just say from Scikit-learn.preprocessing import label encoder and initialize this label encoder like encoder label encoder class. Then we can just do data frame category and label encoded, and it's going to be label encoder dot fit transform. I'm going to record the Scikit-learn course soon, so I'm just going to cover all this, and we are going to say data frame category. And let me quickly show you the original data frame and this version. Now this is the original data frame, and when I run this and we recheck this, you are going to see that we got values like 0 for A, 1 for B, and 2 for C. I just wanted to quickly show you this because this is the most used one. So these operations enable us to encode categorical data into a format suitable for various data analysis and modeling tasks. Next, let's explore techniques for handling categorical data for analysis. So let's just call our data frame again by recreating this, and let's call it in here, and we can just analyze categorical data using group by. Actually, let's just create new features into our data, like let's say sales, and we can just do like 10, 20, 30, 40, 50, and 60, and recreate this data frame quickly, and we are going to have the values. Now what we can do is we can just say data frame dot group by, and we can say category, then we can use dot size, and you will see the counts in here like A, B, A, C, B, A. Actually, let's not use the sales in this particular part of the course. I will use some grouping operations later on, so let's just forget about it. And what we can do is we can also use aggregation functions like data frame group by category, and we can use dot aggregation, then we can say category, and we can say count. This is going to give the same result with the upper one. This gives a series like category 3, 2, 1. This gives a series with this index. Actually, I think it's data frame. Let's quickly check this. Type. You can also check the data types in Python like this, and it's a data frame. So I'm just going to quickly show you a method like this is now a series, like we can check. And what if we want this to be data frame? We can basically use like reset index method, and this time this ABC is going to be in a new column. Our indexes are going to be into columns. Like you can see it's a data frame now, and you can just use type, then you are going to see it's a data frame from now on. Great. These techniques enable us to analyze categorical data effectively, providing insights into distribution and characteristics of categorical variables within a dataset. Now we will focus on data transformation techniques in Pandas. Understanding how to reshape, pivot, and melt data is crucial for organizing and restructuring data for various analytical tasks. Let's begin by exploring how to reshape data within a data frame. So I'm just going to create a new data frame, and I'm just going to call it like this. And now we are going to reshape the data using the melt function. So I will say pandas.melt, and I'm going to say data frame and ID variables is going to be equal to the name, and I will say actually I'm in list. I will say variable name, and I will set this as subject. Then I'm just going to do value name is going to be equal to the score. The melt function allows us to reshape data by converting columns into rows, facilitating a more organized representation of data. Next, let's explore how to pivot data within a data frame. So I'm just going to set this like data frame melted, and now I'm going to use pivot on that. I will say it's just like in the Excel data frame melted. Actually, for seeing it visually, let's also call this, and I will say data frame melted dot pivot, and index is going to be equal to the name, just like Excel. I will say columns is going to be equal to the, actually I made a typo, I'm quickly changing that. Columns is going to be equal to the subject, and value name is going to be equal to the score. Actually I need to use like values, and now we can see that we got the pivot table we wanted. The pivot function allows us to reshape data by converting unique values into new columns, providing a different perspective on the data. Now we will focus on handling date and time data in Pandas. Understanding how to effectively work with temporal data is essential for time series analysis and various time-based operations. Let's begin by exploring how to work with date and time data within a data frame. So I'm going to create an example data frame with date and time data, and I will just say data frame here. We got the dates and sales related to that. I'm going to convert the date column to date time format. So I will say data frame date. And then I'm going to say pandas to date time. Data frame date. Actually I need to use normal parentheses for that. And then I will say, actually before that I will say data frame dot data types. Firstly, before that you can see date is object and sales is integer, and then I'm going to do this, then I will say data types, and now we have date time in here. Okay, let's extract components from date time. Like we can get the year, month and day after changing this to pandas date time object. Like let's add a new column as year, and we are going to say data frame date, and we will use date time dot year. And also we can do the same for the month and the day. I'm going to do that by copying. I will change this like month, then I'm going to change this with month. Also for the day I will change this with day. And let's see the new version of our data frame. These operations enable us to convert date and time data into a more usable format and extract specific components from date time for further analysis. Next, let's explore working with time series data. Let's create another time series data and let's just check it, like time series data. This time we have series. Now we are going to see the resampling. So I will say time series resampled, and I'm just going to use time series data, and I will use resample, and by the W we will say weekly. Then I'm just going to take the mean of it, and I will say time series resampled for displaying it. You can also do this like monthly, yearly and other time frames. Working with time series data allows us to analyze and manipulate data points based on their temporal characteristics, visualizing various time-based operations and analysis. Let's create another data frame similar to this series and do more examples. I will say data frame with this code here, and we have a data frame right now. Let's create a date time index like data frame date. We already saw that. We will say pandas to date time, and we will say data frame date, and here it is. And now we are going to see how we can set this as index. So I will say set index, and I'm going to say date, and I'm going to use in place equals to true for modifying the original data frame. So when I call data frame, we will have that index in here. You can check your index like data frame index, and you will see your index. Here it is. Let's see shifting and lagging time series. So I will say data frame, and what we are going to do is let's create a column like shifted sales, and we will say data frame sales, and we will use dot shift, and we will say 1 for shifting it, and we will say data frame lagged sales, and let's say data frame sales dot shift, and this time we will use -1 for lagging it, and let's call data frame again, and you will see that we have shifted sales and lagged sales. Since we don't have any before date and after date on these values, these are none. Okay, with these null values being said, what we can do is we can generate a sequence of dates and times. For that, we have a function of pandas, like let's say date range, and we can use just pandas.date range, and this time we will give starting point like 2023 1 and 1, and let's say periods is going to be 10, and we will set the frequency like let's say weekly. And actually there's an error, let me quickly check. I made a typo, like it's periods. Actually I made a lot of mistakes on that, and this time it's going to work smoothly. And let's see how our date range looks like, and we will talk about its components. The periods here will create 10 new points with this frequency. Like if you change this to 20, you're going to see that we have 10 more in here, and if you change this to monthly, you're going to see that these are not going to be weekly, these are going to be monthly. Also, you can create long dates, like let's say 2023, let's not change it, and you can say 2000 in here, and when you run this, you are going to see you will have a lot to 2189. Great. Now we will focus on understanding group by operations in pandas. Group by operations are crucial for aggregating and analyzing data based on specific criteria, enabling comprehensive data analysis and insights. Let's begin by exploring how to use group by for data aggregation. For that, I'm just going to copy a thing from my notes, and I will say data frame for displaying it. Also, I need to use lowercase letters, and here we got our data frame. Let's group the data by category, and let's perform aggregation. Like we can say data frame group by, and what we can do in here is we can say category, then we will say .sum for getting the sums. Like in the A category, we have the 60 from the sum of this, and we have the 40 from this. We can just change this aggregation function like mean, and we will get the means like this. Also, we can do median and maximum and minimum. We have a lot of aggregation functions like standard deviation, variance, and much more. Great. We can also apply multiple aggregations like data frame, group by, and we can just say category. And what we can do is aggregation, then we can give a list like sum, mean, and maximum. And this time we will not get anything because we mistyped it. I'm going to say brackets, and when I add this, it's going to work smoothly. Like when I run this code, it's going to look great. Okay. Grouping data allows us to analyze and derive insights based on the distribution and characteristics of different groups within the dataset. Now we will focus on aggregating data using various functions in pandas. Understanding how to apply different aggregation functions is crucial for deriving insightful summary, statistics, and analysis from your datasets. Let's begin by exploring how to aggregate data using various functions. So I will say data frame again, and what we can do here is we can say data frame group by category, and then we can use aggregation, and we can get like value and sum. Also, I'm just going to copy this before running it, and here it is. Also, we can do mean, and we can do maximum, standard deviation, and much more. These operations allow us to apply various aggregation functions to derive essential statistics and insights from the dataset. Next, let's explore how to apply custom aggregation functions. So just like say custom aggregation, and we'll use lambda x max minus x minimum. And here we got the function. Now I will say data frame group by Actually, before that, let's call our data frame. For remembering it, data frame group by, and I'm going to say category, and I will use dot aggregation. Then I will say value, and it's going to be custom aggregation function we created. Here it is. So it made 25 minus 20 and 30 minus 10 for different categories. Applying custom aggregation functions enables us to derive specific insights and metrics tailored to the requirements of the analysis. Let's do more examples like apply multiple aggregation functions simultaneously. So what we can do is, let's say data frame group by category, and let's say value, and what we can do in here is that aggregation, and then actually I need to use this bracket aggregation. Let's give a list like sum, mean, and it's enough. I think actually we can give like variance with it, and result won't change. We will get it also that we can also aggregate data with custom functions using group by, like define a custom function like custom mean, and we will give the function values, and we are going to return sum of values divided by length of the values. And how we can use that is data frame group by category and value dot aggregation custom mean. Here it is. Okay, let's do a time series visualization. Like we can just create a time series data like this and recheck it. It's actually the same data we used, and let's explore time series visualization. So for that we will say import matplotlib.pyplot as plt, and we can just say time series data.plot, and it's going to be a line plot. Let's set a marker like this, and let's set a color like this, and let's set a line style like this, and I think it's enough. Let's say x label is going to be equal to date, and y label is going to be equal to the value. Then we can also use plt.grid, and we can use plt.show. Actually we got an error. I'm quickly checking it. It says it's a typo. Okay, I'm just going to, it's line type, not lines type. And when I run this, we got an error again. I'm just rechecking it. Line type is also not valid because it's line style. Okay, I'm quickly fixing it, line style, and now it's going to work smoothly. Great. So what this grid does is, when I remove this, you are going to see the background is going to be removed, and when I add grid, it's going to come back. I always use grid when I'm working with data. Like the background is nice, I think. Now we will explore advanced data manipulation techniques using apply, map, and apply map in Pandas. Understanding how to leverage these methods is crucial for applying custom functions, mapping operations, and element-wise transformations on data with data frames and series. Let's begin by exploring how to use apply for data frame operations in Pandas. I'm just going to create a data frame like this, and I will call data frame in here. And let's just use data frame apply, and we will say data frame dot apply for using the apply, and we will say lambda x multiplied by 2. And when we call data frame apply our data frame, we are going to see that all of our values is multiplied with 2. Using apply allows us to apply custom functions to each row or column in a data frame, facilitating versatile data manipulations and transformations. Now let's explore implementing map for series operations. Let's say series data, and it's going to be equal to pandas series. I'm not going to do a copy paste for this. I will say 1, 2, 3, 4, 5, and let's say mapped data is going to be equal to series data dot map and we are going to use lambda again, x 2 power of 2, and let's, after getting the squared value of each element, we can say map data, and you are going to see that we have the 4 for the 2 squared, 25 for the 5 squared. Great. Implementing map enables us to perform element-wise operations on series, providing a streamlined approach for data transformation and manipulation. Lastly, let's explore using apply map for element-wise operations on data frames. Like, let's recall our data frame, and we will say data frame apply map, and we will use data frame.apply map method, and we will say lambda and x and x3, and let's get the data frame apply map. Here it is. Using apply map enables us to apply function element-wise to every element in a data frame, facilitating efficient and consistent data manipulations. Let's do more examples with this. Actually, apply is the most used one, so I'm going to create example with this. Let's create a new column as C with using data frame dot apply lambda row A multiplied by row B, and we will set the axis as 1. And let's recall our data frame. For seeing the C column, you will see that 2 times 20 is 40, 3 times 30 is 90. Great. Now we will focus on visualizing data with built-in Pandas tools. Understanding how to effectively utilize these tools is essential for creating insightful visual representations of your data directly within the Pandas environment. Let's begin by exploring how to create basic plots with Pandas. Let's create a data frame firstly and call it. And now let's create a basic line plot with Pandas. Like we already did something like that. Data frame plot, and we'll say x is going to be equal to year, y is going to be equal to revenue, and let's set the kind as line, and let's set the marker as this, and I think it's enough. Let's don't add another thing. We'll give this a title like revenue over the years, and let's give this a x label like year and y label like revenue, and also add grid. Then use plt.show. Here it is. You can change these things, like you can do color, and you can say red for customization, and what you can do is you can do sky blue for this. And if you don't want to see this revenue thing in here, like let's do yellow, and actually we can see it, let's say black. And if you don't want to see this revenue thing in here, you can just say legend and set this as false for removing it, like this. Now we will talk more and focus on creating basic plots such as bar plots and scatter plots in Pandas. Understanding how to effectively create these plots is essential for visually representing data and analyzing trends and relationships within dataset. Let's begin by exploring how to create bar plots with Pandas. So here I have a data frame, and now what I'm going to do is data frame.plot. I will say x is going to be equal to the city, and y is going to be equal to the population, and we are going to set the kind as bar this time, and let's say color is going to be the red, and let's say legend equals to false. Also, what we can do is we can give it a title like population in major cities, and let's add x label like city and y label like population, and we will use plt.show at the end. Here it is. So what if you want to sort them in descending order is you can just say data frame sort values, and by is going to be equal to the population. We are going to sort this by population, and we will say ascending equals to false, and we are going to plot like this. The rest is going to be the same, and we are going to get our bar plot in descending order. Also, for getting it in ascending order, you can just change this to true and you will get it in ascending order. Creating bar plots with pandas allows us to compare different categories or groups, facilitating a straightforward visualization of the data. Lastly, let's explore creating scatter plots with pandas. So here we have a data frame, df scatter. Actually, I called the wrong one, scatter, and I'm just going to call it. Okay, let's create a scatter plot for that. We will say plt.scatter. We are creating with Matplotlib this time. I will say data frame scatter x, and I will say data frame scatter y, and let's say color is going to be green, and we will say x label as x, y label as y, and we will use plt.show. By the way, we are creating the scatter plot with Matplotlib, not pandas. So here it is. Creating scatter plots with pandas allows us to visualize the relationship between two variables, facilitating the identification of patterns and correlations within the dataset. Now we will focus on working with multi-index data frames and combining pandas with other libraries, such as Numpy. I think it will be just Numpy. I'm not going to add other libraries to this part. Understanding how to effectively manage multi-index data and integrate with external libraries will enable us to handle complex data structures and perform advanced data analysis. Let's begin by exploring how to work with multi-index data frames in pandas. So I'm going to create a data frame like this, and I will say, as you can see, we have two indexes, first and second, and I'm going to say data frame.index, and when we do that, you are going to see we have A1, A2, B1, B2, like this one, and this with this, and this with this, and this with this. How we can do this is you can just use multi-index from pandas, and you will say from arrays, and you will give two arrays as index, and then you will say arrays, and you will give names, like you can just give first one and second one like we gave in here. Then you are going to set the index when you are creating the data frame with pandas.dataframe, and you are going to see that these are changed. Like also you can add more like D and C and B to this, and you are going to see it's going to be changed. Like you can just give two values for this and it's going to work finally. Actually not, because I forgot that we need to have same length arrays. Like we need to do like 3 and 4. This time it's going to work smoothly. Here it is. So when we call index, we will say A1, B2, C3, D4 this time. Working with multi-index data frames enables us to manage and analyze data with multiple levels of indexing, facilitating the organization and manipulation of complex datasets. Next, let's explore combining pandas with Numpy for advanced data analysis. So how we can do that is we can just import Numpy again. We imported it before, but just for showing you again. And what we can do is we can say array data, and we can just create an array. Like we created a data frame at the start of this course from Numpy, and I'm just doing this again for remembering it. And by remembering this, we can just use Numpy arrays. After now, for creating data frames, we can say 7, 8, and 9, and then we can do like data frame Numpy. Actually, there is an I need to do like, actually, what is the error is that we need to take this to the start, and now we are good to go. We will say pandas.dataframe, and we will give array data, and let's say columns are going to be sales A, sales B, and sales C. We actually made a really similar thing to that at the starting of the course, and now we are doing it again at the end. Combining pandas with NumPy allows us to leverage the extensive functionalities of NumPy arrays within the pandas environment, facilitating complex data manipulations and calculations. We actually use NumPy arrays a lot on deep learning and machine learning models, so using this too can be really beneficial, and that's why I showed it again. I think you are going to use NumPy a lot if you are going to do a data related job, like you can be data scientist, data analyst, machine learning engineer, and I'm pretty sure you will deal a lot with NumPy. Now, as the final part of the course, we will explore the powerful text manipulation capabilities offered by Pandas. Understanding these text methods is crucial for efficiently handling and processing textual data within your datasets. Let's begin by exploring how to use vectorized string operations in Pandas. And we have a text data in here. I'm just going to use df for displaying it. And let's lowercase this text data. Like, let's say data frame lowercase, and we can just do data frame text data, and we can use string.lower like this. And let's get data frame displayed, and you are going to see all the letters are lowercase. Also, let's do an uppercase version of this. So we can say data frame uppercase, and what we can do is data frame text data dot string dot upper. And here, when we display data frame again, you're going to see we have the uppercase letters in here. So let's make an example of checking for string containment. So how we can do this is data frame contains, and we will say data frame text data, and we will use dot string contains, and let's say letter P actually, and then we can do case false like this. And when we display data frame again, you are going to see that if the string contains P, the value we give in here, it will display true because we set up the case as false, and if it's not containing P letter, it's giving false in this column. Using vectorized string operations allows us to perform various text manipulation tasks efficiently and seamlessly within the Pandas environment. Next, let's explore applying regular expressions for advanced text processing. So how we can do that is data frame matches, and we can just do equsign data frame text data dot string find all, and we can just say oh, and we can just say data frame now. So it returns in a list all in the matches side if the word contains all, and it returns an empty list if it not. Applying regular expressions enables us to perform complex pattern matching and text extraction operations, providing advanced capabilities for text manipulation and analysis. Furthermore, let's explore using string replacement and splitting for text manipulation. And I think that will be all for our course. And let's do like data frame replaced. And in this side, we will say data frame text data, we will say string replace, and let's replace the O with X. And let's see how our data frame replaced looks like. Here it is. We got the hello in different version. And now what we can do is for the splitting, we can say data frame split, and we can do data frame text data, and we can use string dot split like this. And let's just call it, and you will see that if we have multiple words like data science, they are splitted in a list like this. Using string replacement and splitting allows us to modify and manipulate text data effectively, facilitating comprehensive text processing and analysis tasks. And that was all for this course. Thanks for watching. I tried my best on this course. We'll start with importing it. For importing it, we are going to use import numpy as np. And we are good to go here. And now we are going to create a one-dimensional array. I'm going to use array one dimension is equal to numpy.array, and we are going to use like this. And let's add 1, 2, 3, 4, and 5 into our array and print this array. And now we are going to create a two-dimensional array. Let's say 1, 2, 3 for the first dimension and 4, 5, 6 for the second, and we are going to print this also and see what it looks like. Now that we have our arrays, let's move on to the first manipulation operation. We will start with array indexing and slicing. Array indexing and slicing allows us to access specific elements or sub-arrays within an array. Let's access to an element in our one-dimensional array, and we are going to print the element here that we reached. We just access to a single element in a one-dimensional array. Let's access to a row in a two-dimensional array. We are going to set this as row and in array 2 dimensions, and let's also print this. We just access to a row in a two-dimensional array. This time we are going to access to a specific element in a two-dimensional array. For this, let's say specific element and now we are going to print this one. It seems nice. Let's access to a subarray with the use of slicing and indexing operations. We are going to use like this, and let's also print this. Seems nice. Now we will keep with reshape operations. Reshaping arrays allows us to change their dimensions, which can be useful when performing certain operations or when we want to match the shape of another array. For this, let's set this as reshaped array, and we are going to use that reshape method, and let's say 5 and 1 here, and let's print this. I made a typo there. Let me quickly fix this. Okay, seems nice, I think. Okay, and now we are going to flatten the two-dimensional array. We just saw how reshape and flatten methods used. Now we will talk about array concatenation. Array concatenation allows us to combine multiple arrays either along a specific axis or by appending them together. Let's see this in an example. Let's start by numpy.concatenate, and we need to open this one here, and we are going to add two one-dimensional arrays together, and let's print what we created here. And as we can see here, we concatenated two one-dimensional arrays. Now we are going to concatenate two two-dimensional arrays along the columns with using axis equals to 1. Okay, we just learned how to use concatenate. Now we will talk about array splitting. Array splitting allows us to break down an array into multiple smaller arrays along a specified axis. Now we will split our one-dimensional array into 5 arrays. We are going to use numpy.split for this task. As we can see, we splitted our array. Now we are going to do the same operation for our two-dimensional array. We are going to split it to 2 parts. Okay, that's it. We just learned array splitting. Now we are going to talk about array transposition. Array transposition is a process of swapping the rows and columns of a two-dimensional array. Let's set this as transposed array. We are going to use .t for this, and let's print this and see how our array is changed here. Okay, we just learned transposition. Now we will talk about element-wise operations. Numpy allows us to perform element-wise operations on arrays, where each element of the array is operated individually. For example, let's see addition here. We are going to add 2 to all elements, and let's print this and see the output. Here we just did element-wise addition, and let's also do multiplication. Here we just did element-wise multiplication. We can do element-wise operations like this. Now we will talk about sorting arrays. Sorting arrays is a common operation in data analysis. Numpy provides functions to sort arrays either in ascending or descending order. Let's start by sorting a one-dimensional array in ascending order. We are going to say sorted array is going to occur to numpy.sort, and let's print this. Seems nice. Now we are going to sort a two-dimensional array along a specific axis. And we are going to print this. And now we are going to sort a two-dimensional array based on a specific column. And this was all for array sorting. Now we are going to talk about array masking. Array masking allows us to create a Boolean mask based on certain conditions and apply it to filter or modify the array. Let's create a Boolean mask based on a condition. Let's say mask is equals to the array 2 dimension greater than 3. And let's print this mask here. And we can see the returns of true and false. Now we are going to apply the mask to filter the array. Let's say filter it array. We are going to apply the mask like this and print this. As we can see, only return the values which gave true at the upper operation. Now we are going to modify the array based on a mask. Let's say is equals to the 0 and print this. As we can see, the values which gets the true value by our condition gets the value of 0 here. That was all for array masking. Now we are going to talk about array stacking. Array stacking allows us to combine multiple arrays along new axes, either horizontally or vertically. We will start with horizontally stacking. Let's say horizontally stacked array is equals to numpy.horizontal stack. And now we are going to see vertically stacking. We are only going to change the hash with v here. And that was the last part of the video. Matplotlib is often used in conjunction with Numpy, so let's import both of them. We are going to import Numpy as np and import matplotlib.pyplot as plt here. With our libraries in place, let's proceed to generating a dataset that we'll use for our plotting examples. I'm going to use some NumPy methods for this operation. Firstly, let's start by creating our x. And now we are going to create our y here. We now have our dataset ready. It consists of 100 data points, evenly spaced from 0 to 10 with some added noise. Now let's jump right into our first plot, a simple line plot. For this we are going to just use like plt.plot, and we are going to pass x and y, and let's add a title. With that title we are going to say line plot, and let's give a name to the x-axis with plt.x label, and also do the same for the y. And at the final stage we are going to use plt.show. Seems nice. We have just created our first plot using Matplotlib. As you can see, we plotted the values from our dataset x against y, resulting in a line plot. We also added a title labeled the x and y axis and displayed the plot using plt.show. Now let's explore some other types of plots. The next one we will cover is a scatter plot. For creating a scatter plot, we are going to say plt.scatter, and we are going to pass x and y again, and we are going to add a title as scatter plot, and let's also do the operations for the x label and y label. And at the final stage, let's use plt.show. And there we have it. Scatter plots are great for visualizing the relationship between two variables. In this case, we have plotted the points from our dataset, resulting in a scatter plot. Notice how the points are not connected with lines, unlike the line plot. Next up, let's explore bar plots, which are useful for comparing categorical data. For this operation, we are going to start by creating categories. And let's say A, B, C, and add D and E here. and we are going to add some values here. 15, 7, 10. I'm just randomly writing 12, 8. And now we are going to use plt.bar for creating a bar plot. We are going to pass categories and values here. Let's add a title with plt.title once again as bar plot. And use X label for categories and Y label for values. And we are going to use plt.show once again. And there we have it. Bar plots provide an effective way to visualize categorical data. In this example, we have categories A through E with corresponding values. The heights of the bars represent the values for each category. Now let's take a look at another popular plot type, histograms. Histograms are ideal for visualizing the distribution of a dataset. I'm going to use the Y that we created earlier in this video. We are going to use plt.hist. We are going to add Y and bins here. plt.title histogram. We are going to add X label as values and Y label as frequency. And at the final stage we are going to use plt.show. Histograms provide insights into the distribution of data. In this case, we are visualizing the distribution of our dataset Y. By specifying the number of bins, we control the granularity of the histogram. Let's explore one more plot type, the pie chart. Pie charts are useful for displaying proportions and percentages. Let's move to the next cell. We are going to create labels quickly. We are going to say category A, category B, and category C in a list. We are going to add sizes here. 40, 30, and 30. We are going to create a list as explode. I'm going to talk about what it does. 0.1, 0, and 0 here. And now we can create our pie chart with plt.py. We are going to pass sizes, explode, labels, and let's add a title as pie chart. And we are going to use plt.show. Pie charts allow us to visualize proportions within a whole. In this example, we have three categories, A, B, and C. The slices of the pie represent the proportions of each category. The explode parameter allows us to emphasize a specific slice. Let's keep with plot type known as the area plot. We are not going to use like plt.area, we are going to use fill between here, like plt.fill between x and y. We are going to pass, and we are passing an alpha value. You can try the different ones. Let's add a title as area plot. Also add x and y labels. And we are going to use plt.show. Area plots are excellent for visualizing the magnitude of data across different categories of time intervals. In this example, we have filled the area between the x values and the corresponding y values, resulting in a shaded area plot. Next up, let's explore a plot type that's widely used in time series analysis, the candlestick chart. We are also going to use Numpy here. Dot plot x and y. We are going to set color here. Let's add a title as candlestick chart, and let's add x label as x axis and y label as y axis. And we are going to do a different thing here. plt.stem x y, we are going to say r, and we are going to set the marker here, and at the final stage we are going to use plt.show. I forgot to add an O here. Let me add that quickly, and that's nice. Okay, candlestick charts are commonly used in financial analysis to visualize the opening, closing, highest and lowest values of a stock or asset. In this example, we have plotted our dataset Y as a line chart and added stamps to represent the opening and closing prices. Now let's move on to a plot type called as the violin plot, which combines the features of a box plot and a kernel density plot. Let's get to another cell here, and we are going to use plt.violin plot. We are also going to show medians as true. Let's give a title here as violin plot and add a y label as values, and we are going to use plt.show. Violin plots provide insights into a distribution of data similar to box plots, but also display the kernel density estimation. In this example, we have created a violin plot to visualize the distribution of our dataset Y, including the median value. Let's explore a plot type known as the three-dimension surface plot, which is perfect for visualizing complex relationships in three-dimensional datasets. We are also going to import something here. We are going to say from mpl toolkits.mplot3d import access 3d. We are going to start by setting figure ax. We are going to add a subplot and set projection as 3 dimensions. That plot cover map. And now we are going to set the title here. We are going to use a different method here since we are using subplots. We are going to set the title as 3D surface plot. Let's set X label as X axis, Y label as Y axis, and at the last place z label the axis, and we are going to use plt.show here, and we are good to go, I think. And that seems nice. Okay. 3D surface plots offer a mesmerizing way to visualize data in 3 dimensions. In this example, we have created a surface plot using the x and y values as the input and the squared sum of x and y as a height. Let's keep with exploring the hexpin plot, which is useful for visualizing the distribution of a large number of data points. For this, we are going to use plt.hexpin, and we are going to pass x and y grid size and cover map. Let's set this to, let me think, Inferno. Okay, plt.title. We are going to add title as hexpin plot, and let's set x label as x-axis and y label as y-axis. We are also going to add plt.coverbar. Label is going to be equal to the count, and we are going to use plt.show. Let me check quickly. I need to change here to grid size. I made a typo there, and I think now we are good to go. Hexpin plots divide the data space into hexagonal bins and represent the number of points within each bin using colors. In this example, we have created a hexpin plot to visualize the distribution of our dataset x and y. Next, let's uncover the power of polar plots, which are great for representing cyclic and directional data. We are going to move to another cell here. We are going to set a theta value with a Numpy method. Numpy.py, and we are going to set r and now we are going to use plt.polar with passing theta and r. Let's give a title here, and we are going to use plt.show. Polar plots utilize polar coordinates to represent data. In this example, we have created a polar plot with theta as the angle and r as the radius. The resulting plot showcases the clinical nature of the data. Now let's move on to the stream plot, a plot type commonly used to visualize fluid flow and vector fields. We are going to create a new x and y here with using Numpy methods, mesh grid, numpy.space. And now we can create our stream plot. plt.streamplot x, y, u, and v. We are going to give a title as stream plot. plt.xlabel x axis and plt.y label y axis, and we are going to use plt.show. I made a typo there. I hope it's okay. Now it's going to work. Stream plots provide a visual representation of vector fields. In this example, we have created a stream plot using the vector components u and v. The resulting plot demonstrates the flow of vectors in the field. As the last one, let's explore the error bar plot, which is commonly used to represent uncertainties or error ranges in data. We are going to use the old x and y, but I don't want to write them, so I'm going to make a copy paste here. We are just going to create errors together. Absolute numpy.random.normal 0, 0.2 and 100. Okay, now we are going to create our plot with this. We are going to use plt.errorbar x y errors fmt, and we are going to set the cap size. Let's set a title here as error bar plot and x label as x axis and y label as y axis, and we are going to use plt.show at the end. Also, let me add one more thing. We can change the color of this. color, let's say red, and you can represent like this also. In this code, we generate random errors using numpy.random.normal with a mean of 0 and a standard deviation of 0.2. Then we pass the x and y values along with the y error parameter to the error bar function. The fmt parameter is set to O to use circles as markers. color is set to R to specify the color of the error bars, and cap size is set to 3 to control the size of the caps on the error bars. We are going to import Pandas, of course Seaborn and Matplotlib, and we are going to run this cell. I'm going to create an easy example dataset for this course for it to be simple and understandable. I'm just going to copy paste for not taking too much time from the video. I'm going to paste and run this cell. We have category values, 3 values, and we turned them into Pandas data frame, and now we can start. We are going to start with bar plot. I'm going to create the plots, then I will talk about them. Let's start by creating bar plot by SNS bar plot. We are going to say x is going to be equal to the category, and y is going to be equal to the, let's say, value 1, and we are going to set data, and let's give the title bar plot x label category y label value 1, and we are going to say plt.show for displaying it. Here it is. A bar plot is a simple and effective way to display categorical data. In this visualization, each category is represented on the x-axis and corresponding numerical values are displayed as bars on the y-axis. The height of each bar represents the value of the respective category. It's particularly useful for comparing multiple categories and identifying trends or disparities between them. The bar plot created with Seaborn showcases the relationship between category variable and the value 1 variable. By analyzing this visualization, one can easily observe the varying values of different categories and discover any patterns or significant differences. Now we are going to talk about scatter plot. For creating a scatter plot, we are going to say SNS scatter plot. Let's set x as value 1 and y as value 2, and we are going to set hue here category, and we are going to set our data, of course. Now give it a title like scatter plot and x label as value 1, y label value 2. Let's add legend to this. Title is going to be equal to the category, and let's use plt.show for displaying it. I need to use capital letter on value 1. I made a typo, and we are going to run this. Here it is. A scatter plot is employed to explore the relationship between two numerical variables. In this representation, the value 1 variable is plotted on the x-axis and the value 2 variable on the y-axis. Each data point is marked accordingly. By adding the category dimension as the hue, the scatter plot covers the points based on their category affiliation. This enables the viewer to discern any correlation between value 1 and value 2, as well as identifying groupings or clusters based on the category. Scatter plots are useful when studying distribution and possible connections between two continuous variables. Now we are going to talk about line plot. For this, we are going to say SNS.lineplot x is going to be equal to the category and y is going to be equal to the value 1. Data is going to be equal to the data frame, and let's set marker as this. We are going to say plt.title line plot, plt.xlabel value 1, and plt.ylabel. I'm sorry, our x label was the category and this one is the value 1. And we are going to display this. Line plots are excellent for displaying trends and challenges in data over time or continuous intervals. In this representation, the category variable is displayed on the x-axis and the value 1 variable on the y-axis. Each category's value is connected by a line highlighting how the value 1 changes across different categories. With markers at data points, the line plot emphasizes individual values. This visualization effectively showcases trends or shifts in value 1 and allows easy comparison between categories. Line plots are valuable in identifying patterns, seasonal variations, or any systematic fluctuations within the data. Now we are going to talk about heat maps. Let's create it. We are going to use sns.heatmap for this, and we are going to say data frame value 1. Let's take all of them, value 2 and value 3, and we are going to use the correlation here, and let's say anode is true and cover map is cool warm, and let's give a title to this as heat map, and we are going to display this like this. Heat maps provide a visual representation of the relationships between multiple variables by using colors to indicate the magnitude of values. In this example, the correlation matrix of value 1, value 2, and value 3 is displayed in a heat map. The diagonal line appears in a uniform color as it represents the correlation of a variable with itself, which is always perfect. The perfect means correlation coefficient is equals to 1. It takes values between -1 and +1. -1 means perfect negative relationship, which means they are moving in different ways but together. The 1 means they are positively perfectly correlated, which means they are tend to move together. Non-diagonal cells are shaded differently based on the correlation coefficient, allowing easy detection of strong positive or negative correlations. Heat maps are particularly useful when dealing with large datasets and exploring the relationships between multiple variables simultaneously. Now we are going to talk about pair plot. For this, we are going to say sns.pairplot data frame hue is going to be equal to the category, and let's set this as, we are going to say let's set y as 1.02, and we are going to display this. A pair plot is a comprehensive visualization that displays pairwise relationships between multiple numerical variables in a dataset. Each numerical variable is plotted against every other numerical variable, forming a grid of scatter plots. In this example, the value 1, value 2, and value 3 variables are compared against each other. The diagonal of the pair plot shows kernel density plots, providing the univariate distribution of each variable. Pay plots are valuable for gaining a quick overview of potential correlations and trends among multiple variables, making them especially useful for exploratory data analysis. Now we are going to talk about count plot. For this we are going to say SNS count plot. X is going to be equal to the category and data is going to be equal to the data frame. We are going to use plt.title count plot. We are going to add X label, category, and Y label count. Let's use plt.show also, and we are going to run this. A count plot is a bar plot that shows the frequency of occurrences of each category in a categorical variable. It displays the number of instances of each category, making it simple to compare the counts and identify the most common categories. In this example, the count plot reveals the number of occurrences of each category. If you had two of the A categories, it was going to display 2 instead of 1. Count plots are ideal for summarizing categorical data and gaining a quick understanding of class imbalances or dominant categories. Now we are going to talk about kernel density estimation plots. For this, we are going to say SNS.kernel density estimation plot data is going to be equal to the data frame value 1, value 2, and value 3, and we are going to use fill true here. And let's say plt.title kernel density estimation plot, and we are going to use plt.show. KD plots are used to visualize the probability density function of a continuous variable. This plot represents the smoothed version of a histogram and provides insights into data's underlying distribution. In this example, the KD plot showcases the estimated density of the value 1, value 2, and value 3 variables. These plots are particularly useful for understanding the continuous data's overall distribution and can reveal patterns that might be less apparent in traditional histograms. Now for the final, we are going to talk about regression plots. For this, we are going to say SNS regression plot. We are going to set X as value 1 and Y as value 2, and let's set our data, and we are going to add markers also for this one. We are going to say O here. We are going to say plt.title regression plot X label equals to the value 1 and Y label equals to the value 2, and we are going to use plt show for the last time in the video. A reg plot, short for regression plot, displays the relationship between two numerical variables along with the best fit regression line. It's used to visualize the correlation between two variables and determine if a linear relationship exists. In this example, the reg plot demonstrates the relationship between value 1 and value 2. The regression line helps understand the overall trend between the variables, indicating whether they have a positive or negative correlation. Regression plots are useful for identifying associations between two continuous variables and assessing the strength of the relationship. We will start by installing and importing Plotly in Google Colab. Plotly is not included by default in the Colab environment, so we need to install it before we can start using it. To install Plotly, we can simply run the following command in the code cell. This command uses the exclamation mark to execute a shell command directly with the notebook. The pip command is the package installer for Python, and we are telling it to install Plotly package. Once the installation is complete, we can import Plotly into our notebook by adding the following line of code. Here we are importing the grep objects module from the Plotly library and aliasing it as Go to make it easier to work with. Now that we have Plotly installed and imported. We are ready to create our first visualization using Plotly. Now we will start by creating our first basic line. Line plots are one of the fundamental types of visualizations and are great for representing trends and patterns in data. To create a line plot in Plotly, we need two essential components, the x-axis values and corresponding y-axis values. The x-axis values represents the independent variable or the categories, while the y-axis represents the dependent variable or the values we want to plot. Let's start by creating some sample data for our line plot. In this example, let's consider we have a list of years as our x-axis values and a list of corresponding sales as our y-axis values. Now we can create a line plot using these data points. Seems nice. We created a good looking plot. In the code above, we imported the necessary Plotly module as Go. Then we create a figure object and specify the data we want to plot using the scatter trace. We provide the x-axis values as years and the y-axis values as sales. Finally, we call the show method on a figure to display the plot. This will open a new window or show the plot directly in the notebook. As you can see, the line plot is displayed and each data point is connected by a line. The x-axis represents the years and the y-axis represents the sales. You can hover over the data points to see their exact values. Zoom in and out and interact with the line plot. Let's make a zoom operation here. As we can see, we can zoom to data like this. Now we will explore how to customize the plot layout, titles, and axes in our Plotly visualizations. Customizing these elements allows us to provide context and improve the overall appearance of our plots. Let's continue working with the line plot we created in the previous section. We have our x-axis values stored in the years list and the corresponding y-axis values in the sales list. To customize the plot layout, we can modify various attributes of the figure object. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data using the scatter trace, just like before. Then we use the update layout method to customize various aspects of the plot. Here, we add a title to the plot using the title attribute, labels to the x-axis and y-axis using the x-axis title and y-axis title attributes respectively. Additionally, we hide the legend by setting the show legend attribute to false. As you can see, the plot now has a title at the top, labels for the x-axis and y-axis, and the legend is hidden. These modifications provide more information and improve the overall readability of the plot. Feel free to experiment with different titles, axis labels, and other layout attributes to further customize the appearance of your plots. Now we will explore how to add annotations and shapes to our Plotly visualizations to provide additional context and enhance the understanding of our data. Let's continue working with the line plot we created earlier. We have our x-axis values stored in the years list and the corresponding y-axis values in the sales list. To add annotations to our plot, we can use the add annotation method of the figure object. Annotations allows us to add text and arrow at specific locations in the plot. Let's write the code together and see how it affects the output. In the code above, we created a figure object and specified the data using the scatter trace. Just like before, then we used the add annotation method to add an annotation to the plot. We provide the x coordinate and y coordinate of the annotation, the text we want to display, and various other attributes like show arrow, arrowhead, ax, and ay to control the appearance of the annotation and the arrow. As you can see, the annotation higher salaries is added to the plot at the specified coordinates. The arrow indicates the location being referred to, adding clarity to the annotation. Apart from annotations, we can also add shapes to highlight specific regions or patterns in the plot. We can use the add shape method of the figure object to accomplish this. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data using the scatter trace. Then we use the add shape method to add a shape to the plot. We provide the type of shape, the x coordinates and y coordinates of the shape, the fill cover, opacity, and the line of width of the shape's border. As you can see, a yellow rectangle shape is added to the plot, highlighting the range of sales between the years 2019 and 2022. Now we will explore how to create scatter plots using Plotly. Scatter plots are a great way to visualize relationships between two numerical variables. To create a scatter plot, we need two sets of numerical data, one for the x-axis and another for the y-axis. Each data point represents a pair of values from these two sets. Scatter plots are especially useful for identifying patterns, trends, or correlations between variables. Let's start by creating some example data for our scatter plot. In this example, let's consider we have a list of students' ages as our x-axis values and their corresponding test scores as our y-axis values. And now we can create a scatter plot using these data points. Let's write the code together. In the code above, we imported the necessary Plotly module as Go. Then we create a figure object and specify the data we want to plot using the scatter trace. We provide the age as x values and the score as y values. Additionally, we set mode to markers to display each data point as a marker. As you can see, the scatter plot is displayed and each data point is represented by a marker. The x-axis represents the age of the students and the y-axis represents their test scores. Scatter plots allows us to easily visualize the relationship between these two variables. Now we will explore how to customize markers, colors, and size in scatter plots using Plotly. Customizing these aspects allows us to add additional visual cues and highlight specific patterns or groups within our data. Let's continue working with the scatter plot we created earlier. We have our age stored in the age list and the corresponding scores in the scores list. To customize the markers in our scatter plot, we can modify various attributes of the scatter trace. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the scatter trace. We provide the ages as x values and the scores as y values. Additionally, we use the marker attribute to customize various aspects of the markers. Here, we change the marker symbol to a star, the marker size to 10, the marker cover to red, and the marker border width to 2 and cover to black. As you can see, the markers in the scatter plot are now displayed as stars with a larger size, red color, and a thicker black border. These customizations help to distinguish the data points and add visual interest to the plot. Apart from symbols, size, and colors, you can also explore other marker customization options such as transparency, gradients, or even using custom images as markers. Feel free to experiment and make your scatter plots unique to your data. Now we will explore how to add error bars to our scatter plots using Plotly. These additional elements provide valuable insights into our data and help visualize trends and uncertainties. Let's continue working with the scatter plot we created earlier, which represents the relationship between ages and scores. We have our ages stored in the ages list and the corresponding scores in the scores list. Error bars provide a visual representation of the variability or confidence intervals around each data point. Let's write the code together to add error bars. In the code above, we create a figure object and specify the data we want to plot using the scatter trace. We provide the ages as x values and the scores as y values. Additionally, we customize the markers by setting the color attribute to blue. To add error bars, we use the update trace method and set the error y attribute to a dictionary containing the type of error bar and array of error values for the y-axis, and make the error bars visible by setting visible equal to true. Now we will explore how to create bubble charts using Plotly. To create a bubble chart, we need three sets of numerical data, one for the x-axis, one for the y-axis, and another for the marker size. Each data point represents a set of values from these three sets. Bubble charts are particularly useful when we want to visualize relationships between multiple variables and represent a third variable through the size of the markers. Let's dive into an example. Consider we have a dataset containing information about cities. For each city, we have the population, the average temperature, and the GDP. We can create a bubble chart to represent the population and average temperature on the x-axis and y-axis respectively, and use the marker size to represent the GDP. Let's start by creating some sample data for our bubble chart. In this example, let's consider we have three cities. Now let's write the code together to create the bubble chart. In the code above, we create a figure object and specify the data we want to plot using the scatter trace. We provide the temperature as x values and the population as y values. Additionally, we use the marker attribute to customize the marker size, its scaling mode, the reference size, the minimum size, the marker cover, and show the cover scale. We also provide the city names as text to display as tooltips when hovering over the markers. As you can see, the bubble chart is displayed, with each city represented by a marker. The x-axis represents the average temperature, the y-axis represents the population, and the marker size represents the GDP. The larger the marker size, the higher the GDP value for each city. Bubble charts allow us to visualize multiple dimensions of data in a single plot, making it easier to identify patterns and relationships. We can explore various combinations of variables and marker sizes to gain insights into our data. Now we will explore how to create vertical and horizontal bar charts using Plotly. Bar charts are useful for visualizing categorical data and comparing values across different categories. Let's start by creating a simple vertical bar chart to represent the sales performance of different products. We have a list of product names stored in the products list and their corresponding sales values in the sales list. To create a vertical bar chart, we can use the bar trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the bar trace. We provide the product names as X values and the sales values as Y values. As you can see, a vertical bar chart is displayed, with each product represented by a bar. The height of each bar represents the corresponding sales value. The x-axis represents the product names and the y-axis represents the sales values. We can also create a horizontal bar charts by simply switching the x and y values. Let's modify the code to create a horizontal bar chart instead. In the code above, we create a figure object and specify the data using the bar trace. We provide the product names as y values and the sales values as x values. Additionally, we set the orientation attribute to h to create a horizontal bar chart. As you can see, a horizontal bar chart is displayed with each product represented by a bar. The length of each bar represents the corresponding sales value. The y-axis represents the product names and the x-axis represents the sales values. Bar charts are versatile and can be customized in various ways. You can modify the colors, add labels, tooltips, or even stack multiple bars to represent additional dimensions of data. Now we will explore how to create grouped and stacked bar charts using Plotly. Grouped and stacked bar charts are useful when we want to compare values across multiple categories and visualize the composition of each category. Let's start by creating a grouped bar chart to compare the sales performance of different products across different months. We have a list of months stored in the months list, a list of product names stored in the products list, and a two-dimensional list of sales data stored in the sales list. To create a grouped bar chart, we can use multiple bar traces provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and iterate over each product using a for loop. Inside the loop, we use the bar trace to create a bar chart for each product. We provide the months as X values, the sales data for each product as Y values, and set the name attribute to the product name for labeling purposes. Now we will explore how to create histograms using Plotly. Histograms are useful for visualizing the distribution of numerical data and analyzing its frequency or density. Let's start by creating a histogram to analyze the distribution of exam scores for a class. We have a list of exam scores stored in a scores list. To create a histogram, we can use histogram trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the histogram trace. We provide the exam scores as x values. As you can see, a histogram is displayed representing the distribution of exam scores. The x-axis represents the range of scores and the y-axis represents the frequency or count of scores falling within each range. Each bar in the histogram represents a bin, which is range of scores. Histograms allows us to make visual the shape of the data distribution, identify any patterns or outliers, and gain insights into the data. We can modify the number of bins to adjust the level of detail and granularity in the histogram. We can also customize the appearance of the histogram by adding labels, adjusting the colors, or changing the layout. Now we will explore how to create pie charts using Plotly. Pie charts are useful for visualizing proportions and percentages of different categories within a dataset. Let's start by creating a pie chart to represent the distribution of sales across different product categories. We have a list of product categories stored in the categories list and their corresponding sales percentages stored in the sales percentages list. To create a pie chart, we can use the pie trace provided by Plotly. Let's write the code together and see how it affects the output. There was a wrong display there since we didn't set the fig. Now it's okay. In the code above, we create a figure object and specify the data we want to plot using the pie trace. We provide the categories as labels and the sales percentages as values. As you can see, a pie chart is displayed representing the distribution of sales across different product categories. Each category is represented by a slice of the pie, and the size of each slice represents the proportion of sales within that category. Pie charts are effective in displaying relative proportions and making comparisons between categories. They provide a visual representation of the distribution and help in identifying the dominant or least significant categories within a dataset. We can further customize the appearance of the pie chart by adding labels, adjusting colors, or highlighting specific slices using the hover info attribute. Now we will explore how to customize slices, labels, and annotations in pie charts using Plotly. These customization options allows us to enhance the visual representation and make our pie charts more informative. Let's start by customizing the slices of a pie chart to highlight specific categories. We have a list of product categories stored in the categories list and the corresponding sales percentages stored in the sales percentages list. To customize the slices, we can use the marker attribute within the pie trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the pie trace. We provide the categories as labels and the sales percentages as values. Additionally, we customize the color of each slice by setting the colors attribute within the marker dictionary. As you can see, the pie chart is displayed with the custom colored slices. Each category is represented by a slice and the color of each slice is determined by the specified colors in the colors list. This customization makes it easier to differentiate between categories and adds visual appeal to the chart. We can also customize the labels of the pie chart to display additional information. Let's update the code to include custom labels. In the code above, we create a labels list by combining the category names and sales percentages using a list comparison. We update the labels attribute of the pie trace to include the custom labels. As you can see, the pie chart is displayed with custom labels for each slice. The labels provide additional information by showing both the category name and the corresponding sales percentage. Now we will explore how to create sunburst charts using Plotly. Sunburst charts are useful for visualizing hierarchical data and displaying proportions at different levels of hierarchy. Let's start by creating a sunburst chart to visualize the sales breakdown of different product categories and subcategories. We have a nested dictionary sales data that represents the hierarchical structure and sales percentages of the categories and the subcategories. To create a sunburst chart, we can use the sunburst trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the sunburst trace. We provide the labels, parents, and values for each segment of the sunburst chart. As you can see, a sunburst chart is displayed representing the hierarchical structure and sales percentages of the different categories and subcategories. Each segment of the sunburst chart represents a category or subcategory, and the size of each segment corresponds to the sales percentage. Sunburst charts allows us to explore the proportions at different levels of a hierarchy and identify the contributions of each category or subcategory to the overall sales. We can further customize the appearance of the sunburst chart by adjusting the colors, adding labels, or changing the layout. Now we will explore how to create box plots using Plotly. Box plots, also known as box and whisker plots, are useful for visualizing the distribution statistics of a dataset and identifying outliers. Let's start by creating a box plot to analyze the distribution of values in different categories. We have a list of categories stored in the categories list and corresponding datasets stored in the data list. To create a box plot, we can use the box trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and loop through each category and dataset. For each category, we create a box trace and provide the dataset as the Y attribute and the category name as the name attribute. As you can see, a box plot is displayed for each category, representing the distribution of values within each dataset. Each box plot includes several components: a box that represents the interquartile range, a line within the box that represents the median, and whiskers that extend to minimum and maximum non-outlier values. Box plots allows us to quickly analyze the distribution statistics of a dataset, including the median, quartiles, and potential outliers. They are particularly useful for comparing the distribution of values between different categories and identifying any variations or anomalies. By the way, I need to add that we displayed three graphs, and at the lower side we can see our three of our categories together, like this. Now we will explore how to create heat maps using Plotly. Heat maps are useful for representing data matrices and visualizing the magnitude of values using colors. Let's start by creating a heat map represent a data matrix. We have a two-dimensional list data matrix that represents the values in each cell of the matrix. To create a heat map, we can use the heat map trace provided by Plotly. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the heat map trace. We provide the data matrix as the Z attribute. You can see a heat map is displayed, representing the values in each cell of the data matrix. The colors in the heat map correspond to the magnitude of the values, with higher values shown in darker colors and lower values shown in lighter colors. Heat maps are particularly useful for identifying patterns and trends in large datasets. They allow us to easily spot clusters, outliers, and variations in the data. We can further customize the appearance of the heat map by adjusting the color scale, adding labels, or changing the layout. Now we will explore how to customize color scales and add annotations to our heat maps using Plotly. These customization options allows us to enhance the visual representation and provide additional information to our viewers. Let's start by customizing the color scale of our heat map. By default, Plotly uses the weirdest color scale, but we can choose from a wide range of predefined color scales or create our own. To customize the color scale, we can use the color attribute of the heat map trace. Let's write the code together and see how it affects the output. In the code above, we create a figure object and specify the data we want to plot using the heat map trace. We provide the data matrix as the Z attribute and the color scale attribute to blues to use a different color scale. As you can see, the heat map now uses the blues color scale, where lighter colors represent the smaller values, and darker colors represent larger values. Choosing the right color scale can significantly impact the perception of the data and highlight important patterns or trends. Now we will explore how to create three-dimension scatter plots and surface plots using Plotly. These visualizations are particularly useful for representing data with three dimensions. Let's start by creating a 3D scatter plot. We will use the scatter 3D trace provided by Plotly to create the plot. Let's write the code together and see how it affects the output. In the code above, we define three lists x, y, and z to represent the coordinates of the data points in the three dimensions. Next, we create a figure object and specify the data we want to plot using the scatter 3D trace. We provide the x, y, and z attributes to define the positions of the data points. The mode is set to markers to indicate that we want to create a scatter plot. We also customize the marker size and color using the marker attribute. As you can see, a three-dimensional scatter plot is displayed where each data point is represented as a marker in three-dimensional space. The size and color of the markers can be customized to convey additional information about the data points. Now we will explore how to customize axes, grids, and lighting in our 3D plots using Plotly. These customization options allows us to enhance the visual representation and provide a better understanding of the data. Let's start by customizing the axes of our 3D plot. We can modify the range, labels, and tick values of the axes to better represent our data. Let's write the code together and see how it affects the output. Also, I'm going to use the upper code here. I copied it and I will paste it. It's the same code. I'm not changing anything, but I'm going to edit and modify it. I'm sorry for the typo there. I can cut this, but I'm not going to cut it because I also want to show you that how I fixed the code. We were missing x-axis here and we didn't close a parenthesis, and we both did, and after that our code works nicely. As you can see now, we have a three-dimensional visualization. In the code above, we define three lists x, y, and z to represent the coordinates of the data points in the three dimensions. Next, we create a figure object and specify the data we want to plot using the scatter 3D trace. We provide the x, y, and z attributes to define the positions of the data points. The mode is set to markers to indicate that we want to create a scatter plot. We also customize the marker size and color using the marker attribute. To customize the axis, we use the update layout method of the figure object. Within the scene attribute, we customize each axis individually by providing a dictionary with the desired modifications. We can specify the title, range, tick mode, tick 0, and dtick to control the appearance of the axis. As you can see, the axes of the 3D plot are customized with new labels, range, and tick values. These modifications allows us to provide more meaningful information about the data and adjust the scales according to our needs. I'm going to add this datasets link in the description of this video, and you can download it for trying the codes by yourself. Let's directly start. We are going to start by the importing libraries. We will say import pandas as pd, and we are going to import matplotlib.pyplot as plt, and we can import numpy. Maybe we can use it when we are doing our data analysis. And now we are going to turn our CSV file into a pandas data frame. For that, we are going to say data, and we will use read CSV from pandas, and we will say shopping trends.csv. And let's display the first 5 rows for checking our data is read successfully, and it's looking great. So we have customer ID as index column, age, gender, item purchased, category, purchase amount, location, size, color, season, review rating, subscription status, payment method, shipping type, discount applied, promo code used, previous purchases, preferred payment method, and frequency of purchases. So as we can see, we have both numeric and categorical columns. And let's get general information about our dataset. So we can say data.info, and we can get the general information. We have information like the memory usage and the data types, etc. Okay, let's get the numerical summaries of the numerical columns. So for that, we will say data.describe, and we are going to get the summary for the numerical columns. So for example, from here we can say that our average age is 44 and our minimum age is 18 and the maximum is 17. And from here, by checking the customer IDs maximum, we can see the row count. Actually, let's check it. Maybe it can't be accurate. So we will say data.shape, and it's correct, 3,900. We can see the average purchase amount, the minimum and maximum. I think it means, yeah, it is in dollars. And we can see that we have review rating. Average rating is 3.74 and seems great. Okay, let's check if our data have any NA values. So we will say data.isNA, and when we run like this, we are going to get booleans, like we have true and false for all rows. And if we say .sum, we are going to get the counts of the NA valued rows. So we don't have any, and let's check for the duplicates. So we can say data duplicated and get the, you can see the booleans, and we can say sum for getting the total count of it, and we have 0. Great. Okay, let's plot a histogram of age, and for that we can say data age.plot, and let's set the kind as histogram, and we can give it a title like plt.title histogram of age, and here it is. So if we don't want this text to appear, we can say plt.show at the end, and you are going to see that it's going to disappear. Great. Okay, let's call our columns and see what we can do with them. So I will say data.columns, and you can stop the video for checking what columns we have. I'm going to stop the record and I will check. Okay, let's generate a bar plot for gender distribution. So for that we will say data, gender, and we will use value counts. And let's use dot plot, and we are going to set the kind as bar this time. And let's say plt.title, and it's going to be bar plot of gender distribution. And let's use plt.show, and I think I need to put a space in here. Great. Okay, let's do a group by operation. Let's group our data by category and calculate mean purchase amount. So for that, we will say data.groupBy, and we will say category, and we are going to take the values of purchase amount in dollars, and we will say that mean aggregation function. Great. Actually, you can manipulate this result, like you can say sort values, and for sorting in descending order, you can say ascending, and you can just put false for getting the descending order. And what you can do, let's say you want to take the top two, then you can just say after the sorting dot head, and you can write 2 in here, and you are going to get the maximum 2 here. So for the bottom ones, you can just use tail like this, or if you want to see the 3 of them, you can just do like this. Great. Okay, let's sort our data by review rating. So for that we will say data.sort values, and we will say review rating, and let's set ascending as false, which means we are going to sort our data in descending order. So I think review rating will be right in here. Great, it's sorting in descending order, but if you want to keep this sorted version, but let's just check the original data frame, we are going to see that the original sorting didn't change. So what you can do in here is you can just say data equals to this sorted version, or we have a simpler solution. We can just say in place equals to true, and it's going to update the original data frame this time. So whenever we call the data like this, you are going to see it's going to be sorted in the descending order based on the review rating column. Okay, let's create a pie chart for subscription status. So for that we will say data subscription status, and we are going to say value counts, and we will use, actually we need parentheses, and we will say dot plot, and this time we are going to set the kind as pie, and let's say plt.show again, and actually not show, we are going to say show, right, but we need to give this a title for it to look better. Let's say pie chart of subscription, and let's get this. Okay, let's use value counts on color for counting the occurrences of each color. So for that we will say data color, and we will use value counts, and here it is. Actually we can just sort it, but I think it's sorted in descending order. Great, we can just get the top 5 in here, and it looks great. Okay, if you want to visualize this kind of information, you can just do dot plot, and you can just say kind pie like this for seeing this kind of information visual. Great. Let's generate a scatter plot for previous purchases against review rating. I'm not sure it's going to be meaningful thing, but let's try it out. So we will say data plot, and we are going to say x is going to be equal to the previous purchases, and y is going to be equal to the review rating, and we are going to say kind, and we will say scatter. Also, let's give this a title like scatter plot and previous purchases and review rating, and let's use plt.show in here. Great. I think it is not, it doesn't have any meaning, but okay. So maybe we can do different thing. We can just plot the first 10. Actually it's going to be meaningless again, but let's just see it out. Okay, And since this is sorted, it has the same values, and if we say like 75 in here, we are going to have different values than 5. Actually, we have different values, but most of them are 5. Great. Okay, let's do some more group bys. Actually, group bys are really useful when you are doing data analysis because you can find really good information with grouping data. Let's group our data by season and find the sum of purchase amount. So for that, we will say data group by, and we will say season, then we will say purchase amount United States of American dollars, and we will say sum, like this. Actually, we got an error. I think it's because the column name. Okay, I'm just going to check the correct version. I think we need capital letter in here, and this time we are going to get accurate thing. Great. Okay, let's create a box plot for purchase amount based on frequency of purchases. For that, we will say data.boxplot, and we will say column is going to be equal to the purchase. Actually, I'm mistyping it. Purchase amount USD, and I'm just going to change this. Purchase amount USD, and we will say buy, and we will say frequency of purchase, and let's say plt.title and box plot of purchase amount based on frequency of purchases, and we will use plt.show again, and here it is. Great. Okay, let's do a value count for preferred payment method. So for that, we will say data preferred payment method, and we are going to say dot value counts, and it's going to be right in here. Great. I think the most preferred one is PayPal. We can just quickly check this, like we can use maximum aggregation function, and it's 677, and which one was the 677 is PayPal. Great. So how we can check the maximum? Like, it's not necessary in here, but imagine that you have thousands of rows like this in this series, and you can just do sort values, and you can sort it by descending order, and you can just say head and 1. So what will happen is we are going to see the PayPal in here. This is just a method that you can do. Or for seeing the least using one, you can just use tail, and you can see that it's bank transfer. Great. Okay, let's create a pivot table for location and item purchased with the mean of purchase amount USD. So for that, we will say pandas.pivot table, and we will say data. Let's give the values as per. It's actually like the Excel. We will say purchase amount USD, and we will set index, and we will say at the index side location. Then we will say columns are going to be equal to the item purchased, and we will say aggregation function, and it's going to be mean. Great. Here we have the data we wanted. So at the columns we have the items, and at the rows we have the locations, and at the cells we have the dollars and their mean amount. Great. Okay. Actually, it looks a little bit complicated. For just seeing it simply, we can just use head in here again, and you can see we got the information we wanted at the starting. Great. Okay, let's group our data by size and calculate the mean of purchase amount USD. So for that, we will say data group by, and we will say size. Then we will say, actually, brackets, we will say purchase amount USD, and we will use mean aggregation function. Great. Okay, let's group our data by payment method and find the sum of purchase amount dollars. So we will say data group by, and we will say payment method, and we are going to get purchase amount dollars, and we will use some aggregation function. Here it is. Okay, now let's group our data by discount applied and calculate the maximum review rating for that. So for that, we are going to do data group by, and we will say discount applied this time, and we are going to get the values of review rating, and we will use dot maximum, actually x. Great. Actually it's meaningless because we have 5 and we can just take the mean of it instead of maximum. So this time it's going to be meaningful. Great. Let's group our data by color and count the occurrences of each category. For that we will say data group by color, and we will say category, and we will use dot value counts. Great. Okay. Actually I'm trying to cover a lot of different stuff, like we covered some aggregation function with group bys, mean in here, value counts in here. I'm doing a lot of group bys because they are super important and I want to show them in the video. Okay, let's group our data by frequency of purchases and find the mean previous purchase. For that we will say data group by, and we will say frequency of purchases, and we are going to take the values of previous purchases, and let's actually purchases, and let's use median this time. Great. Okay, let's group our data by season and calculate the mean review rating. So for that we will say data group by, and we will use season, then we will say review rating, and we can use dot mean like this. Let's do some more data visualization before finishing the video, and then we can finish this project. So let's create a bar plot for season with the count of each season. So we will say data season, and we will use value counts, and we are going to use the plot, and let's set the plot as bar plot, and then we will say plt x label season, and we are going to say y label count, and let's give this a title like count of purchases in each season, and we will use plt.show. Great. Okay, let's create a pie chart for category distribution. So for that we will say data, and we will say category, and then we are going to use value counts again, and we are going to use plot, and it's going to be equal to the kind pie, and we can just give this a title like distribution of purchases by category, and we are going to use plt.show at the end, and here is our pie chart. Okay, now create a box plot for review rating based on gender. So we will say data box plot again, and we are going to say column is going to be equal to the review rating, and we will set the by as gender this time, and we will say x label, we will give gender in here, and we will say y label, we will give review rating in here, and we are going to say plt.title review rating distribution by gender, and we will use plt.show at the end. Great. By the way, I'm not evaluating any of the results of the plots group bys because I'm showing the technical part, and this commenting thing can actually differ by domain to domain, and you can just write comments if you are going to add this to your portfolio. Like from checking this box plot, we can say that male customers are likely to give more rating on the review side based on this box plot. How you can understand this is the male box plot in here is way higher at the minimum and the maximum both sides, and the mean of it is higher than the female one. So we can just make a comment like this, and for the others you can, for example, you can see the distribution of purchases by category is maximum at the clothing and minimum at the outerwear, and you can make comments like this if you are going to put this to your portfolio. If I do comments like this, the video is going to be like 3 or 4 hours, so that's why I'm skipping it. Okay, let's create a histogram for purchase amount with 10 bins. So for that we will say data purchase amount USD dot plot, and we will say kind histogram, and we will set the bins as 10. Then we will say plt x label, let's say USD shortly, and plt y label frequency, and we will say plt.title histogram of purchase amount distribution, and we will use plt.show at the end of it. Great. Okay, let's group our data by color and plot a bar chart for mean review rating. So for that we will say data.group by, and we will get the color in here. Then we will say review rating, and we will use .mean, and we will say .plot kind is equal to the bar, and x label color, y label mean review rating, and title mean review rating for each color, and we will use plt.show. Great, but it seems a little bit complex because we have a lot of values in the x-axis. So what we can do easily is we can just get .head in here, and we are going to get the random selected 5, and great. Let's move on. Let's group our data by payment method and plot a pie chart for the sum of purchase amount. So for that we will say data group by, and we are going to say payment method, and we will say purchase amount USD, and we are going to take the sum of this. Then we will say plot, and it's going to be equal to the pie, and we will say plt.title. Then we will say sum of purchase amount by payment method, and let's use plt.show at the end. Great. Actually you can see that we have a y label in here. For fixing it you can simply do plt.y label, and you can just enter an empty string in here, and you are going to see it's going to look way smoother. Okay, let's do final 1 or 2 visualizations and then finish this project. Let's group our data by frequency of purchases and plot a box plot for purchase amount. So for that we will say data box plot, and we will say column is going to be equal to the purchase amount dollar, then we will say by, and then we will say frequency of purchases, and then we are going to say x label is going to be equal to the frequency of purchases, and y label is going to be equal to the purchase amount dollar. Then give this a title like purchase amount distribution by frequency of purchases, and we can just use plt.show at the end. Great. Okay, let's do a final one. Let's group our data by season and plot a pie chart for the sum of purchase amount. So for that we will say data group by season, and we will say purchase amount dollar, then we will use sum, and we will say plot, and it's going to be equal to the pie. Then we will say plt.x label, and we are going to say season for the x, and y label we will say sum of purchase amount USD, and we will use plt.title sum of purchase amount by season, and we will use plt.show. Great. Seems great. By the way, if you want to change the aggregation function on this, like you can just change the sum with mean for getting the means in the chart, or you can just change it to median, and you are going to see that it's going to change up. You can just get maximum of aggregation functions like in here, or I don't know, minimum maybe, and you can just change it like this. Okay, let's just fix this to sum and finish our video. That was all from me for this project. There's two types of machine learning, supervised and unsupervised. In the supervised machine learning, we have features like x1, x2, x3, and we have a label. So think this like we have 2 as the x1, 3, 4, and our label is 8. We are predicting this y with these features, so we have label in supervised learning. In unsupervised learning, we have x1, x2 features, but this time we don't have a label. Like we have 1 and 2 in here, but we don't have any more information. So think this unsupervised learning thing like we have features in here and features in here, and this is just like a grouping thing. But in the supervised learning, we know the true values, so we can train models and we can make predictions. Also, we can make predictions on the unsupervised learning side too. But we will never know how good is our predictions. But in the supervised learning, we can test our models like with think it like we have 100 data points and we can train our model on 80% of the data and we can test the performance on the 20% of the data. This is also referred as train test plate, and we will also cover that in the course. And in the supervised learning side, there's different things like we will look at two problem types, regression and classification. So, what are them? In the regression side, we are just going to see problems like our y variable, our target, is going to be continuous, like it can be 30, 3000, and we are just going to predict this like we are going to have a line like this. It doesn't need to be in a linear form. Also, it doesn't need to be a line, but just for the concept. And we are going to have the features and we are going to have the label. With this line, let's assume that we are going to predict this point. But in the classification side, we are going to have classes like our y variable is going to be something like 1, 0, maybe 2. And how this is going to look like is I'm just going to show you the graph of the logistic regression. Our y and x is going to be in here, and for the y, let's say the output is going to 0 or 1, and here is the logistic regression line, and we are going to make predictions with these x values on unseen data, and we are going to get classes like 1 and 0. Like think this like, let's give it a real world example on this too. Like at the regression side, we can just predict the salary someone is earning based on their education. Like if the education is 8 years, then the salary is going to be 40,000, and if the education is 12 years, then the salary is going to be 60,000. And at the classification side, what we can say is we can predict the sickness based on blood values, like let's say blood test value, and let's say this value is 10, so we are going to say sick, and if it's 5, then we are going to say not sick, and we can use classification like this. So let's start coding. We will use Scikit-learn for applying the machine learning models. First things first, make sure you have Python installed. If not, you can download it from python.org. Once that's done, you can install Scikit-learn library using pip. Like you can open the terminal and you can say pip3 install Scikit-learn. Also pip works sometimes. Actually it's like install scikit and we need this. And we have the Scikit-learn right now. Also sometimes pip3 won't work and you can just go with pip install scikit-learn and this will work. Great! Now we will get a dataset to work with. I'm going to use the datasets which comes with Scikit-learn library. Let's use Iris. We will use different datasets too in this course. So what we are going to do is we will say from sklearn.datasets import load iris, and after that we are going to say iris, and we will use load iris method, and we will set the data like iris.data, and we are going to set the target like iris.target. And what else we can do right now is we can just check if they are installed successfully, like you are going to see array like this, and at the target side you are going to see a similar thing. And from this we can understand that our target y is like the classes 0, 1, 2, so we have a classification problem at the side. Now let's understand the structure of this dataset. So what we can do is, let's say print feature names, and what we are going to say is iris.feature names. There's information about flowers, I guess, and let's say print target name, and we will say iris.target names, and target names are these classes. Like, I'm not sure what are they, but think this like if it's 1, I'm just giving an example, it's verse color, and if it's 0, it's setosa, and etc. And let's see our data shape. So what we're going to do is we will say print data shape, and we will say data.shape after that. So this means that we have 150 rows and 4 columns in our data at the X side. Great. Now we are going to talk about techniques for data pre-processing. This is a pivotal stage in any machine learning project, and Scikit-learn provides us with powerful tools to make this process seamless. So let's firstly convert our data frame to a Pandas data frame for better visualization. So what we can say is, also we need to import Pandas firstly, and then what we are going to say is data frame is going to be equal to the pandas.dataframe, and we will say data and columns are going to be equal to the iris feature names. But if we run like this, you are going to see that your data frame won't have the target. So what we are going to do is we are going to set the target as target, and then when we call our data frame, we are going to see that our data frame seems nice. Great, let's jump into some common pre-processing techniques. We will cover cleaning, normalization, and feature scaling. So what if we want to check for missing values? We are going to do dataframe.isNull, and we will use .sum after that, and we don't have any values in here. So now let's cover normalization. We will say from sklearn.preprocessing import min max scalar, and what we are going to do is we are going to initialize this scalar equals to min max scalar class, and we are going to say normalized data is going to be equal to the scalar.fit and transform data. So remember, data was our X features, and when we call them again, you are going to see they are going to be different from this normalized data. Like we have values like 7, 6, and if I call normalized data right now, you're going to see all the values are going to be scaled, and we have such low values in here. So this is a really common thing if you have different scaled values in your X. Like at one side you can have salary like 70,000, 80,000, and you can just have a car option at the X side, and their labels is going to be like 1 and 0. So at one side there is 80,000, at one side there is 1 and 0. So you need to scale your data before training your model. So now we are going to cover feature scaling. For that we will say from sklearn.preprocessing import standard scalar, and we are going to initialize this like scalar is going to be standard scalar, and we are going to say scaled data is going to be scalar, and we will use the fit transform method again, and we will pass the data. So when we call our scaled data, you are going to see the values are going to be really low, and they are going to differ from the original x values. Great. Normally, we do all the scaling operations after splitting our data for getting rid of data leakage, and we are going to cover train test split right now. Remember we talked about it, like we are going to separate our data. We will put some data in the training set and we will put some in the testing set. So we are going to have the chance to evaluate our model. Train test split is crucial for building models that generalize well to new unseen data. So how we do that is, we are going to say from Scikit-learn.model selection import train test split, and we will say xtrain, xtest, ytrain, ytest is going to be train test split. We will say data, target, and we are going to set the test size, like it's going to be the percentage which is going to be in the testing data, like the 20% of the data is going to be in our testing set right now. This 20% is a really common value, you can use that. And if we check xtrain shape right now, we are going to see we are going to have 120 rows in our xtrain, and also we are going to have the same in the ytrain. And if you check xtest, like xtest.shape, you are going to see we are going to have 30, and at the ytest we are going to have 30. Now, why we do this? Well, by splitting our dataset into a training set and a testing set, we can train our model on one set and evaluate its performance on another. This helps us ensure that our model doesn't just memorize the training data, but can generalize well to near unseen data. Now we are diving deep into the evaluation of classification models. It's not just about accuracy that you're going to see a lot when you are creating machine learning models. We are going to explore precision, recall, F1 score, and the confusion metrics. I'm going to use a k-neighbors classifier model for showing the metrics. We'll cover this model later in the course. I'm also going to do same type of section for the regression side, but don't worry, we are going to cover this model thing, .fit command, .predict command in the modeling side. For now, I'm just going to show you this because you are going to understand this model performances on the modeling side of the course, and I think this path will be better for the learning machine learning. So let's start by importing the libraries that we are going to use in this section. So I will say from Scikit-learn.metrics, we are going to import our evaluation metrics from here for both regression and classification problems. And then I will say import accuracy score, precision score. I'm going to explain all of them with simple sentences, but I have a full video about them. You can just check it for learning about them more. I will import recall score, F1 score, and confusion metrics. And then I'm going to import the example model. I will say from Scikit-learn.neighbors import k-neighbors classifier. And then after the imports, I will say knn, and I'm going to initialize the model class. I will say k nearest neighbors classifier, and let's say number of neighbors equals to 2, and then I will say knn.fit, and I'm going to fit this model into a training set. And then using this model, I'm going to make predictions on the test set with using .predict. I'm going to make the predictions based on xtest, and I will compare the performances with ytest. So I will say predictions is going to be equal to the knn.predict xtest, and if we just check predictions, you are going to see it's an array which have our values. So we can understand from this too that with this xtest's first row, like with this, our model predicted this class 2. So now we can get our evaluation metrics. So for at the accuracy side, I will say accuracy score, ytest, and predictions. So here are our predictions, and it's just going to look with the ytest. It's going to compare, like we predicted 2, but the original one was 1, so it's a wrong prediction, and it's going to give us the Model success, like how well this model works on unseen data. We can think it like that. Accuracy measures the overall correctness of the model. So, the next step is precision. So how we can get this is we are just going to say precision score. We are going to give y-test and predictions, and we are going to say average equals to weighted. And so precision indicates the proportion of true positive predictions out of the total predicted positives. So now we are going to talk about recall. I will say recall score, and we are going to give y-test, predictions, and let's give average as weighted. And we are going to see our recall score. By the way, they are coming equal like 0.9333, but in the real world it's not going to be like that, and each of them have a different use type. Recall measures the proportion of true positives out of the total actual positives. So we will check F1 score right now, and we will give y-test predictions, and let's get the average as weighted. And we can define this as a balance between precision and recall. At the last step, we are going to see the confusion matrix, like confusion matrix, and we will give y-test and predictions. And we are going to see an array like that for the true positives, true negatives, false positives, and false negatives. All of the upper metrics are calculated from these confusion matrix. Great. Now we are shifting our focus to regression models and how to evaluate their performance. We will be covering mean squared error and R-squared. We will be still using the iris dataset, but this time we will select our label differently, which will make us predict continuous values with our model. Like now, let's check the y. It's something like 1, 2, 1, 0, and we are just going to try to predict some of these values. Like we are going to select a y from this x values, and we are going to create our regression model on this. I will use a linear regression model. We will cover this model later on the course. So what I'm going to do is I'm going to say from Scikit-learn.linear model import linear regression, and from Scikit-learn.matrix this time we are going to import regression metrics like mean squared error and R-squared score. Great. So this time we are going to recreate our dataset, like iris is going to be equal to the load iris, and we are going to set data as iris.data, and then we are going to do y is going to be equal to the data, and we will do this filtering. Like you are going to see right now the y, it's the sepal length, and you can see we have values like 5.1, 4.7 instead of classes like 0, 1, and 2. So we are going to work on a regression problem right now. And we need to update our xtrain, xtest, ytrain, and ytest. And we will use train, test, split, and we will say data and y, and we will say test size equals to 0.2. And great. So at the y side, like ytest and ytrain, we have the continuous values right now. Like you can just check ytrain 2, and we are going to have a similar thing. Great. Let's create our regression model. Like regression model is going to be equal to the linear regression class. We are going to initialize this, and then I'm going to do regression model.fit, and I will use the training data we have. And at the next step, we are going to do predictions with this, like regression model.predict xtest again, and these are our predictions, and now we are going to compare them with ytest. So what I'm going to do is I'm going to save these predictions like regression model.predict xtest, and at the next step we can use our evaluation metrics. So let's start with mean squared error. So we will say mean squared error, and we are going to say ytest and predictions. And now we are going to see our mean squared error. At the mean squared error side, it's better to be this value is lower. Like If it's lower, your model is better. Mean squared error measures the average squared difference between the predicted and actual values. Remember that actual values are the y-test and predicted ones are the predictions. Lower values indicate better performance, as I just said. So let's just use r squared, like r squared score, and we will say y-test and predictions. And what is r squared is, by the way, it takes value between 0 and 1. It's just like impossible in the real world scenarios, like r squared can't be this good, but it's just an example dataset. And what r squared is? R squared represents the proportion of the variance in the dependent variable that is predictable from the independent variables. It's not like mean squared error. A higher r squared indicates a better fit. Great, now we can start to learn the machine learning models. We will start with classification models and keep with regression models. And then we are just going to look at the unsupervised learning side. We will start with k-nearest neighbors, a powerful algorithm for classifying data based on its proximity to other data points. We already imported it in the example classification metrics side, and I'm just going to re-import it because we are just going to learn modeling and it's better to remember this, I guess. I will say from sklearn.neighbors import k-nearest neighbors classifier, and we are going to reload the dataset. Since it's set for the regression problem, I will say iris equals to load iris, and I will say data equals to iris.data and target equals to iris.target. And our target is going to be like 0, 1, 2 again, like you can see from here. And we are going to redo the train test split. It's better to do this again because you are going to see this a lot, because if you are training a machine learning model, you need to know how well it performs. So I will say train test split, data target and test size is going to be equal to 0.3 for now. By the way, setting this to 0.3, it means that in the training side of our dataset, there is going to be the 70% of the total data, and at the test, we are going to have the 30%. Great. By the way, at the modeling side, we have parameters for all the models, and in this course, we are going to look for them and how we can optimize this model's performance by hyperparameter tuning, and I'm going to teach it also. Great, let's initialize our KNN classifier. So KNN is going to be equal to the k-neighbors classifier, and then we are going to fit this into our training data like xtrain, ytrain, and we are going to make predictions with that. So we will say predictions equals to knn.predict, and we will use xtest, and we can just get accuracy. It's the most common one, so we will say accuracy score and y-test with predictions. Great. The KNN algorithm classifies a data point based on the majority class of its k nearest neighbors. The value of k is crucial hyperparameter that we'll explore in a second. Let's talk about hyperparameter tuning again. Hyperparameter tuning involves optimizing the settings of a machine learning model that are not learned from the training data but set prior to the training process. These settings, known as hyperparameters, they have significantly impact the model's performance, and the tuning process typically employs techniques like grid search or random search to find the best combination of hyperparameter values, enhancing the model's effectiveness on unseen data. Hyperparameter tuning is crucial for achieving optimal model performance and generalization across different datasets. We will cover hyperparameter tuning steps for every model in this course once again. Now we will focus on finding the optimal value for the hyperparameter k in KNN algorithm. This step is crucial for fine-tuning our KNN model and achieving the best possible performance. So what we are going to do is, let's just initialize our model again, like KNN is going to be equal to k-neighbors classifier, and we are going to define the parameters that it can take. Like we are just going to say param grid, and It's the most common usage. You can just use it like that. And we are going to use a dictionary. For each parameter, you will say the keys and values like this. And we are going to give 1 to 30. And we are just saying our grid search that you are going to look for these values one by one and find the best performing one. If we were going to add a different parameter than this, we are just going to say a, and it can be like list of strings like 1 2 3 but or abc, but we are just going to cover that because other models have parameters like this. At the kernel side we won't need that. And now we are going to import the grid search. So I will say from Scikit-learn.model selection import grid search cross-validation. And what we are going to do is we are going to initialize this like grid search. We will say grid search cross-validation and we will give the model firstly, and then we are going to give our parameters. And by the way, we need equal sign after this. I made a typo. And then we are going to say cross-validation, like we can just set this to 2 and I'm just going to explain it in a second. This CV cross-validation is a resampling method used to test the model's generalization ability using out of the sample data chunks. So I'm just going to run this, and what I'm going to do right now is I'm just going to use this grid search and I will use the fit method, like fitting the base models, and we will use xtrain and ytrain. And after that, this process, we can just get the best parameters for every model, like grid search, best parameters, and underscore also. And we are going to see number of neighbors 7 was the best performing one. Also, we can make predictions with grid search object like predict, but I'm just going to show you a different thing. I will say best parameters and I'm going to say number of neighbors, and after that we are going to get this 7 in here, and I'm just going to set this as best k. And then what I'm going to do is I will say best knn, and I will recreate model like k neighbors classifier, and I will set the number of neighbors to the best k. And I'm going to create this model like this, and I'm just going to fit this using my training data. We will train this model xtrain, ytrain, and after that I will get the predictions best knn.predict xtest, and let's get the accuracy score in here, like accuracy equals to accuracy score ytest and predictions, and let's just call the accuracy in here, and we are going to see it's 0.95. So accuracies remain same because it's an example dataset. In the real world scenarios, your model performance will increase this with this grid search, and 0.95 is a really high accuracy, and you will get better performing models if you use grid search. And we are going to cover this method for every single model that we are going to cover in this course. Okay, let me just repeat. Grid search cross-validation search through a specified parameter grid, in this case different values of k, and evaluates their performance using cross-validation. The result is the best parameter value that maximizes model performance. Now we are shifting our focus to another powerful classification technique, decision trees. Decision trees are intuitive, easy to understand, and capable of handling both numerical and categorical data. Algorithms like decision tree and random forest, called as tree-based methods, and we are going to say from Scikit-learn.tree import decision tree classifier, and then we will say data frame, decision tree classifier is going to be equal to the decision tree classifier. We are going to initialize our model, then we are going to train the model on the training set. So I will say decision tree classifier that fit xtrain, ytrain, and after fitting our model we are going to do predictions with it. We will say data frame classifier. Actually I read the T like F, so why I called is as data frame it's decision tree, and we can just get our accuracy score like y-test and predictions. So our accuracy score is 0.93. Great. Decision trees work by splitting the data based on features, creating a tree-like structure. Each leaf node represents a class label. The depth of the tree and other hyperparameters play a crucial role on its performance. Now let's discuss parameter tuning for decision trees. We will focus on finding the optimal values for the tree depth and the splitting criterion. So I will say parameters grid, and I'm going to set this like max depth is going to be range 1 to 11, and then we are going to set the criterion as Gini and entropy. And now we are going to use grid search to find the optimal parameters, like grid search equals to grid search cross-validation, decision tree classifier, parameters grid, and let's set the cross-validation as 3. And then we will fit this to our training data. Actually, I need to use lowercase. I will say fit xtrain and ytrain. And now we can just check the best parameters like grid search dot best parameters, and we are going to say best criterion is Gini and best max depth is 2. So what we are going to do, we are going to do a similar thing. I will say best depth, and it's going to be equal to the grid search dot best parameters, and we are going to take the value of the max depth. And after that, I will say best criterion, it's going to be equal to the grid search dot best parameters, and from here we will get the criterion. And now what we are going to do is we will say best decision tree classifier, and it's going to be equal to the decision tree classifier. Max depth is going to be equal to the best depth, and criterion is going to be equal to the best criterion. So after this, we are going to train this model with these parameters, like we will say dot fit xtrain and ytrain. After this step, we can make predictions with this model. Like what we can do is we can say predictions is going to be equal to the best decision tree classifier dot predict, and we will say x test. So after having our predictions, we will say accuracy score, y-test, and predictions. And here is our accuracy score. It didn't change again since we are using an example dataset, but in the real world, you can improve your model performance like this. Now we are going to talk about random forests. Random forests are a powerful extension of decision trees, providing improved accuracy and robustness through the combination of multiple trees. Like you are having more decision trees than one, and you are going to make predictions based on their results. So let's just import it from Scikit-learn.tree, import random forest classifier. And after this, we will say random forest classifier is going to be equal to the random forest classifier. And after this, actually, there's a problem. I just checked, it's taken to the ensemble like this, and after doing this, maybe it was in the ensemble, the entire process of scikit-learn development, I'm not sure, I remember like 3. And after this, what we are going to do is we will say random forest classifier dot fit, and we are going to fit this using xtrain and ytrain. And after that, we are going to make predictions like random forest classifier dot predict x test, and we are going to get the accuracy again with y-test and predictions. Great. Random forests work by constructing multiple decision trees during training and outputting the class that is the mate from that decision trees. It's the mode of the classes of the individual trees. Now let's discuss parameter tuning. For random forests, we will focus on finding the optimal values for the number of estimators, which we can also refer as trees, and the maximum depth of the trees. So we will define parameters grid, and we are going to create a dictionary. We will say number of estimators, and it's going to be like 50, 150, 200, 250, and then we can say for the max depth side we can say none, 10, 20, and 30. And now we are going to use grid search. We will say grid search, and it's going to be equal to the grid search cross-validation random forest classifier parameters grid, and let's set the cross-validation as 3, and we are going to fit this using grid search, and training data we have white train, and after this we are going to do check the best parameters like best parameters, and max depth is 10 and the number of estimators is 200 at the best parameters side. So what we are going to do right now is let's set best estimators as grid search dot best parameters, and we are going to take the number of estimators from here, and I'm just going to make copy paste because you already know the process. And what we are going to do in here is we will say best depth, and it's going to be best depth, max depth. Great. So we will create something like best random forest classifier, and it's going to be random forest classifier number of estimators is going to be equal to the best estimators, and max depth is going to be equal to the best depth, and that's it. We are going to train this model right now. Best random forest classifier dot fit x-train and y-train. So what we are going to do right now is we are going to make predictions with this. Predictions is going to be equal to the best random forest classifier dot predict x test, and after that, actually I made a typo, x test, and after that we are going to get our accuracy score predictions. Actually there's a problem, let me quickly check. Actually I need to give also the y test, and after that it's going to work smoothly. Here it is. Great, now we are going to talk about support vector machines. Support vector machines work by finding the hyperplane that best separates different classes. This hyperplane is chosen to maximize the margin between classes. It's great for both linear and non-linear datasets. So what we are going to do is I will say from Scikit-learn.svm support vector machines import support vector classifier like this, and after that we will initialize this like svm classifier is going to be equal to the support vector classifier, and then we will say svm classifier that fit, and we are going to fit this into our training data, like we are going to train the model, and after that we will store the predictions which we are going to make with this model in predictions variable, and after that we are going to do accuracy score, y test, and predictions. Great, 0.95. Okay, we were talking about a hyperplane. This hyperplane is chosen to maximize the margin between classes again. Now let's discuss parameter tuning for SVM. We will focus on finding the optimal values. For the kernel, it can be linear, polynomial, or radial basis function, and a regularization parameter C. So we are going to create parameters grid, and this time it's for support vector machines. We will say kernel, and it can take values like linear, poly, and RBF. And for the regularization parameter, we are going to say 0.1, 1, 10, and 100. Great. Now we are going to use grid search again. We will say grid search, and it's going to be equal to the grid search cross-validation support vector machines classifier parameters grid, and let's just set cross-validation as 3, and we are going to say grid search dot fit x-train and y-train. I'm going to correct my typo like grid search. Great. Now we have our model, and we can just check the best performing parameters like best parameters, and here it is, polynomial for kernel and 0.1 for C. Great. So what we are going to do is we are going to save this best parameter values like best kernel, and for just making this faster, I'm just going to do like this right now because we have the values, and for the best C side we will say polynomial. Great. It's same with writing grid search best parameters kernel and C. And now we will say best SVM classifier, and it's going to be equal to the support vector classifier, and we are going to set our parameters like best kernel, and then we will say C is going to be equal to the best C. And now with this, what we can do is we can train our model SVM classifier that fits X train and Y train. And after that, actually there's a problem. Let me quickly check. The C parameter must be float. So I think I made a mistake, like kernel is going to be polynomial and C needs to be 0.1. I missed that, and now we can do just train our model without problems. Great. Now we are going to do predictions, like it's going to be equal to the best support vector mentions classifier that predict X test, and we can just get our accuracy score with Y test and predictions we made with this model, and it's 0.95. Great. Now we are delving into regression techniques with Scikit-learn, starting with one of the fundamental models, linear regression. Linear regression is a powerful tool for predicting numerical values based on a linear relationship between features. We will also switch to a new dataset. We will use a different one. There won't be parameter tuning part of the linear regression, but the other regression methods we are going to have that. So let's just create our new dataset. Like we will say from Scikit-learn.datasets import load Boston, and after that we will say from Scikit-learn.linear model import linear regression. And actually there's a problem. Let me quickly check. It says load Boston has been removed from Scikit-learn, and what we can do right now is, so we can just try another dataset, like I found diabetes like this, and after this we can do like diabetes can be load diabetes, and after that data can be diabetes.data, and target can be diabetes.target, and after this we can just check target if it's a regression problem. Yes, it is. Great. So instead of Boston data, we are going to work with this diabetes data. Also, let's check the data side of things, and great, we have the values hidden here. So let's do the X train, X test splitting operation, Y train, and Y test is going to be equal to the train test split, and we will say data target. We are using the diabetes dataset. Let's use test size 0.2 this time, and let's just check this. Yes, we imported the linear regression, so we can directly use that. So what we are going to do is, let's say linear regression model is going to be linear regression class. Then we will say linear regression model dot fit, and we will train this model with X train and Y train, and we are going to get predictions, like predictions is going to be equal to linear regression model dot predict X test, and after that, after I correct the typo like this, let's just check the predictions. They are going to be continuous values. Like you can see, they are not like classes. And let's just get the mean squared error. We already imported it, and we will say Y test and predictions again. And here's our mean squared error. Also, let's get the R squared here, Y test and predictions. And here it is. Also remember that we want our score to be higher and mean squared error to be lower. Okay, now we are going to talk about ridge regression. Ridge regression is an extension of linear regression that includes regularization to prevent overfitting, which means that Your model fits on your training data well, but it performs really bad on unseen data. It, it doesn't predict the unseen data. It just remembers what you did in training data, and it's just not useful in real life. Also, we have a parameter for this, and for the next models, we are going to have parameters, and we are going to do hyperparameter tuning. So for importing the ridge regression, we will say from sklearn.linear model import ridge. And after that, we are going to initialize this like ridge model is going to be equal to the ridge. And now we are going to train our ridge model with base parameters like ridge model.fit. We will use xtrain and ytrain. And after that, we are going to get our predictions with this base model like ridge model.predict x-test. So we can just get mean squared error like y-test and predictions, and we can get r-squared score with y-test and predictions. Great. So ridge regression introduced a regularization term controlled by the hyperparameter alpha, which helps prevent the model from fitting the noise in the training data. Now let's discuss parameter tuning for ridge regression using grid search. We will set our parameters like parameter grid is going to be equal to the alpha is going to be 0.1, 1, 10 and 100. So after that we will say grid search is going to be equal to the grid search cross validation. We will say ridge model parameters grid and cross validation is going to be equal to 2. And now we are going to fit this into our training data, which means training the model, and we can just check the best parameters like grid search best parameters, and you will see alpha 0.1 is the best performing one. So let's just set this like best alpha is going to be grid search best parameters and alpha from here. And after that we can just create best ridge model, and it's going to be ridge alpha equals to best alpha. And after that we can train our model with this like best ridge model.fit xtrain ytrain, and we can just make predictions with this like predictions is going to be best ridge model, and we will give x-test in here. And actually there's a problem, let me quickly check. We need to use predict in here, and with that it's going to work. Great. So we can get our mean squared error in here like y-test and predictions, and we can get our r squared like y-test and predictions. Great. So actually I think, let me quickly check, with the base model we have 0.38 in r squared and we want it to be higher, and with the parameter tuned version we have 0.44. So we have an improvement in the model performance. Now we are going to talk about lasso regression. Lasso regression, like ridge regression, is a regularization technique that helps prevent overfitting and can perform feature selection. So we will say from sklearn.linear model import lasso, and after that what we are going to do is we will say lasso model is going to be equal to lasso. We are going to initialize this, and after that we are going to fit this using our training data, and we are going to make predictions with that lasso model.predict x-test. And what we are going to do now is let's just get the r score, r2 score and y-test and predictions. Also I need to add this in here. Great. Lasso regression adds a penalty term proportional to the absolute values of the coefficients. This can lead to some coefficients becoming exactly zero, effectively performing feature selection. Now let's discuss parameter tuning for lasso regression using grid search. We are going to say parameters grid, and we have the alpha parameter, and it can take values like 0.1, 1, 10 and 100. And what we are going to do right now is grid search cross validation, lasso model and parameters grid, and let's set the cross validation as 2. We will say grid search fit x train and y train. After that, we are going to get the best parameters like best parameters. Then let's set the best alpha, like best alpha is 0.1. Then we are going to create best lasso model. Lasso alpha is going to be equal to the best alpha. Then we are going to fit this like best lasso model dot fit x train and y train. Also, I want to show you something, that instead of doing this, retraining your model with the best value, you can just use this grid search and you can just use predict with this. It's going to be same, but since I'm teaching this, I'm just rewriting it every time for you to understand the models better. And after that, we are going to say predictions is going to be equal to the best lasso model dot predict and x test, and let's just get r squared for this y test and predictions, and we will get 0.43. The base model was 0.29, and in the regression problem we are seeing the improvement in the parameter tuning. Great. For the final regression technique, actually there's a lot more, but we are going to cover this one also since this is essential. We are going to talk about polynomial regression. Polynomial regression is a powerful technique that captures nonlinear relationships in the data by introducing polynomial features. Let's create a synthetic dataset for this. Like, I'm going to import Numpy and I'm going to import Matplotlib also. I'm going to make a visualization on this, pyplot as plt, and we are going to import preprocessing, import polynomial features from here, and I'm just going to run this like this. And now what we are going to do is we will say x is going to be equal to the, let's say 6 multiplied by numpy random 100 1 minus 3, and for the y side we can say 0.5 multiplied by x with the power of 2, and after that plus x plus 2, and we can do plus numpy dot random, and we will say 101. Great. So let's just check the x. We have values like this, and let's just check the y. Great. We have the values like this. So I'm just going to split the data like x train, x test, y train, and y test, and I will use train test split x and y, and let's set the test size as 0.3. And now what we are going to do is we will say polynomial features is going to be equal to the polynomial features. We will say degree equals to 2, then let's say include bias false, and we will say x train polynomial, and we will use x train, and then we will say actually we need to use polynomial features, and we will use fit transform method, and I will say x train after that. And now what we can do is we can just check the difference between x train and x train polynomial like this, and you will see the difference right now. And great. So now I will set polynomial regression model, and I will say linear regression. After that I will say polynomial regression model that fit x train polynomial and y train. After this we can just check our model performance, but we need to do like x test polynomial, and it's going to be equal to polynomial features that transform, actually fit transform, and we need to say x test. After that we will say predictions equals to polynomial regression model dot predict x test polynomial. Great. Now we can just check our score like y-test and predictions, and we will see it's 0.87. Actually, I said like I'm going to visualize this, but I'm not going to do that. And now we are going to shift our focus to unsupervised learning, and our topic is going to be k-means clustering. It's going to be the most common unsupervised learning method you are going to see. K-means clustering is a popular clustering algorithm that partitions data into k-distinct non-overlapping subgroups, which we can also refer as clusters. Let's use a synthetic dataset for our hands-on demonstration. So what we are going to do right now is, actually I can use Matplotlib. In here we will say from Scikit-learn Datasets, we will import make blobs, and we will import from Scikit-learn.cluster import k-means, the algorithm we are going to use. So we will say x and y, we will set make blobs number of samples 300, and let's set the centers as 3. This is the form of the x, and now we can visualize this. So we will say plt matplotlib.scatter, and we will take x and 0 in here. Then we will take x and 1 in here. And for the C side we will say y. Then we will say cover map, and let's say this for the cover map. Then let's set the edge color as k, and for the S we will say 50. I think it's edge color. If it's wrong, I will just fix it. And let's say for the title side, say synthetic dataset with clusters. And for the X label, let's say feature 1, and for the Y label, let's say feature 2, and we will use plt.show at the end. And here it is. So here we have 3 groups, and in our model we are going to group this. Like for each color we are going to say they are going to be clusters, so we are going to set the number of clusters as 3, and by this we can make predictions like if a data point comes between the yellow and the green ones, we can just look which center it's more close to, and we can just label them like that. Like if it's closer to the yellow side, we can just say it's on the yellow cluster, it's in that class, it's on that cluster, and we can just classify it like this. So let's do that. We will say k-means model, and we are going to create our model like k-means, and we are going to set number of clusters as 3. Then it's it, I think. And now we are going to fit this like using .fit command again, but remember we don't have y in here, so we will say x, and then what we are going to do is we are going to set the cluster centers with k-means model.cluster centers, and we are going to set the labels like k-means model.labels. And after setting them, what we are going to do is we are going to visualize the clusters. So we are going to say plt scatter. Actually, let me copy the upper thing, the first line. I'm just going to copy this because I need to write the same thing. And after that, now I'm going to say plt scatter, and after that I will say cluster centers, and I'm going to do 0, and I will say cluster centers, and I will say 1. Let's set the color as red in here, and let's set the marker as X, and let's set the S as 200, and we will say label is going to be equal to the cluster centers. And then what we are going to do is we will say plt title k-means clustering results, and we are going to do X label feature 1, Y label feature 2, and legend, and we will use plt.show at the end. And here it is. Great, you can see the centers. So based on the distance between these centers and the new data points, we can just move our new data to these clusters. Great. In this example, we have created a synthetic dataset with 3 distinct clusters and applied k-means clustering to identify these clusters. Now let's discuss the process of choosing the optimal number of clusters, often referred as the elbow method. So we are going to have a metric like inertia, and we can just call it like within cluster sum of squares. And what we are going to do is we will say define calculate. We are going to create a function like this, inertia, and we will give the data inside and the maximum k inside. Then we are going to say inertias, and we will create an empty list. We will use append method after, and we will say for k in range 1 and maximum k plus 1, and we will say k-means model equals to k-means, then we will say number of clusters equals to k, and then we will fit this for every value in range 1 and maximum k plus 1, fit k-means model fit, and we will use data. Then we will say inertias append k-means model inertia, and we will return inertias at the end. Here it is. Okay, let's apply the elbow method now. We will say maximum clusters is going to be 10, and we will set inertias like calculate inertia. We will give x and maximum clusters, and here it is. So at the next step, we are going to visualize the elbow method like plt.plot range 1 to maximum clusters plus 1, and we will give inertias, and we are going to set the marker as O. Okay, then let's give the title like elbow method for optimal number of clusters, and we will set x label like number of clusters, which we can also refer as k, and we will set y label as inertia, and we will use plt.show at the end, and here it is. From here we can select the k value based on the lowest inertia. Actually, after the tree, as you can see, there is no significant change. So if I was modeling on this graph, I will take the tree as the number of clusters because there is no significant change. There is no need to add new clusters. Actually, it really depends on the problem, but I'm just telling what I will generally do. You can take the point which is going to be changed, going to be smaller after that point, like from 3 to 10, the chains are really small, and I think there is no point and there's no difference on taking 10 bit and 3. Okay, for the final part of our course, we are going to talk about model persistence and serialization in Scikit-learn. Model persistence involves saving a trained machine learning model to a file so that it can be easily reloaded and used later without the need for retraining the model. So we are going to use joblib for that, and what we are going to do is let's load our iris dataset again and train a basic model. I'm just going to make a copy paste in here. Let me find the related code. I'm going to be in here in a second. Okay, for the iris load dataset side we will do this. And after that, what we are going to do is we are going to do train test split, as we've done a lot in the course, and we are going to train a random forest model with 100 number of estimators. And what we are going to do is actually we don't need to get the predictions and accuracy, but I'm just going to do that like accuracy score, y test, and predictions. And here we have our model. So now in the destination I don't have any files, and we are going to save this machine learning model as a pickle file. It's a special type for the Python files, and it's commonly used in the deployment of the machine learning models. Like what we can do is we are going to say model file name, and we can just name this like random forest model.joblib. And what we are going to do right now is we are going to say joblib.dump. We will say random forest model, and we will say model file name. And after doing this, you are going to see we have random forest model.joblib in here. Also, as I said, pickle file is really commonly used. You can just say pickle in here, and after saving this, you are going to get the pickle file in here. But we are going to move with the joblib extension right now, and here is our model. And how we can load this is we can say loaded model, and we are going to say joblib.load, and we are going to give this file name, just like reading CSV files in Pandas data frames. And here it is, we loaded our model. And let's create a new data point for the prediction side. Like, think this, your customer wants to get a prediction. You'll say 3.5, let's say 1.4 and 0.2. And I remember like there's 4 different X features in the iris dataset, and we can just get the prediction like loaded model.predict, and we can just give the new data point in here, and let's see our prediction. We got the class 0. Great. So we just saved our model as joblib file in here, then we loaded this model and we made a prediction with that. So think this like you can deploy this into a website. You can just send this to your machine learning operations team. They can deploy this on a mobile app, and customers or people in your company can use your machine learning models with this. Model persistence is essential when you have invested time and resources in the training a model and you want to deploy it in production or share it with others without the need to retrain. I have also videos like API deployment of machine learning models or creating web apps with Streamlit. You can check them for different types of deployment. Like in the Streamlit video, you are basically creating a website for your model and everyone can use your model from there. Here is the dataset. I put it in here and you can download it from the description. We are going to start by importing the libraries. Import Pandas. We are going to import Numpy. We are going to import Seaborn. And we are going to import Matplotlib at the first stage. At the machine learning part, we are going to do the other imports. Let's use read CSV, pd, read CSV, Europe, motorbikes.csv. Here it is. So you're probably going to see it from the title. Our dataset is about motorcycles. Let's see the first 5 entries here. We have columns like price, mileage, power, make, model, date, field, year, offer type, version, and a link of it. Great, let's get general information about the columns and the data. We are going to use df.info for that. Here it is. So with .info we can see information like how much memory it uses, how many data types in each type we have, and more. Let's use df.shape for seeing the row and column count. As we can see, we have around 35,000 rows and 10 columns. Let's get the summary statistics for the numeric columns. Like we have 3, we have 1 float and 2 integers in here. We are going to get the summary statistics for them. We are going to use df.describe method for that. And here it is. So for example, this means that we are going to take this number and this is going to be multiplied by 10 power of 4. And this is that number's full version. Like we can change this scientific notation with 1 line of code here. We can say that pandas set option display that float format, and we will say to floating, and we will say that format here. And now we are going to see that our numbers are going to be changed and they are going to be in the float format with to floating. Here it is. Also, you can see that the thing we got here, the count of the price is 34,917 as we calculated. You can use this line for changing the scientific numbers to the floats we know. Great, let's talk about this numeric summary. We have 3 columns that are numeric and the average power is 206. Great, so we can move on. Let's check for missing values. We will say data frame is null and we will use .sum here. We have 6,000 missing values in the power, 3,000 missing values in the fill, 22,000 missing values in year, and 17,000 in the version. I'm not going to drop the missing values because we are going to lose some really important information with dropping them. We are just going to keep them as null. Like if you say drop NA, you are going to drop 22,000 rows maybe with 17,000 and you are going to lose 40,000 rows for nothing. Year and version isn't that important, I think. Okay, let's check for the duplicates. df duplicated, and we will use some method from here. And we can see that we have 5,800 duplicates. We can remove them. We are going to use drop duplicates method and we will say in place equals to true. So we are not going to assign it again. So we can check if it's worked like duplicated .sum, and this is going to show us 0 this time. Great. Okay, let's do a data visualization. Let's create the count plot of the field types. We will say SNS count plot and we will say X is going to be equal to the field and we will say data is going to be equal to the data frame. Let's set the X label as field type and Y label as count, and let's give it a title like count of motorbikes by field type, and let's set X text rotation 45 and use plt.show here. Here it is. Great, now we can see the field type distribution of the motorbikes. We can see that it's dominated by the one field type. Okay, let's group by year and calculate the average power of the motorbikes. Let's say year power and df group by year. We will take the power mean and let's get this values like year power. Here it is. Great, we can see that in the motorbike power mean terms, semi-automatic is the leading one and the automatic is the less powered one. Okay, we can move on. So let's sort our data set by price in descending order. We will say df sort values. We are going to sort by price column and let's set the ascending as false. Here it is. So we can see that here are the prices we have in ascending order, and let's check our original data frame. It's randomly sorted. So what if we want to save this sorted version? It's simple as in place equals to true, and from now on our original data frame is going to be look like sorted like this. Great. So these are the outlier values and we normally shouldn't include them in any of our analysis or any of the modeling side. I'm just not going to remove the outliers because it's going to take a lot of time and video is going to be really long, but in the future projects I can do that. If you want, you can tell me in the comments section. I'm just going to model like this. I don't think it's going to change a lot of things because some of the models are understanding the outliers and treating them, and maybe we don't need them in some of the models like we need it in some of the models. I can do that in the future projects, but just for keeping this video short, I'm not going to do that. But if you really want to create a great model and better analysis, you can just remove them. You can use interquartile range, and you can use other outlier removing methods, and you can take this project a step further. Great, let's move on. Let's take the value counts of offer type. So we will say offer, also I'm just going to remove this interquartile range, offer counts, and we will say df offer type dot value counts, and let's get offer counts. Also I need parentheses here. Great. So most of the motorbikes are used, as you can see, and we have some new in here. We have demonstration. Great. By the way, I don't really know about motorbikes, so I'm just going to get the first two entry of our data. It says used in here for the offer type, but maybe they can be classic and these prices can be true for some motorbikes, because I know that some classic cars gets this amount of values, so maybe it can be. Like collection items can get crazy monies, so this is a probability, I think. I'm not sure. As I said, I don't know anything about the motorbikes. I know some, but I don't know a lot. Great, let's get the value counts of make model. We will say make model counts. We will say df make model, and we will take the value counts like this and get the make model counts here. Great. Also, if you don't want to see this amount of list, like we have 2168 unique values in here, we can just say head and 5 for seeing the first 5 like this, and you can include them in your analysis. You don't need to put all of them actually. Great, now we can do some group bys. Let's group by fuel and calculate the average price for each fuel type. Let's say fuel average price, and we will say df group by fuel, and we will group by price mean, and let's say fuel average price here. Great. So let's also sort this. Sort values ascending false, and see the result here. Here it is. So the thing has the most price is LPG. I think that's because of the classic cars. I'm not sure. Great, let's group by year and calculate the median mileage for each year type. Let's say year median mileage, and we will say df group by year, and we will say mileage dot median. Year median mileage. Also, I made a typo there. Great. I think this is an accurate result because manual motorbikes used much. Great. Also, we can check quickly like what happens if we take the mean instead of median. You can see that here. Okay, let's group the data by offer type and calculate the maximum power for each offer type. For that, we are going to say offer maximum power df group by offer type, and we will say power, and we will use the maximum method here. Offer max power. Here it is. Also, we can sort this in descending order. Sort values ascending false, and it's going to be sorted right now. Great. Okay, let's group the data by make model and calculate the average price for each motorcycle model. We will say model average price df group by make model, and we will group by the price, and we will take the mean here like this and get the model average price here. We have 2000 here, so we can sort the values firstly in descending order and take only the 5 here like this, and you can see that we got the data we wanted. Okay, let's group the data by fuel and year together and calculate the count of motorcycles for each combination. Let's say fuel year counts df group by, we are going to give 2 columns to group by fuel and year, and we will say dot size, and we will use unstack here, fill value 0, and get this, fill year counts. Here it is. I think it looks great. A lot of information in here, like we can see electric, gasoline, and semi-automatic like this in here. We can see gasoline, automatic in here, a combination of them. By the way, I'm trying to cover most of the methods, like we are grouping by 2 columns using unstack, we are grouping by single column, and we are doing other methods because I want this video to be informative and it's my goal in this video. Okay, let's do some more data visualizations. Let's take the average price by field type in a bar chart. So we are going to go step by step. Let's group by field and calculate the average price. We will say field average price. We will say df group by field, and we will say price mean. And let's see the result, and then we can move on to the bar chart. Great. Also, we can do sort values here for getting the better bar chart. We can say ascending, false like this for doing in the descending order. And now we are going to create our bar chart. I will say field average price dot plot kind bar, and let's set the color as sky blue because it's going to look better. Let's say X label field type, and let's say Y label average price, and let's give it a title like average price by field type, and let's set the X text as rotation 45 and use plt.show here. Here it is. So I just want to show that this looks like that right now, but if we go here and say in place equals true and recreate our bar chart, you're going to see it's going to be in the descending order to the right. Okay, let's do another visualization. Let's take the maximum power by offer type and recreate a bar chart with that information. Let's go step by step again. Let's group by offer type and calculate the maximum power. So we will say offer max power and df group by offer type, and we will take the maximum powers like this, maximum, and let's see what we get from here. Offer max power, here it is. So let's again sort it, sort values, and we will say ascending false, and we will set in place as true like this, and let's get what we have in offer max power. Here it is. So used has a higher number than the others, so it's just going to look like this graph. So I'm just going to take this 4 for making it better looking, and we are just going to remove the used like this. Offer max power is going to be equal to the tail 4. It's going to take this 4 entries, and we are going to run this, and let's check offer max power. Here it is. Great. Now create a bar chart with this. Let's say offer max power dot plot. We will say kind bar, and we will set the color as light coral, and we will say plt x label offer type and plt y label maximum power, plt title maximum power by offer type, and x text, let's set rotation 45 and plt.show. Here it is. It's looking great. I think it was a good idea that removing the first entry here, like we are just taking this 4 and it's looking better. Okay, now let's do a final visualization, like let's use pie chart, since we didn't use it in this video, and then we can get to the feature engineering and modeling side. So I will say, I think we can do the pie chart of field type distribution. We can just use like field distribution, and we will say df field. We will use value counts here, and you can see field distribution. It's looking like this. So let's just take this again and don't put this one here, don't put gasoline here. We can just say tail and 1, 2, 3, 4, 5, 6, and we can set this to the field distribution, and it's going to be look better like this. And let's create the pie chart. We will say plt.pie field distribution. We are going to set the labels as field distribution dot index, and let's say auto pct. We will say 1.1 floating percentage. Then we will say start angle, and let's say 140 color, and we will say gold. Let's take light coral and light green like this. And I think I made a typo. Yeah, here it is. Great. So we will say plt.axis, let's say equal, and plt.title field type distribution. Also say doesn't gasoline included. Also we can just say not instead of doesn't, because it's going to look better. And let's use plt.show here. So I made a typo there. I can just change this to angle, and now it's going to be better. I think color it didn't work. I'm surprised because it's colors, and now it's looking great. So we have a nice looking pie chart, and we can get to feature engineering. So let's just call our columns and select the ones that we will include in the modeling. So let's set y firstly. Y is going to be the price here. It's a short thing. I'm just going to put it in here and run that, and it's going to be in here. Great. And let's set the x here. Also, I'm not going to set it as series, so I will just do like this, and I'm going to show you the difference. It was a series before, and now it's going to be a data frame like this. Great. And let's set our x here, like we can take my wage power. Let's not include the make model. Also we can, I'm not sure, let's not include it. Take my wage and power. Let's put fill, and I'm not sure about the year. Let's put offer type, and let's also put year here. And I think it's enough. Let's just check X, and I think we made good decisions here. So the next thing we need to do here is we need to do feature encoding, because these are categorical variables and we need to change them to numeric if you want to use them. Also, we have really big differences in like my wage power, and these are going to be like 1, 2, 3, 0. So we need to do feature scaling also. Let's import preprocessing from Scikit-learn. Import preprocessing, and let's set label encoder. Let's use label encoder preprocessing dot label encoder, and then we are going to go column by column. So we will do the encoding for the data frame fill, and how we are going to do is we will do label encoder. We will use fit transform method, and we will use it on the data frame fill. And I'm just going to make a copy paste here, and I'm just going to change the column names. Like here I'm going to do that for the offer type like this, and I'm going to do that for the year. So I'm just going to do this, and we are going to see the new version of the data frame. Like you can see that field gear offer type, and I'm just going to rerun the X and Y didn't affect but X affected, and you are going to see that we have the numeric values here. So we can do that before the X and Y selection. It's the same thing, and since we have only numeric X values, we can move on. Now we are going to use train test split to split our data. After that we are going to scale our data because we don't want data leakage. So the train test split is going to let us evaluate our models. Like we are going to have a test set and training set. We are going to train our models on the training set, and we are going to test the performance of the models on the testing set. If we don't do that, we can't compare the models, and we can't know that how our model is performing. So we need this. We are using this a lot when we are doing modeling. So let's just do that. We will import train test split from Scikit-learn.model selection, import train test split. We are going to say xtrain, xtest, ytrain, and ytest. We'll use train test split here. We'll say x, y, test size 0.2. This means that 20% of the data we have is going to be in the testing set, and the 80% is going to be in the training set. So let's just run this, and we can just check like xtrain, xtest, etc. It has 23,000 rows, and this has 5,800 rows. And the next step is the scaling our data. We will import Scikit-learn pre-processing. We'll import standard scaler here, and we are going to do standard scaling, which we can also refer as standardization. We are going to initialize the standard scaler like this. Then I'm only going to scale the x values. Scaled xtrain is going to be equal to the scalar fit transform xtrain, and scaled xtest is going to be equal to the scalar fit transform xtest, like this. Great. Now I'm going to define a function for evaluating our models. Like it's going to give mean absolute error and root mean squared error when we call it. So we are not going to call these metrics every time. So I'm going to import from Scikit-learn metrics. I will import mean absolute error and mean squared error, and we are going to define as model results, and we will give predictions to our model. We don't need to give y true values because we are going to give it right now. I will say print mean absolute error on model is, I'm going to use that format with this string. I will use mean absolute error, ytest, and predictions. The predictions are the ones we will pass in our function, and also print root mean squared error on model is, we'll use that format again. We'll use numpy square root mean squared error ytest, and we'll give predictions. This is our function. Great. Also just take this to here. I missed something, that we created this function, but we are not going to have any NA values in the modeling side. So I'm just going to do a quick thing here. I'm just going to set, before any transforming and setting options, I'm just going to say df is going to be equal to the pd read csv, and let's use like our CSV file here. I'm just going to take its name from here, copy, and we will say, and we have the brand new data frame here, like here it is. Let's just check it, and it's not label encoded, anything, etc. And after setting x and y, we are going to say x drop NA and use in place equals to true, and we are going to do the same for the y. We will say y drop NA, and we are going to set in place as true in here too. So we have X and Y with non-NA values. So if we have NA values in the modeling side, it's going to raise an error and we are not going to train any models. So I just dropped that. I'm sorry for the confusion. You can drop it at the start of the selection of the X and Y after selecting, because with that NA values you can train any models. Now we can start to the modeling. Let's start with linear regression. We will say from Scikit-learn. Also I'm going to use lowercase letters. From Scikit-learn.linear model, import linear regression, and we will say linear regression is going to be equal to linear regression. We're going to initialize this. And for the other models, I'm going to do hyperparameter tuning, but we don't have any parameters in linear regression. Actually, we have, but we don't have. So we will just say linear regression.fit, and we're going to fit this in our training data. And by train here, and let's fit linear regression like this. Then we will say predictions linear regression.predict, scaled x-test here, and we got our predictions in here like this. And let's say model results and predictions linear regression, and we can see our mean absolute error and root mean squared error like this. Okay, let's train a support vector machines model, but this time we are going to do hyperparameter tuning with grid search. Let's say from Scikit-learn.support vector machines, import support vector regressor, and from model selection, import grid search cross-validation. And we are going to initialize this like SVR model, and it's going to be equal to the SVR support vector regressor. I need equal sign in here. Great. And we are going to define a dictionary for our parameters. We will say C, and we will create a list like 0.001, 0.01, 0.1, and let's say 0.5. Also, we are going to give kernel, and there's going to be 3 options like linear, RBF, and poly. And we can say for other parameters, I think it's enough, but I'm just going to define more for showing you. I'm going to say gamma, and we can say scale and auto in here, and also we can set degree, and we can say 2, 3, 4, and 5. So this is going to be the final ones that I'm going to define. You can do a lot more, like you can add after this 0.5, and you can add before this 0.01, and also for the others. So what we have here is we have C, kernel, gamma, and degree as our parameters. I think I didn't make a mistake on the writing side. I need this in here. Also this is, I'm just checking it, and I think we are good to go here now. Okay, so after defining our parameters with SVR, I'm just going to check it quickly again. This, we have list. Okay, great. So the next thing I'm going to do is I'm going to create this like grid SVR, and I'm going to use grid search cross validation. Then I will say SVR model and parameters grid SVR. So now we are going to fit this into our data. We will say grid SVR fit scaled x train. By the way, this fitting operation is the model train part, and we will train our model like this. This is going to take a little bit time, and after the fitting operation I'm going to be in here. Okay, I'm back. It is trained like in 2 minutes and 4 seconds. So the next step, what we are going to do is, also we can remove this warning, but it's not important for now, I guess. And what we can do now is we can print the best parameters, like we are going to use best parameters for model is, and we will say format grid svr dot best parameters, and let's see the best parameters selected. We have 0.5 for C, 2 for degree, scale for gamma, and linear for kernel. And the next thing we are going to do is we are going to make predictions with this model, and then we are going to evaluate its performance on the testing set. So we will say predictions grid SVR, and grid SVR.predict scaled x test, and let's call our function predictions grid SVR. Model results is the name of the function. Here it is. So here we got the results from our model. Let's train one last model for this video and end this video because it's going to be too long and we can train other models on the other projects. Let's train a random forest model for the ending of this video, and we can train other models like decision tree and XGBoost in the other projects. So we will say from Scikit-learn.ensemble import random forest regressor here, and we are going to initialize it like RFR model random forest regressor. Also, I made the same mistake. I need equal sign in here. Then I will say parameters grid RFR, this time random forest. We will set parameters like we have bootstrap. We are going to set true for this. I can explain this in another video on a random forest specific tutorial. I'm planning that. Max depth, we can say 5, 10 and 15 here, and maximum features we can say auto and this, and at the number of estimators time we can say number of estimators, we can say 3, 4, 5, 6, 7. We can say a lot more, but I just want it to train fast, and I will say grid RFR, and we are going to say grid search cross validation RFR model and param grid RFR. Then we are going to fit this like grid RFR.fit. We are going to fit this using our training data. I will say scaled x train. Also I made a typo there, x train and y train like this, and I'm going to be back when it's trained. Oh, it trained fast. So the next thing I'm going to do is let's take the best parameters. Let's say print best parameters for model is, and we will use that format grid rfr.past parameters, and we are going to see bootstrap true. That was the only option. 15 for the max depth, this for the maximum feature, logarithmic 2, and the 4 for the number of estimators. Great. By the way, I'm calling this as this because I don't remember that it was logistic or logarithmic. I'm just going to quickly check it and tell it to you. Okay, I remember it correctly. It's the logarithm base 2 of the whole number of maximum features, and we can just say logarithm 2 for that. And now the next step, we are going to make predictions using the scaled x test. Let's say predictions grid random forest, and we will use grid random forest predict scaled x test. And let's get the model results for the random forest model. We will say predictions grid RFR, and we can see that we got higher numbers than the support vector regressor. I think it's the end of this video. I can do like decision tree regressor too, but it's already longer than 1 hour, so let's just finish this project in here. So we made a lot. We made exploratory data analysis, we made some data visualizations, group bys, sorting operations, multiple group bys, then we did feature scaling, and then we did modeling. In the video we used linear regression, support vector regressor, and random forest regressor. And I think that was a great project, and I hope you enjoyed it. We have two CSV files in here, credit card and credit card label. So we are going to start by merging them. Okay, now we can start coding. We will start by importing the pandas, and then we are going to data reading for both of our datas. So firstly, let's read the credit card CSV. So we will say data pd read CSV, and we will say credit card CSV, and let's check how it looks. Here it is. So I'm not going to talk about it, like talk about all the columns one by one, because firstly I want to merge the data frames. So I will use read CSV for the label. So I will say label is going to be equal to the pd.read CSV, and we will say credit card label.csv, and let's check how our label looks like. Okay, our common column is individual ID in here, and we are going to merge on this column. So what we'll do is we are going to reassign data like data.merge, and we will say we are going to merge with label. Then we are going to say the common column is individual ID because it has the same name in the both, like you can check from here. Then we are going to say how is going to be equal to the left. So we are basically going to do a left join. Also we don't need to use capital letter, otherwise it will raise an error. And when we check our data frame's latest version, we are going to say we have the label now. Like in here we have the labels. So what these labels mean is you can also read about this dataset from the Kaggle side. Like if the label is 0, that means that credit card application is approved. And if it is 1, it means that credit card is rejected. So we are going to work with a dataset which we have information about credit card applicants and information about them, and we have the label of approval. Like we have the columns, like let's quickly check them: individual ID, gender, car owner, property owner, children, annual income, type of income, education, marital status, housing type, birthday count. Also, I'm not sure why this is negative: employed days, mobile phone, work phone, phone, email ID, type, occupation, family members, and label. Okay, let's also import data visualization libraries we are going to use. Let's import Seaborn, and let's import Matplotlib, pyplot as plt. And now we can start to analyze our data. So let's start by displaying some of the rows we have, and we talked about the columns. We have both numeric and categorical columns in our data. We are not going to use all of them in our classification model, but I think we can use some of them. Okay, let's get general information about our dataset using .info, like this. Actually, I need to write data. And from this code .info, we can get general information like the data types in the columns, non-null values, memory usage, and also you can see the summary data types in here. And for the numerical columns, you can use data.describe for getting the numerical summaries. And here it is. I'm not sure, but maybe this can be the days after the birth. Like we have all negative values in the birthday count, and in the employed days side, we have negatives and we also have positives. I think this is an outlier. Also, let's check others like, okay. So by the way, from the mean of the label column, we can see that the credit card applications are most likely to be approved since 0 was the approval. Great, let's check if we have any NA valued rows. So for that we will say data is NA, and we will use sum in here. And here we have a lot. Actually, I'm not going to directly use drop NA method because when we do that, we are going to drop 488 columns. This is not a thing that I want because we can lose some really important information if we drop all this. So what I'm going to do is I'm firstly going to drop this column, then I'm going to say drop NA. So we are just going to clean this amount of data. So for that we can do data.drop, and we will say columns is going to be equal to the type, and we will say occupation, and when we run this, our original data frame is not going to change, and you can see from data columns that we will still have the type occupation since we didn't assign this like data equals to true, or we didn't do something like in place equals to true. Like if you want to modify the original data frame, you can just use in place equals to true. So in this way, you are going to change the original data frame. Like when I run this right now, it's not going to be in here. And let's get the NA sums again. Like I'm just going to copy this and paste it in here. And you are going to see that when we drop NA values now, we are not going to drop out of columns and rows. So what we can do is we can just use data drop NA, and if we run like this, this is not going to modify the original data frame, so we will just do in place equals to true for modifying the original data frame. And when we say data is NA and we say sum, we are going to see that our rows which contains NA values are dropped. Okay, let's check for the duplicated values. For that, we will say data.duplicated, and we will use .sum after that. And as we can see, we don't have any duplicated rows in our dataset. If we had, we can just use a method like drop duplicates from Pandas, and it's a really efficient method that you can use. Also remember to use it with in place if you have any duplicate values in your dataset, but we are not going to use that. Okay, let's calculate the average income. So we can say average income, and we will do data annual income, and we will use mean aggregation function, and then we can just call average income. So from this we can say that the males in our dataset is earning more than the females. So also we can sort this, like you can take this in here, and let's just quickly run this, and we can just do sort values. And what we can do in here, it's now sorted in the ascending order, and if we want to get this in descending order, we can say ascending equals to false, and now it's in the descending order. And let's say you just want to take this value, so you can just do 0 like this if you want, or if you don't want to take the value and get it with its index, you can just use head and put 0 in here. Actually not 0, we can just put 1 in here, and you will get the male in here. Okay, let's just remove this, and we are going to create a data visualization right now. Let's plot the average income by gender. So for that we will say SNS bar plot, and we will say x is going to be equal to gender income dot index, and y is going to be equal to gender income dot values, and let's give it a title like average income by gender, and we will use plt.show. Here it is. Also you can add x label and y label, like x label, let's say genders, and y label, and let's say money. And when we run this, we are going to get our labels like this. Okay, let's calculate the value counts for label for seeing the improvement rate. So we can say label counts, and it's going to be equal to data label, and we will use value counts. And let's see what it looks like. Label counts. Here it is. So how we can make this information more meaningful is we can create a pie chart from this. Like we can say plt.pie, and we can just give label counts we created, and then for the label side we will say credit approved, and we will say credit rejected. And let's set auto PCT for seeing the percentages also. I'm just going to delete it after creating, and you are going to see the difference. We will say auto PCT, and we will say percentage 1.1 f percentage, and let's say plt.title, and let's give it a title like credit approval status, and let's use plt.show again, and you are going to see the information like this right now. And if you remove this auto PCT in here, you are going to see that we are going to lose the percentages on there. So I'm adding it again, and you are going to see we have the 89% in here and 10% in here. Okay, let's do some group bys. Let's group our data by type income and calculate the mean of annual income. So we will say data.group by, and we will say type income, and we will say annual income, and we will use the mean aggregation function in here, and here it is. And let's group our data by marital status and find the maximum employed days. So for that we will say data group by, and we will say marital status, and we will get the maximum of the employed days. So we will say that maximum like this. Okay, let's group our data by housing type and calculate the sum of family members. So for that we will say data.group by, and we will say housing type, and we'll get the values of family members, and we will use that sum like this. Okay, let's group our data by gender and find the minimum birthday count. So for that we will say data group by, and we will say gender, we will take the values of birthday count, and we will take the minimum of this. Actually, I think these are negative and it's like nonsense, so let's just actually do like multiplied by -1, and let's just get them positive. Like, I'm not sure if these are the days after the birth. Like, if it is like this, then this age is like 7 maybe, not sure, but in that way it's not going to be meaningful since it's about credit cards. I'm not sure of this. Okay, let's group our data by property owner and calculate the average annual income. By the way, since this is non-meaningful for me, I'm not going to include this one in our models. So what we are going to do for grouping by the data property owner, we will say data group by, and we will say property owner. Actually, it has a name like this in the original data frame. We will say annual income dot mean, and we will get it like this. Let's group our data by education and find the maximum mobile phone value. So for that we will say data group by, and we will say education. Actually, it has capital letters as I remember, and I will say mobile phone, and I will say that maximum like this. So I think it has values like binary. Let me quickly check, like data mobile phone, and we are going to see its values. Yes, I think it has binary values inside. So maximum is not meaningful. Actually, it only has one value. Okay, so even if we change this like minimum, we are going to get ones. So okay, let's group our data by children and calculate the sum of annual income. So for that we will say data group by, and we will say children, and we will take the annual income, and also it will be our last group by. I don't want to make any more. Okay, let's do some data visualization, like let's create 3 or 4 plots, then we can move into the feature engineering, and after that we can move into the machine learning part. So let's create a box plot of annual income grouped by marital status. So for that we will say sns.boxplot, and we will say x is going to be equal to the marital status, and y is going to be equal to the annual income, and we will say data is going to be equal to the data. And then let's give it a title like plt.title and annual income variation by marital status, and let's use plt.show like this. And here it is. Let's create a violin plot of birthday count grouped by gender. So for that we will say sns.violin plot, and we will say x is going to be equal to gender, and y is going to be equal to the birthday count, and data is going to be equal to data. And we will say title distribution of birthday count by gender, and we will use plt.show in this one too. So here it is. Okay, let's create 2 more plots and then we can move on. Let's create a pie chart of the sum of family members grouped by marital status. So for that we will say data group by, and we will use marital status. And let's take the values of family members and let's say sum. Then we will say that plot kind is going to be equal to pi. Also, let's do the autopcity thing. For seeing the percentages, we will say percentage 1.1 f percentage. You are going to remember this as you do it. So, and then we are going to use plt.title. Then I will say family members distribution by marital status, and I will use plt.show. And here it is. Actually, sometimes when you create a pie chart from a group by operation, you are going to see that you will have an unnecessary y label. So how we can fix that is we can just say plt.ylabel and you can insert an empty string in here, and you are going to see it's going to be removed in here. Great. Okay, let's create a final box plot of the annual income grouped by education and then move on. We will say data box plot column is going to be equal to the annual income. Actually, we need to capitalize the A, and we will say by education. And we will say plt.title annual income variation by education level, and we will use plt.show. Here it is. Okay, let's call our data and select some columns inside of it. So let's use, also we can write like data, we will use this, and we will get, actually we can get car owner, it can be meaningful. And then what we can get for our models is we can get property owner thing. And what we can get else is we can get annual income for sure. And then what we can get, let me quickly check what other columns we have. We can get education, and what else? I'm not going to take the others, like from here, and from here what we can get is maybe family members, but I'm not going to get that. We can get the label, it's going to be our target, so we need to get that. I'm going to make a final check, like if we can take anything else. I think no, it's enough. So let's reassign this as data. Also let's do a final check, like we are going to use these ones for the modeling side. Okay, so when we call data again, we are going to see our new columns. For training machine learning models, you can't directly use these values, like they are categorical and you need numerical values. So we will do encoding right now. I'm going to use label encoder, and let's do that. So for that I will import preprocessing from Scikit-learn. Import preprocessing, and I'm going to initialize the label encoder like preprocessing dot label encoder. And now what I'm going to do is I'm going to say data, and I will say let's start by car owner is going to be equal to the label encoder. Here it is, dot fit transform, and we will use data car owner again, like this. Also we need to do this for the other columns we have, which are non-numeric, so we will do it for property owner from here, and we are going to do this for education too. So we will do, actually I didn't copy it, we will do it for the education. I'm just going to copy it from here, and when we run this and check our data frame again, we are going to see we all have numeric values. Right now we have different scales on numeric values, like This differs from others really much, and we are going to do scaling, but not right now, because if we do it before the train test split and we also scale the testing data, that will create a data leakage. So let's set our x and y. For the x, we will say data.ilog, and we will not going to filter any rows. We are going to filter columns. We are going to take all of the columns instead of the last one. So for the y side, we will say data.ilog, and this time we are again not going to take any rows. We will say -1. By the way, what I mean by we are not going to take any rows, we are not going to do a filtering based on rows. We are going to do a filtering based on columns. So with this code, we will say we are going to take this for the x and take this for the y. Great. So now we can do train test split. I'm going to say from Scikit-learn.model selection import train test split, and then I will say xtrain, xtest, ytrain, and ytest. Then I will do train test split x and y. Then we are going to set our test size as, let's say, 0.2, which means 20% of our dataset is going to be in test set and 80% is going to be in the training set. So now what we can do is we can do scaling operation on our x. So how we can do that is we are going to say from Scikit-learn.preprocessing import standard scaler. Then we are going to initialize this standard scaler. And for the next step, we will say scaled xtrain. It's going to be scalar that fit transform, and we will use xtrain in here. And for the xtest side, we are going to do the same scalar that fit transform, and we will say xtest. Here it is. Great. So now, before getting into the modeling side, I'm just going to define a function for getting the accuracy score when we pass in the predictions from the model. So with this, we are not going to need to write it every time when we create models. So for that, I'm going to say from Scikit-learn.matrix, I'm going to import accuracy score. You can also use others. Each of them have different advantages, like I have a video named classification matrix. You can watch it for seeing the others like F1 score and rock curve, etc. So I will say define model performance, and we are going to give inside the predictions. Then we are going to print, when we call this accuracy score on model is, and let's use curly braces. Then we will say that format, and we will say accuracy score. We will say ytest and predictions. Here is our function for evaluating our models. Great. We can directly start with logistic regression. We will say from Scikit-learn.linear model import logistic regression, and then we will say logistic model is going to be equal to logistic regression. We are going to initialize this. And then we are going to say logistic model that fit, and we will say scaled xtrain and ytrain. Here it is. So what we are going to do next is we are going to make predictions with our model, and let's do it like logistic predictions, and we will say logistic model, and let's use predict, and we are going to predict the values with scaled xtest, and let's get the model performance on this logistic model. Predictions. Here it is. We have the accuracy score of 0.9, which means our model is great. This is a really good accuracy score. Okay, let's train other models and see how they perform. What I'm going to do at the first place is I'm going to import grid search. It's going to be helping us on the hyperparameter tuning. So I will say grid search cross-validation. What grid search does is it checks for multiple parameters and picks the best performing ones. So let's start to our models with k-neighbors classifier. So we will say from Scikit-learn.neighbors import k-neighbors classifier, and we are going to define parameters grid it's going to be a dictionary which will have the possible parameters inside. We'll say number of neighbors. I think it will have 2 underscores, but I'm not sure. If it raises an error, we will quickly change that. We are going to say 3, 5, 7, 9, and 11. Also, you can extend these numbers if you want to get better performing models. Maybe it will change, maybe it will not, but you can try it out. Since I'm recording a video, I'm not going to try out of values. You can just extend these limits. Like you can also put 1 and 13 and you can extend these numbers like that. Okay, let's do weight and we will say uniform and distance. Also what we can do is, let's say algorithm. Actually we need h in here and we can say auto and kd3, and I think it's enough for the can classifier. We will say grid can and we are going to do grid search cross-validation k neighbors classifier. Then we are going to do parameter grid and let's set cross-validation as 2. You can also increase this number, but I want it to be trained fast, so I'm just going to go with 2. You can do like 5 or 10. I will say grid can.fit and I will use xtrain. Actually I'm going to use scaled xtrain and we will use ytrain. And let's wait for it to fit. Actually there's an error. Let me quickly check. And I think, okay, the 2 underscores thing is wrong. And when I change that, it's going to be fixed, I think. Here it is. By the way, by clicking this, you are going to see that our model in here. And if you do grid can best parameters, you will see the best performing parameters. Like for the algorithm side, auto, number of neighbors side 9, and for the weights, it's uniform. Okay, let's do some predictions with this. So we will say can preds, and we are going to say grid can.predict, and we'll use scaled xtrain for taking the predictions. And let's call our function model performance, and let's say can preds. Actually there's an error. Let me quickly check why it is. Actually I think we made an error on, we are making predictions with the xtrain, so I'm just going to change this with test and it's going to work smoothly. Here it is. Our logistic regression performed better. Okay, let's train a support vector classifier right now. So we will say from scikit-learn.svm import support vector classifier, and we are going to initialize this like svm is going to be equal to svc support vector classifier. Then we are going to say param grid svr, and we are going to do like, let's say c, and we are going to give the values for it like 0.01, 0.1, 0.5 and 1. And let's also define kernel, and for this we can say linear, rbf and poly. Actually you can check the scikit documentation for seeing all the parameters and trying them out. I actually recommend that because if you do that you are going to remember all of them. So now I'm going to say grid svr, which is going to be equal to the grid search cross-validation, and I will say svm param grid svr. Actually I need comma in there, and here it is. So actually we need to use this in here for it to work smoothly. And now what I'm going to do is I'm going to fit this in our data. I will say scaled xtrain and ytrain in here, and we got an error again. Actually it's scaled capital letter xtrain, and now it's going to work smoothly. Okay, let's make predictions with this. So we will say predictions svc. We will say grid svc dot predict. Actually I used like r, and we will say predict, and we are going to do scaled x test. Then we will call our function model performance and get this pred SVC accuracy. Our accuracy score on the support vector classifier is 0.9, and I think it's really great. I'm not sure if it's better from the logistic regression, so let's check it. Actually, they are same. Okay, let's train a decision tree classifier model. So for that, we will say from Scikit-learn.tree import decision tree classifier, and we will say parameters grid. We will say criterion, and for that we can say Gini or entropy, and what we can do is we can say splitter, and it can be best or random, and for the max depth we can say none, 10, 20, 30, 40, 50, and for the minimum sample split we can say 2, 5, 10, and for the minimum samples leave we can say 1, 2, and 4. And what we can do is we can just use grid search tree, and we can use grid search cross validation. Estimator is going to be decision tree classifier, and parameters grid is going to be equal to the parameters grid. Here it is. So in the next step we are going to fit this into our data. We will use grid search tree.fit, and we will use scaled xtrain and ytrain. By the way, before fitting this, I'm going to tell you a thing that in tree-based models like decision tree or random forest, you don't need to scale your data. Like, you can just remove the scale thing in here, but it has no harm, so I'm just going to do it like this. So we passed a lot of parameters inside, so let's just check the grid search tree dot best parameters, and here are our best parameters. Then what we are going to do is we will say predictions is going to be equal to the grid search tree dot predict scaled. Also in the test side you don't need to use the scaled values, because in the tree models you don't need that. We will say model performance, and we will get the predictions. It's 0.9. Go right. Actually, our logistic and a support vector machines model are the winners by far. Okay, let's train a random forest model. For that, I will say from Scikit-learn.ensemble import random forest classifier. Then I will say random forest classifier model is going to be equal to the random forest classifier. I'm going to initialize this, and for the parameters grid side, I'm just going to define them outside right now. I will say number of estimators is going to be equal to the 32, 64, 128, and 256. And I will say maximum features is going to be 2, 3, 4. And I will say bootstrap is going to be true or false booleans. And for the OB score, I will say true and false. Okay, now we can define our parameters grid RFC. We will say, actually it's going to be much easier from others because we are defining outside of the dictionary. I will say number of estimators, and I will just use number of estimators we created. Then I will say maximum features, and I'm just going to use the maximum features we created. Also for the bootstrap, I'm going to do the same. I need to say bootstrap, and for the OB score, I'm going to do the same. You can also do it like this, and I will say grid and the first classifier. I will say grid search cross validation, and I will do RFC model, and I will give the parameters grid RFC. And the next thing I'm going to do is I'm going to fit it to our data. Actually, I made a typo. I need underscore in here. And now I'm going to fit this like grid rfc.fit, and I will use the scaled xtrain. Actually, I'm telling you that again, this is a tree-based model and you don't need to scale your x, but I'm going to do that. and here it is. Okay, let's see the best performing parameters, like let's say grid rfc.best parameters. And for the bootstrap we have the true, for the maximum features we have 3, for the number of estimators 64, and all be scored true. Great. So what we can do now is we will say predictions rfc, and we will use grid rfc.predict, and we will say scaled x-test. Actually there's a problem. Grid underscore rfc, we need to do it like this, and I'm going to call our model results model performance function, and I will say preds rfc. Actually this is also 0.9. Okay, let's apply some boosting methods. Actually I'm going to train two last models, like I will use AdaBoost and XGBoost, then I'm going to finish this video. So let's start with the AdaBoost. I will say from Scikit-learn.ensemble import AdaBoost. Actually this is also a tree based model, so you can do it without scaling. I will initialize this, then I will say Ada parameter grid, and I will do number of estimators is going to be 50. Actually I need to open a list, 50, 100 and 200. Then I will say learning rate, and I will say 0.01 and 0.1, then 1 and 10. And let's say Ada grid search, and we will say grid search cross validation. Then we will do Ada classifier, Ada parameters grid. Then let's set the cross validation as 2. And we are going to fit this right now into our data. Fit scaled. Actually you don't need to use scaling again. By train, and when it's trained, let's do some predictions with that. Ada pred is going to be equal to the Ada grid search.predict scaled x-test, and let's get our model performance like Ada pred. Here it is. It performs same with logistic and support vector machines. Great. For the last step we are going to train an XGBoost, and I want this to be winner, so I'm going to give a lot of parameters for this, and I'm going to do like from XGBoost import XGBoost classifier, then I will say XGBoost classifier, and it's going to be initialized like this. Then let's define a parameters grid like XGBoost parameters grid, and we will say number of estimators, let's give like 20, 40, 60, 80, 100, 500, 1000, 2000 and 5000. And let's give learning rates like 0.01 and 0.1, 0.2, 0.3, 0.5, 1, and actually it's enough. Let's also give 0.7 in here. And for the max depth, let's give max depth, let's give like 1, 3, 4, 5, 7. Actually I missed 4 in here, 7 and 9. I think it's enough. Okay, I'm also going to set cross validation high this time. I will say XGBoost grid search, and I will call grid search cross validation. Then I will say XGBoost classifier, XGBoost parameters grid, and let's set cross validation as like 8. And let's fit this into our data. I will say XGBoost class grid search that fit scaled x train and y train, and when it's trained I'm going to be right in here. So like there is 12 minutes past and it's not going to be finished soon, so I'm just going to remove some of these. Like I'm going to delete this one, I'm going to delete this one, I'm going to delete this also. I'm going to delete this one. Let's just forget about training a big model because it's not ending soon. So I'm just going to change the cross-validation as 3 and I'm going to rerun this. And I think now it's going to be trained much faster and we are going to get the results quicker. So I will say fit again and I'm going to be in here when it's trained. So here we have our model and let's say XGBoost predictions and we will use XGBoost grid search that predict scaled X-test. Also, before seeing its performance, let's just check the best performing parameters like best parameters. And here we have the 0.05 in learning rate, 4 in max depth, and 60 in the number of estimators. So let's get the model performance. For the last time for this video, we will say XGBoost predictions, and it's same with the logistic and the support vector machines. I'm not sure if it's going to change when we train this big model like with the 8 cross validation, but here we got a good result. This is a good accuracy score, and it was all for this video. Thanks for watching the video. I'm sharing 2 or 3 new videos every week about data science and Python programming. You can subscribe to my channel for more videos like this. I have a playlist named Data Science Projects where I have more than 20 data science projects with their datasets on that playlist. You can just reach to it from the cards of this video or the link in the description. See you in the next tutorial. Have a great day.